Good morning and welcome back to day two of our Developer Festival. It's a gorgeous morning here at the Shoreline Amphitheater.
chrome, build a castle to hold. 'Cause you build me up, oh, 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 and you never let go. Oh, 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 yeah, you build me up, oh, 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 and you never let it go. There will be a reckoning. Everything on its knees. All the world will sing in the sunshine of the spring. You and me will be the top of everything. I build you up when you think you're alone, and no one picks up the phone. Forgot skin and bones. Oh, yeah, I take you home, fill your body with chrome, build a castle to hold. 'Cause you build me up, oh, 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 and you never let go. Oh, 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 yeah, you build me up, oh, 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 and you never let it go. I build you up when you think you're alone, and no one picks up the phone. Forgot skin and bones. Oh, yeah, I take you home, fill your body with chrome, build a castle to hold. 'Cause you build me up, oh, 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 and you never let go. Oh, 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 yeah, you build me up, oh, 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 and you never let it go.
Welcome. Thank you for joining. Our session will begin soon.
Out of sight, out of mind. I don't mind going days without seeing your face. Sure enough, there you go. We seem to be stuck at the hip. Don't you know what you do to my heart when everything seems to be falling
guys. Good morning. All right. So we're going to cover what's new in Chrome DevTools. And we're going to be capturing what's been going on from the Chrome DevTools team in the past years, the features and functionality, all the new stuff. Jason?
Just says joke. Should have removed that slide.
OK. We're going to be covering a few different things. We're going to go through authoring, accessibility, performance, and JavaScript, kind of capturing different feature areas of the DevTools. And to kick things off, we want to look at authoring. So in authoring, this is really the experience of us crafting a nice user experience for everyone who's enjoying our web content. And this is creating a nice feel, a nice look. And there's a few different ways to do this, right? I can, first possible way is kind of the classic, the reliable way. I work in my editor, I load it up, I tweak things in DevTools, copy paste what I like, bring it back to my editor, save and refresh. Kind of that old save and refresh cycle. Good, reliable, always there. Now, previous IOs, we've also talked about workspaces. This is a way where you take your entire project, like your Git checkout, essentially, drag it into DevTools, and DevTools can now work with that, save to disk, and you have access to the entire folder there, and really makes for a fast iteration cycle.
Right.
Now, this is great if it's your project. But there's also this other case of, I want to make changes, and I don't necessarily have like a Git checkout of it, but I still want to try things out. And that's what local overrides is about. So, like, Jason, if you wanted to make changes on paulirish.com.
Right, if I wanted to deface your header or whatever.
Sure, OK.
Yeah.
But, I mean, so far you do not have Git access, and so that works for me. Yeah. But local overrides would work for your defacement.
Right.
So there you go. I'm going to show a little bit of how this works in actuality. So let's switch over to my screen for a moment. So we have here the Google I/O extended site. Nice little page. But I feel like making some changes. And it's not my site, but I figure, why not? All right, so first thing is we go head over to Sources panel. And in this little drop down, we go to Overrides. The first thing that we have to do just once is set this up. So we just need to select off folder for overrides. So I'm just going to go right in here. And you just need to put this someplace on disk, really anywhere. And we're going to be using the disk to kind of back all these changes. So once you select, you click Allow so that DevTools has permission to work with this, this folder.
It only gets permission inside that folder, not root?
Yeah, yeah. So, all right, so I think that's all good. And now, well, let's make some changes. So this guy right here, actually, I figure a background, maybe?
Yeah. Yeah, something nice.
Let's go with
hot pink.
Hot pink is a good choice. I like hot pink. Let's try that out.
Oh.
So hot pink.
Hot pink. Ooh, there it is.
That is classy.
That's
Maybe
nice.
some padding though. It probably needs padding.
Yeah, there's some padding up.
All right. Let's give that a shot.
Pretty.
Now, I don't know if you saw that. Let me just do that again. Refresh. Ooh. Sticking around post-refresh. I like that. I like that. Now, the cool thing here is that I can make changes to kind of anything. Say, for instance, this text beneath here. Developers hosted 534 extended viewing parties. Cool. I think that number needs a little bit of an upgrade. I don't know exactly where this text is. It could be in a JavaScript file, maybe the HTML. But let's go find it. So I'm just going to select and copy that. And we want to find it. So Command-Shift-P brings up this little command palette.
Right.
Nice. And I'm going to show search. This is going to search across all the files that are loaded into the page. And OK, yeah, so here we have just the HTML. All right, easy enough. So we can just make a change to that over 9,000. Good. We hit Control-S, and you can see this little purple. And this is telling me that this is linked. This file is linked to the network file. And so I have the one on disk and the network. And this also means if I right-click this and open it, this is just, this HTML file that I just changed is just a regular old file on disk. I can drag this into my text editor and make any changes there, and then they'll instantly be reflected if I just refresh. Over 9,000.
There you go.
Nice.
Pretty nice.
So this enables a lot of really cool things, and you can make nice changes, prototype things out, go wild. If you get to a point where you're like, okay, made some changes, they feel good, but what were they all again? There's another little pane that you can access to just summarize everything that's happened. Again, you can use Command-Shift-P, or you could just open up the little menu down here at the bottom and go to Changes. And the Changes view was just going to tell you what changed. Now, in this case, it's minified CSS, so it's not entirely useful to look at the diff. But then again, I could always open up this file and pretty print it. And at that point, that's one way to do it.
Yeah.
All right. Let's go back to the slides. All right. So you saw it in my demo, search across all files. And we've been looking at other places to surface more content via search.
Yeah, so one of the ways that we're doing that is through improvements to the network search. So in the network tab, we've had search for a while. It's just like a bar that shows up at the bottom. And that bar is only searching URLs. So it's useful, if you're looking for something that's in the URL, but not quite so useful if you're looking for something that isn't in the URL. So now there's a new icon in here, and also shortcut Control F.
Yeah, Control F, Command F.
Yeah. And that's going to pull up a new search sidebar. Search sidebar searches through headers and their values in addition to all those other pieces of information. So this is really useful. Let's say I wanted to search for cache control headers. Cache control headers are going to tell me whether the browser is going to cache stuff locally or not, and it'd be good to get kind of an overview of what we're sending down. So if I hit enter on this, it'll show me an aggregated list of all of the cache control headers that's sent down. And you can click them in the left. You can see the details of those on the right. It's very nice. And there's still the familiar controls in the header for case-sensitive search, regex-based search. This is really useful if you want to search for authorization headers to know which of your requests are authenticated, cookies.
Yeah.
There's lots of great use cases for them.
Have you had like specific domains and you're looking up what CSP headers, references to domains, stuff like that?
Right.
It's powerful stuff.
Yeah, so we're trying to show you kind of an at-a-glance overview in this interface. And there's other places in DevTools where we have kind of similar problems here, like huge lists of CSS variables would be one example.
Yeah, variables. Raise your hand if you guys use CSS variables. Custom properties, good stuff.
Yeah,
I love them too. Yeah, we use them all the time on the Chrome DevTools themselves. And we've been looking at it and wondering, they could probably use some upgrades in the experience.
Right.
So there's a few things. So if you've seen some variables before, they might look a little bit something like this. We have a fail color, we have a warning color. Good. But then you're like, what was that again? So today, you'll see something a little bit different. You'll just see a little color swatch placed there. We recognize that this is referencing a color value, and so a little color swatch seems good. Easy enough. You can also just hover on that variable name, and the tooltip will resolve the actual value. Works with colors, works with anything, any custom property, really. But with colors, there was one more thing that's pretty cool. If you open up the color picker, down at the bottom is this kind of color palette. And this is the material design color palette. A lot of nice, tasteful choices of colors in there.
Yep.
But there are a few other palettes available. And a brand new one is CSS variables. So this is kind of cool. You click into this, and this is listing the CSS variables that apply to this element right here. So it's basically while there may be many, many variables in the page, these are only the variables that apply to this specific element via the cascade.
Right.
So that's kind of cool. So right now we're hovering over text link color, and if I select this, the cool thing is we apply var text link color instead of the resolved color value.
Cool.
So
it doesn't use the hex, it uses the actual variable when it injects it.
kind of like what you'd expect it to have.
That's pretty clever, yeah.
Now, when you choose colors, it's important you choose something that looks good, tasteful, but also accessible. You want to make sure that what you have is an accessible choice. And so we've introduced some features to make that a little bit easier. And we're going to walk through this little video where we explore that. So I'm looking at this page, and I want to tweak the foreground color of this text. So I bring up the color picker. And it says contrast ratio right there. It says it's not very good right now. But as I drag the color around, the contrast ratio is going to update. It's kind of cool. And if you open that section up, you'll now get this line in the color picker. And so on one side of the line is bad contrast. On the other side is good. And you get ratings beneath on what the current ratio is and if it meets WCAG, AA or AAA ratings. Now, it's currently trying to identify what the background color is, but there is a little color dropper there, a little eyedropper if you want to manually select your background color. So that's always an option.
Cool. Did I notice that you were editing your Lighthouse score with DevTools?
I was editing Lighthouse with DevTools. I wasn't editing my Lighthouse score, but the score, I mean, it could use some improvement. Yeah, I get what you're saying there.
Right. So speaking of Lighthouse,
Sure.
we should probably tell them about the new features we had in Lighthouse.
All right, sure.
Seems like a good idea. So last year at Google I/O, we announced that we were bringing Lighthouse into DevTools. And this was huge because it meant that everybody who had Chrome obviously has DevTools. Everybody who has DevTools, which is the Chrome users, now had Lighthouse. Nothing to install, no extensions, none of that business. So that's good. Now that kind of started us thinking, was there anything else we could do to kind of make Lighthouse more helpful to people? We're always thinking of that, but it moving into Chrome was sort of a turning point here. We want Lighthouse to act like a real lighthouse. We want it to kind of keep you away from the rocks and guide you towards other meaningful information that exists elsewhere in DevTools. So this year, I'm excited to announce that we are introducing some improvements that we hope will bridge the gap between Lighthouse and DevTools. And I'm just going to show you my favorite new feature of all time, which is View Trace. View Trace, to stretch the analogy to the point of breaking, lets you dig beneath the lighthouse. Yeah, we're looking at the foundation here.
Nice.
So Lighthouse records a trace of your application as it runs. It loads your application, reloads it, grabs a trace, which is going to be details about JavaScript, network stuff, all those kind of underlying pieces of information. We thought, why not let people dig into the trace? We have it. It's sitting there. And turns out this is a really nice way to kind of see why you got a Lighthouse score. So let's walk through this. So I'm on paulirish.com, one of my favorite websites. And I'm going to run a performance audit. We won't pummel them with the PWA audit, just the performance audit for now, for time reasons and whatnot. So behind the scenes, this is going to be reloading the page, gathering a trace, analyzing it, and coming up with a pretty page and a lovely score. I think there. Oh, yeah. So you get an 87.
Hey now.
Congrats. But you see now there is a View Trace button. And clicking this, it's actually going to take me right over into the Performance tab, and I can dig down into the trace that powered that Lighthouse score. And this is awesome because that trace was run on a emulated 3G network on a slow CPU emulation.
That's right.
And you can kind of figure out what exactly those audits were derived from. Let's say you had a critical request chain, for some CSS or something. And you could literally see that in the Performance tab, blocking the rest of your page rendering with screenshots. So to me, this is huge.
That's cool.
It's huge.
Now I'm looking at this, and you're kind of, in a way, you're calling me out. You're calling my site out, at least, for its performance. So I was wondering maybe we should spend a few minutes and see if we can improve the score.
I think we can improve the
on
score.
the site a little bit.
I think we can improve it.
We can make it faster. And to make it faster, let's bring back one of the features that we were talking about earlier, local overrides. So, okay, first up, let's reload the page, just capture a trace of the page load. All right, now, what we want to do is measure from the very beginning of the HTML load right there to when the web fonts finish loading. It's right about there.
2,000 seconds?
At the bottom, yeah, we can see it's 2,000 milliseconds total. All right, it takes a while. Now, in the green right there, WAF files. These are my web fonts, and there's a pretty big gap before they start loading in. That's no good. So we can fix this. This is a bit of code. I'm going to use resource timing API, some fancy stuff, copied it to clipboard. But really, I just want to get the WAF URLs. Now we're going to come over here and use local overrides. We paste them in. Again, yeah, some multiple cursors.
Just ignore the multiple cursors magic. This is Paul Irish video foo.
All right. Link rel preload with our fonts. And I think, yeah, that's Blink Rail preload. All
Now
right,
we're
we
in
got
preload
them
box.
loaded in. So again, 2,000 milliseconds before. Let's reload without local overrides changes. So we now are preloading. Did we preload?
Well, it's looking better.
Yeah. Yeah, the fonts are at the top, the green. Yeah, yeah, WAF 2. Yes, good.
Ooh.
And our total time is, yeah, 13.
It's a 33.33 repeating improvement.
That's
Very
not bad.
impressive.
That's pretty fast, too. Be able to make a change.
Very
just
impressive.
try it out and see what happens. So while we're talking about performance, there's a few other changes. So you might see something like this. If you're looking at a trace, you have the main thread. You may have iframes that are using site isolation, and those are going to be represented on a separate track. Also, any web workers, any service workers are positioned on different tracks. And the nice thing now is that as you select each track, the summary, the bottom up, the call tree, all that stuff at the bottom is going to be updating to reflect your track selection.
Very nice. It's sort of like a multi-process view.
Yeah, yeah.
I like it.
It's kind of cool, and it enables also another feature that I think is really powerful. So say, for instance, you're looking at a trace of your web app. And you see a flame chart like this. Now, in the flame chart, there's a lot of stuff going on. There's function names like complete work, create element, mount class instance. And you're like, yeah, mount class instance is taking time again.
Good old mount classes.
Great. What do we do about that?
Who knows?
Now, a number of JavaScript frameworks also use user timing to say when things started and ended. And usually this is very meaningful because it's talking about your components. When your components were mounted, when they were rendered. And so you can select the user timing track and now see that data summarized with the bottom up and the call tree details.
Very
This
nice.
is really great. Having this structural profiling data coming in via user timing saves time because otherwise you'd be writing all this like start and end like marks yourself. It's a big time sink to do all this. Here, DevTools is doing a lot of the heavy lifting for you.
All right, Paul, you mentioned syncs and lifting.
Yeah.
Right. So one of the things I wanted to cover is actually related to that, and it's async await.
A joke slide
Yeah.
in our presentation.
I think I was going to remove them before.
Probably should have.
This is the last one, though.
Good.
Yeah. Oh, no, there was two. There was two. Yeah.
A sync.
Or three.
Oh wait.
There's a couple.
Is that a self-diving car?
That's a self-diving car.
Good.
So anyway, what I was going to say is, it's 2018, and it's the year of async await. Cool. So, async await is kind of part of everyday JavaScript development at this point. Last year, we added the ability to step through async await in DevTools, right? Amazing. This year, we're taking things a few steps further. If you're not familiar with async await, it kind of looks like this. You have a wrapper function, very important, with the async keyword. Inside of the body of this function, you can use the await keyword to kind of wait on the return value of a promise. And it looks like synchronous code. This is all promise-based under the hood, and that's lovely. But it's going to kind of run line by line to you. This will run asynchronously when it actually gets invoked. This is fine, certainly fine for application development. But one place where this is actually kind of annoying is down in the console.
Yeah.
So we are happy to announce that today the console has gained support for top-level await.
No wrapper around it.
No wrapper, no shenanigans.
That's nice.
So I'll walk through an example to illustrate this. So in this case, I'm going to await the response from this fetch call, which is going to apparently connect to a GitHub API that I Googled, and it was the first result. So we're going to search for Workbox. We're going to stick that in res. Then we are going to await, no wrapper, no promises, the value of res.json, so this streamed JSON response. And you notice it just dumps it straight into the console. There's no undefined or promises here.
Promise pending.
Yeah, exactly. With the little, oh, you got to wait and then expand it, get the value. Yeah.
Nope.
Clever hacks. We don't need them anymore. And then finally, I'm going to use a little DevTools trick, which is $_.
Ooh,
Like
nice one.
bash,
Nice one.
this is the previous result from the console. So I can just do $_ items map them over the name, and now I have a list of the 30 most popular Workbox repositories.
Nice.
Yeah. So this is cool. So I've been able to step through line by line in sort of like a discoverable way, an async flow. And I haven't had to use any wrapper functions, haven't had to use promises, callbacks, none of that stuff. The console just kind of supports this out of the box.
Great.
The interesting thing is we're actually bringing this async first mentality to the rest of DevTools like the debugger. So one of the biggest changes you'll notice here is when stepping into async functions. Until now, if you stepped into an async function like a set timeout or whatever, we would pretty much just step over it, especially if it's a native.
Yep.
So let me show you what I mean. So in DevTools last year, this is what set timeout looked like. If I click step into on this set timeout call, step into next function call, I end up on line 7.
Step past it.
That doesn't seem super useful.
Doesn't seem like an into.
Right, that's not much of an into. Now in DevTools, if I click step into on set timeout, I fall into the function. I could step through the rest of the function. So it's kind of an async aware step into. This is just one type of async though. So a lot of people right now are spreading their work out by, spread the work out on the main thread, or the alternative is you push your work off the main thread into a background thread using a web worker, let's say. One of the hardest parts of web worker development is actually debugging them. These are separate threads.
It's a little painful, yeah.
It's painful. You're switching context in the debugger, going from one thread to another. The sidebar is changing. You have to wait for post-message calls to resolve, and you can't really do anything there. So we thought, what about making all that a little bit easier? Yeah. So now, let's say we have some main thread code, right? Running on the main thread, script tag, whatever. With new async aware step into, I can step into the worker creation.
Into the creation of the worker.
And it drops me off on the first line of the worker that I created.
Nice.
Yeah.
That's great. That's
So
hot.
we can step across a thread boundary in DevTools now. So this is really cool. And then you just continue on like normal. Another case would be, let's say I've created my worker. I've got this W variable with the worker in it. And I've got a breakpoint there. I can step into the post message call to the worker, and it will step across the thread boundary and into the worker. It will drop me off on the first line of my on-message
In the
handler in the
on-message.
worker. Yeah.
What about if in the post message from the worker back to the main thread, can we?
It's funny you should mention that. I actually have slides set up to show exactly that.
Oh,
so
really?
we could step into the post message call and get back to the main thread like there was no thread boundary at all, and it drops us off in the message handler. So this is super cool. It's almost like you're not debugging across a worker boundary at all.
Wow.
Yeah.
Wow, that's rad. All right. So before we finish up, I do want to bring it back to the console for a moment.
Gotcha.
There's some stuff going on in the console. In fact, in the console, there are a few functions that are available there and nowhere else. We call them the command line API, but there's some sneaky things. First up, I might have spotted before, copy method
Right.
in the console. Take anything you want, throw it to the copy method, it copies it to the clipboard. It's so nice, you pass it like an element, it'll give you the outer HTML, pass it, anything else, it'll just stringify it as JSON and copy that to the clipboard.
Yeah.
Nice, handy little thing.
I did not know that this existed.
It's been there like 7, 8 years, yeah.
Right.
But-
Longer than I've been alive.
But anyways, just to refamiliarize yourself. There are some other methods in there that have now just gotten an upgrade too. The debug method has been around. What you can do is you pass a function to it, and it will essentially pause right inside of the function that you passed. But now you can pass a native function. So document.querySelector being an example, and what happens is it'll actually pause right as soon as any JavaScript is about to use that native method. You could also do it with alert too if you want to find out who is alerting. Pause right there. Similar story with monitor. Different function. It doesn't pause, but instead it logs to the console the stack trace and also the arguments that are being passed in. So this you could say, tell me about all of the code that's using set timeout and what they're using it with.
So we would have seen in my previous example the function that I passed to it and all this stuff.
Exactly.
Beauty.
It's really nice. There's one more that's actually brand new, which is query objects. It's kind of cool, kind of tricky, so let's just start this out. We have a class. We create 2 instances of the class. The second one, we just add an extra property so it's unique. Now, later on, we're like, hey, query objects for foo. We pass back in that class. And we're going to get in the console an array of all of the instances of the class. In this case, it's pretty straightforward, but the really powerful thing here is that it is looking across the entire JavaScript heap and reporting back all of the instances that we know about. It's like taking a big heap memory snapshot and summarizing it down to just those things. Now, this is cool because it's not just what is currently available to JavaScript scope right now, it's the entire heap.
Yeah.
So you can look at, for instance, custom element constructors, or like, what are all my Canvas 2D contexts that are somewhere, and just get them dumped right here.
Nice.
Powerful stuff. Okay, I think that's it. So to wrap up, we covered authoring, accessibility, performance, JavaScript. And what I wanted to mention, always grab Chrome Canary.
Paul, didn't I see you like literally backstage before we came on adding slides to the end of our deck?
Right.
Is there something that you wanted to tell the
Yes,
good people of this room?
There was a little treat.
Oh God, are we getting a live demo?
I think so.
We're getting a live demo.
You guys want to see this? All right.
We're getting a live demo.
I got one more thing to share with you.
All right, sit down.
Okay. Jason, as you know, web platform evolves quickly. As it evolves, we as developers need to feel comfortable working with these new APIs, these new objects, and make sure that our code runs well against all of them. And the console is our home base for this exploration. It's where we start from. So we were thinking that the console could use some more power here. So we're introducing a brand new feature that we think revolutionizes how we work with the console. We call it Eager Evaluation. I'm going to give you guys a taste of it now.
Yeah.
Really, no other way to do it than with a demo. So let's switch over to my machine. All right, we'll just undock this and go full screen here.
Does anybody else know these commands, or is that just you?
Command-Shift-P.
Probably adds them as he needs.
Dock to right, undock. Those are my favorite ones. All right. So,
Today I learned.
all right, here in the console, I have a little line of code, right? We have a regular expression, and we're going to call exec on it. We're going to pass it a string.
There's a music joke in there.
All right, let's finish this off. Thanks. All right. Now, as I finish this expression, check out what happens. We get the result of this evaluation just positioned right beneath me. And I did not hit enter or anything.
What?
The cool thing here is, too, that this is going to update as I type. So if I come back and let's say, does this regex work if I have parens around the area code?
I'm gonna guess no.
Nope, no, doesn't. OK. Regex, a little brittle, could use some improvement. One thing I do see as far as improvements is this 0 to 9 character
yeah.
range.
Like a feature for this.
All right, we could use a digit instead. We do have multiple of these, so we could just multiple selection /D. And yeah, OK, good.
Still working?
Matches too, we're good. We're feeling nice about this. Now, one last thing, Jason, I want to do is I want to pull out the area code from this text.
You're sure this wasn't just a reason to show off your whole triple cursor thing?
So while we have these multiple cursors here,
Right.
ooh, I like that. What we're going to do is we just add some capture groups to the regular expression.
Right.
All right. All right. Boom, boom, boom. Yes, exactly. And so let's pull out the, is it 1? 1. Boom. All right. So in a few short moments, with not too much work, we managed to explore this API, find a bug, make an improvement, and get the result that we wanted. And this speed of iteration is really nice. No like going back in your history, changing that one thing. We just do it all live on the same line. Let's show another demo of this.
We should do a DOM demo.
DOM thing.
Yeah. You still have that page running in the background, I
Hi.
think.
Yeah. We're still connected to this page with the hot ping.
The guy never closes anything.
All right. How about, OK. We got links on this page, right?
Yeah.
Let's grab all of the link text on
Okay.
that page.
Like you're like a screen reader.
Yeah, like I'm a screen reader.
All Irish screen
Hey.
reader.
All right. OK, so what do we need? Query selector.
Query selector.
Okay.
Query selector all.
Query selector all. All right. Yeah, my bad. A tags. OK. We have them now. I don't know. We'll grab the text with like inner text or something. So we'll map over that. Map. Maps undefined. Maps undefined. Maps undefined. Node list. Node list.
It's a node list. It's
Right.
not an array.
Right. No map on node list. Okay. How do we change a node list to an array?
What's the newest, hottest way of doing this?
Audience participation? Suggestions? I like it. I like it. Yes. Let's do that. We'll
Can
do
we
an
go deeper?
array literal with spread.
Ooh.
Oh, yeah.
Oh.
Boom, ba, ba, ba.
Did that even work in Chrome? Who knows?
I love that. That's
Magic.
a nice one. All right. Now we got an array, right? Map's the thing. Map's the thing. All right, good.
Hey, there it is.
All right. So let's grab the inner text.
Your text.
Good.
Looking good.
Great.
Good.
Let's clean this up. Let's sort it, get it all nice and
That's a lot of white space.
wow. Okay. Let's get rid of that. The filter.
Let's hope they have title tags.
The classic one, the filter Boolean.
Boss
Boolean
filter.
constructor.
I like it.
Uh,
You still have some white space in
like,
there.
yeah. All right. Trim.
Trim that. Yeah.
Yeah, it's
Capital
trim.
T. Blah, blah, blah.
Trim. Nope. At least
You
I
having
get
some typing problems? Oh, it shows you the error below.
that is handy. Okay.
That's pretty
Fingers.
clever.
Go. Yes.
Hey,
Good. All
there
right.
it is.
All right. Nice.
Very nice.
So I was able to craft that, not mess up too much, and we got back.
Figure widget.
It'll work. All right.
Who knows what that's supposed to be?
Now, the really powerful thing here is that eager evaluation is done in a way that we can guarantee there are no side effects. And we did this by introducing a new mode in V8 where we attempt to evaluate code, but if we know it's about to cause a side effect that changes the outside state, your application, the page, other parts of the DOM, we just bail and stop doing that work.
I tried for like an hour to break it. You can't.
No.
I'm going to try more, though.
The other nice thing is that eager evaluation, in addition to kind of giving you this result right underneath what you're typing in the console, enables some new completions in the console. So a completion is just, I type in document, I hit dot,
Oh,
and we see
Clojure UID.
Clojure UI.
My old friend.
Like we all do every time we see this.
Yeah.
Well, this is on this page anyways. But there's some tricky things here. Completions normally, as soon as you introduce like some parens, you are calling like a method.
Right.
Completions never continue to work. You just have to figure it out on yourself. But now we can try eager evaluation on that same string and power more completions. So to give you a show of how this kind of works, and Jason and I, as we've been
Oh, you're
rehearsing.
going to show off our thumb war stats.
Yeah.
Should we try and settle this right here?
Okay.
One,
been playing
two,
Thumb
three,
Wars.
4. I declare a thumb war. Bow.
And I've been keeping
Touch.
score. Touch. I'm going. All right, 5. We got 5 on Paul.
That's a tie.
You're done, man.
I like it.
And the nice thing is, I'm keeping this here, but we were thinking it would probably make more sense if we pulled this data down
Right.
from
We're going to put this up in a thumb war API.
thumbwarsStats.com/API.
Hosted by Firebase.
Yeah. Now, if we pulled that down, it would probably be a string, right?
It's
So
gonna be a
let's
string.
make this a string.
That's a bit opaque.
Yeah, and we need to turn it back into an object, right, guys? Right. So we'll just JSON parse
My
this.
namesake function.
All right.
The JSON parse.
Now, take a look. I'm just going to hit dot, and what's in my completions?
What?
Jason and Paul.
We have a cameo in the console dropdown?
Yeah, check us out. We look good up there. So the cool thing here is, this is being evaluated under the hood, and it was determined to have no side effects, so now the completions are upgraded.
That's rad.
Really powerful stuff. This is just a taste of some of the things you'll be seeing. You try this out yourself. What you can do is grab today's Chrome Canary, pop into the console settings right up here, and you'll turn on eager evaluation. It will enable all this stuff that I was just covering. All right, Jason, I think that's it. Let's go back to the slides. Do we have anything else?
No,
I don't think we do.
I think we're good.
All right,
I think that's
thank
it.
you guys very much. Appreciate it.
Thanks, everybody.
Good morning and welcome back to day 2 of our Developer Festival. It's a gorgeous morning here at the Shoreline Amphitheater, the backyard of our Google Mountain View campus. During each of the session breaks will be our conversations with special guests like the visionary production designer for Black Panther and the astronomer who is using AI to uncover the origins of our solar system. We'll also take you to the sandbox for some playtime. And when we're not in the sandbox, we'll be taking you around the festival to enjoy everything that's happening here at Shoreline. During your first session break, I'll be speaking with Jeff Dean, head of AI at Google.
Toughen up, you're a slacker, gotta cut your hair. But you don't care about the next generation, don't care what your girlfriend says. We'll all dance to the new revelation. There's a shotgun. Everybody's talking about. Everybody's talking about.
All right. Hey folks, my name is Addy. This is Eva. We work on Chrome, and today we're going to give you a whirlwind tour of tips and let's get started.
The internet gets heavier and heavier every year. If we check in on the state of mobile web, we can see that a median page on mobile waits at about 1.5 megs, with majority of that being JavaScript and images. That's quite a lot. Apart from the sheer size, though, there are other reasons why a web page might feel sluggish and heavy. Third-party code, network latency, CPU limitations, parser blocking patterns, all of these contribute to the complicated performance puzzle. We've been pretty busy over past year trying to figure out how to fit this rich content of mobile web into the smallest package possible. In this talk, Adi and I are going to show you what you can do in this regard today, but also we'll take a peek into the future and give you a highlight of might be possible really, really soon.
So, I'm not the biggest fan of suitcases. The last time I was at the airport waiting at the baggage carousel for my bags, I looked around for my suitcase and all I could find was this. I too laughed the first 4 times this went around. I was really happy to get this back, I just wanted more of it. Now, the experience that I had at a baggage carousel is a lot like the experience our users have when they're waiting for a page to load. In fact, most users rate speed as being at the very top of the UX hierarchy of their needs. And this isn't too surprising, because you can't really do a whole lot until a page has finished loading. You can't derive value from the page, you can't admire its aesthetics. Now, we know that performance matters, but it can also sometimes feel like a secret, discovering where to start optimizing. And so we've been working on trying to make this problem a little easier for a while. And today, we have an exciting announcement to share with you. We like to call it a Paul Irish in your pocket.
Well, we're happy to announce a newly expanded set of web performance audits in Lighthouse. Lighthouse, as you know, is part of developer tools that allow you to make an audit of your website and also gives you hints on how to make it better. It's been around for a while, right? But as some of you have heard today in the morning, it's been also actively worked on. And today, I'm happy to share with you some of the newest audits that landed in Lighthouse over past quarters. We'll try to show them to you in action during the rest of the talk.
Oh, next one's yours.
As the internet saying goes, fixing web performance is as easy as drawing a horse, right? You just need to follow some steps carefully. But even though, well, there is some truth in the picture above, the good news is you can get pretty far by following some simple steps. In order to show you these steps, Adi prepared something special for you.
So, Eva and I are really big fans of Google Doodles. Google's been doing them since 1998, and we thought it'd be fun to create a nice little app where we can show you some of our favorite interactive doodles from over the years. We call it the Oodle Theater. Here it is in action. So we kick it off with a drive-thru, and as we can see, we can now start browsing through the application, looking at doodles over the years. We could click through to one and even start playing. We're not going to ruin the surprise. You can go and you can play some of these in your own time, just not during this talk, please. So, let's begin our journey into the wild west of web performance, and it all begins with one tool.
Of course, Lighthouse. The initial performance of our app, as you can see on this Lighthouse report, was pretty terrible. On a 3G network, the user needed to wait for 15 seconds for the first meaningful paint or for the app to get interactive. Lighthouse highlighted a ton of issues with our site, and the overall performance score of 23 mirrored exactly that. The page waited at about 3.4 megs. We desperately needed to cut some fat. This started our first performance challenge, find things that we can easily remove without affecting the overall performance experience. So what is the easiest thing to remove? Usually nothing. And by nothing, I mean things that do not really contribute to the code, like white space or comments. Lighthouse highlights this opportunity in the Minify CSS and Minify JavaScript audit. We were using Webpack for our build process, so in order to get minification, we simply used the Uglify.js plugin. Minification is a common task, so you should be able to find a ready-made solution for whichever build process you happen to use. Other useful audit in that space is enable text compression. There is no reason to send uncompressed files, and most of the CDNs support this out of the box these days. We were using Firebase hosting to host our code, and Firebase actually enables gzipping by default. So by the sheer virtue of hosting our code on a reasonable CDN, we got that for free. And while gzip is a very popular way of compressing, other mechanisms like Zopfli and Brotli are getting traction as well. Brotli enjoys support in most of the browsers these days, and you can use a binary to pre-compress your assets before sending them to the server. Okay, in these two ways, we made sure that our code is nice and compact and ready to be sent to the user. Our next task was to not send it twice if not necessary. The inefficient cache policy audit in Lighthouse helped us notice that we could be optimizing our caching strategies in order to achieve exactly that. By setting a max stage expiration header in our server, we made sure that on a repeated visit, the user can reuse the resources they have downloaded before. Ideally, you should aim at caching as many resources as securely possible for the longest possible period of time and provide validation tokens for efficient revalidation. All the changes we made so far were very straightforward, right? They required no code whatsoever. It was a really low-hanging fruit with very little risk of breaking anything. So remember, always minimize the code, preferably automating it with build tools by using the right CDNs or by adding optimization modules to your own servers. Always compress your assets and use efficient cache policies to optimize repeated visits. Okay, this way we removed the obvious parts of the unnecessary download. But what about the less obvious parts? For example, unused code. As it happens, unused code can really surprise us. It may linger in the dark corners of your code base, idle and long forgotten, and yet making it to the user's bandwidth each time the app is loaded. This happens especially if you work on your app for a longer period of time, your team or your dependencies change, and sometimes an orphan library gets left behind. That's exactly what happened to us. At the beginning, we were using Material Components library to quickly prototype our app. In time, we moved to a more custom look and feel, and of course, we forgot entirely about that library. Fortunately, the code coverage check helped us rediscover it in our bundle. You can check your code coverage stats in DevTools, both for the runtime as load time of your application. You can see the two big red stripes in the bottom screenshot. We had over 95% of our CSS unused, and a big bunch of JavaScript as well. Lighthouse also picked up this issue in the unused CSS rules audit. It showed a potential saving of over 400 kilobytes. So we got back to our code, and we kicked out both the JavaScript and CSS part of that library. This brought our CSS bundle down 20-fold, which is pretty good for a tiny 2-line long commit, right? Of course, it made our performance score go up, and also the time to interactive got much better. However, with changes like this, it's not enough to check your metrics and scores alone. Removing actual code is never risk-free, so you should always look out for potential regressions. Remember that our code was unused in 95%? Well, there's still this 5%, right? Apparently, one of our components was still using the styles from that library, the little arrows in the doodle slider. Because it was so small, though, we could just go and manually incorporate those styles back into the buttons. So if you remove code, just make sure you have a proper testing workflow in place to help you guard against potential visual regressions. So remember, code coverage both in DevTools and in Lighthouse is your friend when it comes to spotting and removing unused code. Do this check regularly throughout the development of your app to keep your code base clean and tidy and to test your changes thoroughly before deployment. Well, so far so good. All of those changes made our app a little bit lighter. It was still too slow to Adi, so he took it a bit farther. Adi, how did it go?
It went so good. Now, some web pages are like heavy suitcases. You have some stuff that's really important, and then you have crap and even more crap. We know that large resources can slow down web page loads. They can cost our users money, and they can have a big impact on their data plans. So it's really important to be mindful of this. Now, Lighthouse was able to detect that we had an issue with some of our network payloads using the enormous network payload audit. Here we saw that we had over 3 megs worth of code that was being shipped down, which is quite a lot, especially on mobile. At the very top of this list, Lighthouse highlighted that we had a JavaScript vendor bundle that was 2 megs of uncompressed code that we were trying to ship down. This is also a problem highlighted by Webpack. Now, what we say is that the fastest request is the one that's not made. Ideally, you should be measuring the value of every single asset you're serving down to your users, measuring the performance of those assets, and making a call on whether it's worth actually shipping down with the initial experience. Because sometimes these assets can be deferred or lazily loaded or processed during idle time. In our case, because we're dealing with a lot of JavaScript bundles, we were fortunate because the JavaScript community has a rich set of JavaScript bundle auditing tools. We started off with Webpack Bundle Analyzer, which informed us that we were including a dependency called Unicode, which was 1.6 megs of parsed JavaScript, so quite a lot. We then went over to our editor, and using the import cost plugin for Visual Code, we were able to visualize the cost of every module that we were importing. This allowed me to discover which component was including code that was referencing this module. We then switched over to another tool, Bundlephobia. This is a tool which allows you to enter in the name of any NPM package and actually see what its minified and gzip size is estimated to be. We found a nice alternative for the slug module we were using that only weighed 2.2 kilobytes, and so we switched that up. This had a big impact on our performance. Between this change and discovering other opportunities to trim down our JavaScript bundle size, we saved 2.1 megabytes of code. We saw 65% improvements overall once you factor in the gzipped and minified size of these bundles, and we just found that this was really worth doing as a process. So in general, try to eliminate unnecessary downloads in your sites and apps. In the case of the Oodle Theater, an app that already has games and a lot of interactive multimedia content, it's important for us to keep the application shell as lightweight as possible. We found that inventorying our assets and measuring their performance impact made a really big difference. So just make sure that you're auditing your assets fairly regularly. Now, although large network payloads can have a big impact over our app, there's another thing that can have a really big impact, and that is JavaScript. We all love JavaScript, but as we saw earlier, the median page includes a little bit too much of it. JavaScript is your most expensive asset. On mobile, if you're sending down large bundles of JavaScript, it can delay how soon your users are able to interact with your user interface components. That means they can be tapping on UI without anything meaningful actually happening. So it's important for us to understand why JavaScript costs so much. This is how a browser processes JavaScript. We first of all have to download that script. We have a JavaScript engine which then needs to parse that code, needs to compile it, and execute it. Now, these phases are something that don't take a whole lot of time on a high-end device like a desktop machine or a laptop, maybe even a high-end phone. But on a median mobile phone, this process can take anywhere between 5 and 10 times longer. This is what delays interactivity, so it's important for us to try trimming this down. Now, to help you discover these issues with your app, we introduced a new JavaScript boot-up time audit to Lighthouse. And in the case of the Oodle app, it told us that we had 1.8 seconds of time which was being spent in JavaScript boot-up. What was happening was that we were statically importing in all of our routes and components into one monolithic JavaScript bundle. One technique for working around this is using code splitting. So code splitting is this notion of instead of giving your users a whole pizza's worth of JavaScript, what if you only gave them one slice at a time as they needed it? Code splitting can be applied at a route level or a component level. It works great with React and React Loadable, Vue.js, Angular, Polymer, Preact, and multiple other libraries. So we incorporated code splitting into our application. We switched over from static imports to dynamic imports, allowing us to asynchronously lazy load code in as we needed it. And the impact this had was both shrinking down the size of our bundles, but also decreasing our JavaScript boot up time. Took it down to 0.78 seconds, making the app 56% faster. So in general, if you're building a JavaScript-heavy experience, be sure to only send code to the user that they need. Take advantage of concepts like code splitting, explore ideas like tree shaking, and check out this repo we have with a few ideas around how you can trim down your library size if you happen to be using Webpack. Now, as much as JavaScript can be an issue, we know that unoptimized images can also be a problem too. So over to Ewa to talk about optimizing images.
Images. Internet loves images, and so do we. In Oodle App, we're using them in the background, in the foreground, and pretty much everywhere. Unfortunately, Lighthouse was much less enthusiastic about it than we were. As a matter of fact, we failed on all 3 images-related audits. We forgot to optimize our images, we were not sizing them correctly, and also we could get some gain from using other image formats as well. So we started optimizing our images. For one-off optimization rounds, you can use visual tools like ImageOptim or XNConvert. A more automated approach is to add an image optimization step to your build process with libraries like, for example, ImageMin. This way, you make sure that also the images added in future get optimized automatically. Some CDNs, for example, Akamai, or third-party solutions like Cloudinary or Fastly, offer you a comprehensive image optimization solutions. So to save yourself some time and headache, you can simply host your images on those services. If you don't want to do that because of the cost or latency issues, projects like Thumbor or ImageFlow offer self-hosted alternatives. Here you can see a single image optimization outcome. Our background PNG was flagged in Webpack as big, and rightly so. After sizing it correctly to the viewport and running it through ImageOptim, we went down to 100 kilobytes, which is acceptable. Repeating this for multiple images on our site allowed us to bring down the overall page weight significantly. That was pretty easy for static images. But what about the animated content? As much as we all love GIFs, especially the ones with the cats in them, they can get really expensive. Surprisingly, the GIF format was never intended as an animation platform in the first place. Therefore, switching to more suitable video format offers you large savings in terms of the file size. In Oodle App, we were using a GIF you saw earlier as an intro sequence on the homepage. According to Lighthouse, we could be saving over 7 megabytes by switching to a more efficient video format. Our clip weighted about 7.3 megs, way too much for any reasonable website. So instead, we turned it into a video element with 2 source files, an MP4 and WebM, for wider browser support. Here you can see how we used FFmpeg tool to convert our animation GIF into the MP4 file. The WebM format offers you even larger savings, and for example, ImageOptim API can do such conversion for you. We managed to save over 80% of our overall weight thanks to this conversion. This brought us down to around 1 megabyte. Still, 1 megabyte is a large resource to push down the wire, especially for the user on a restricted bandwidth. Luckily, we could use Effective Type API to realize they're on a slow bandwidth and give them a much, much smaller JPEG instead. This interface uses the effective round-trip time and downlink values to estimate the network type the user is using. It simply returns a string, slow 2G, 2G, 3G, or 4G, So depending on this value, if the user is on below 4G, we could replace the video element with the image. It does remove a little bit from the experience, but at least the site is usable on a slow connection as well. Last but not least, there is a very common problem of off-screen images. Carousel, sliders, or really long pages often load images even though the user cannot see them on the page straight away. Lighthouse will flag this behavior in the off-screen images audit, and you can also see it for yourself in the network panel of DevTools. If you see a lot of images incoming while only few are visible on the page, it means that maybe you could consider lazy loading them instead. Lazy loading is not yet supported natively in the browser, so we have to use JavaScript to add this capability. Here you can see how we use lazy sizes to add lazy loading behavior to our UDL covers. Lazy sizes is smart because it does not only track the visibility changes of the element, but it also proactively prefetches elements that are near the view for the optimal user experience. It also offers an optional integration with the intersection observer, which gives you very efficient visibility lookups. As you can see, after this change, our images are being fetched on demand instead of straight away. OK, that's a lot of good stuff about images. So just remember, always optimize images before pushing them to the user. Use responsive images techniques to achieve the right size of the image. Use lighter formats wherever possible, especially for animated content. And finally, lazy load whatever is not immediately visible to the user. If you want to dig deeper into that topic, here's a present for you. A very handy and comprehensive guide written by Eddie. So you can access it at images.guide URL.
Cool. So let's talk about resources that are discovered and delivered late by the browser. Now, not every byte that's shipped down the wire to the browser has the same degree of importance, and the browser knows this. A lot of browsers have heuristics to decide what they should be fetching first. So sometimes they'll fetch CSS before images or scripts. Now, something that could be useful is us as authors of the page informing the browser what's actually really important to us. Thankfully, over the last couple of years, browser vendors have been adding a number of features to help us with this. So things like link rel pre-connect or preload or prefetch. These capabilities that were brought to the web platform help the browser fetch the right thing at the right time. And they can be a little bit more efficient than some of the custom loading logic-based approaches that are done using script instead. So let's see how Lighthouse actually guides us towards using some of these features effectively. So the first thing Lighthouse tells us to do is avoid multiple costly round trips to any origin. Now, in the case of the UDL app, we're actually heavily using Google Fonts. Whenever you drop in a Google Font style sheet into your page, it's going to connect up to 2 subdomains. And what Lighthouse is telling us is that if we were able to warm up that connection, we could save anywhere up to 300 milliseconds in our initial connection time. Now, taking advantage of link rel pre-connect, we can effectively mask that connection latency. Now, especially with something like Google Fonts, where our font face CSS is hosted on googleapis.com and our font resources are hosted on gstatic, this can have a really big impact. So we applied this optimization, and we shaved off a few hundred milliseconds. The next thing the Lighthouse suggests is that we preload key requests. Now, link rel preload is really powerful. It informs the browser that a resource is needed as part of the current navigation, and it tries to get the browser fetching it as soon as possible. Now, here Lighthouse is telling us that we should be going and preloading our key web font resources because we're loading into web fonts. Preloading in a web font looks like this. So specifying rel equals preload, you pass in as with a type of font, and then you specify the type of font you're trying to load in, such as WAF2. The impact this can have on your page is quite stark. So normally, without using link rel preload, if web fonts happen to be critical to your page, what the browser has to do is it first of all has to fetch your HTML, has to parse your CSS, and somewhere much later down the line, it'll finally go and fetch your web fonts. Using link rel preload, as soon as the browser has parsed your HTML, it can actually start fetching those web fonts much earlier on. In the case of our app, this was able to shave a second off the time it took for us to render text using our web fonts. Now, it's not quite that straightforward if you're going to try preloading fonts using Google Fonts. There is one gotcha. You see, the Google font URLs that we specify in our font faces in our style sheets happen to be something that the fonts team update fairly regularly. These URLs can expire or get updated on a regular frequency. And so what we would suggest to do if you want complete control of your font loading experience is to self-host your web fonts. This can be great because it gives you access to things like link rel preload. In our case, we found the tool Google Web Fonts Helper really useful in just helping us offline some of those web fonts and set them up locally. So check that tool out. Now, whether you're using web fonts as part of your critical resources or it happens to be JavaScript, try to help the browser deliver your critical resources as soon as possible. If you're connecting up to multiple origins that are critical, consider using link rel preconnect. If you have an asset for the current page that's really important, use link rel preload. We happen to have a good preload plugin available for Webpack. And if you have an asset for future navigation, consider using prefetch. This is something that has good support now in the latest version of Webpack, as well as preload. Now, we've got something special to share with you today. In addition to features like resource hints as well as preload, we've been working on a brand new experimental browser feature we're calling priority hints. This is a new feature that allows you to hint to the browser how important a resource is. It exposes a new attribute, importance, with the values low, high, or auto. This allows us to convey lowering the priority of less important resources such as non-critical styles, images, or fetch API calls to reduce contention. We can also boost the priority of more important things like our hero images. In the case of our Oodle app, this actually led to one practical place where we could optimize. So before we added lazy loading to our images, what the browser was doing is we had this image carousel with all of our doodles. And the browser was fetching all of the images at the very start of the carousel with a high priority early on. Unfortunately, it was the images in the middle of the carousel that were most important to the user. So what we did was we set the importance of those background images to very low, the foreground ones to very high, and what this had was a 2-second impact over slow 3G and how quickly we were able to fetch and render those images. So a nice positive experience. We're hoping to bring this feature to Canary in a few weeks, so keep an eye out for that. The next thing I want to talk about is typography. So typography is fundamental to good design. And if you're using web fonts, you ideally don't want to block rendering of your text, and you definitely don't want to show invisible text. We highlight this in Lighthouse now with the Avoid Invisible Text While Web Fonts Are Loading audit. If you load your web fonts using a font face block, you're letting the browser decide what to do if it takes a long time for that web font to fetch. Some browsers will wait for up to 3 seconds for this before falling back to a system font, and they'll eventually swap it out to the font once it's downloaded. We're trying to avoid this invisible text, so in this case, we wouldn't have been able to see this week's classic doodles if the web font had taken too long. Thankfully, with a new feature called Font Display, you actually get a lot more control over this process. Font Display helps you decide how web fonts will render or fall back based on how long it takes for them to swap. Now, in this case, we're using Font Display Swap. Swap gives the font face a 0-second block period and an infinite swap period. This means the browser is going to draw your text pretty immediately with a fallback font if the font takes a while to load. And it's going to swap it once the font face is available. In the case of our app, why this was great is that it allowed us to display some meaningful text very early on and transition over to the web font once it was ready. So in general, if you happen to be using web fonts, as a large percentage of the web does, have a good web font loading strategy in place. There are a lot of web platform features you can use to optimize your loading experience for fonts. And also check out Zach Leatherman's web font recipes repo, because it's really great. Next up is Eva to talk about render blocking scripts.
So displaying visible text as early as possible is really important, but we can go further than that. There are other parts of our application that we could push earlier in the download chain to provide at least some basic user experience a little bit earlier. Here on the Lighthouse timeline strip, you can see that during these first few seconds when all the resources are loading, the user cannot really see any content. Downloading and processing external style sheets is blocking our rendering process from making any progress. So what can we do about it? Well, we can try to optimize our critical rendering path by delivering some of the styles a bit earlier. If we extract the styles that are responsible for this initial render and inline them in our HTML, the browser is able to render them straight away without waiting for the external style sheets to arrive. In our case, we used an NPM module called Critical to inline our critical content in index.html during a build step. While this module did most of the heavy lifting for us, it was still a little bit tricky to get this working smoothly across different routes. The truth is, if you're not really careful or your site structure is really complex, it might be really difficult to introduce this type of pattern if you did not plan for app shell architecture from the beginning. This is why it's so important to take performance considerations early on. If you don't design for performance from the start, there is high chance you run into issues doing it later. In the end, our risk paid off. We managed to make it working, and the app started delivering content much earlier, improving our first meaningful paint time significantly. So to sum up, to unblock the rendering process, consider inlining critical styles in the head of your document and preloading or loading asynchronously the rest later on. For non-critical script, consider marking them with a defer attribute or lazy load them later during the app lifecycle. Okay, so that's the whole story of how we drew the horse and tried to put it in a suitcase. So let's take a look at the outcome. This is how our app loaded on a median mobile device on a 3G network, before and after the optimization. That's a pretty nice progress. All of this progress was fueled by us continuously checking and following the Lighthouse report. All of the hints you've seen today are linked in the Lighthouse tool so that you can check them in the context of your own application. If you would like to check out how we technically implemented all of the changes, feel free to take a look at our repo, especially at the PRs that landed there. The performance score went up from 23 to 91. That's pretty nice, right? However, our goal was never to make Lighthouse happy. We wanted to make the user happy. And high-level metrics included in the report, like time to interactive or perceptual speed index, are a good proxy for improved user experience. Also, the snapshots timeline gives you a nice visual feedback about how much shorter the waiting time for our app became. This is the full story of Little Oodle app. Now, let's take a look at some much bigger businesses.
So Eva and I had the benefit of being able to think about performance very early on. But how does this apply at scale to much larger businesses? Well, let's take a look at Nikkei. Nikkei are Japan's largest media company. They have a site that's got 450 million users that are accessing it, and they spent a lot of time optimizing their old mobile site, turning it into a new PWA. The impact of performance optimizations was huge. They were able to get 14 seconds faster on interactivity. They saw a 230% increase in their organic traffic, 58% increase in conversion rates, and their daily active users and page views also went up. But what did they actually do to optimize their performance? Well, if we take a look at the full list of things that Nikkei did, they'll look a little bit familiar. That's because many of these are things that we covered today. Nikkei did things like optimize their JavaScript bundles. They were able to shrink them down by 43%. One big change they made was they actually used Webpack to optimize the performance of their third-party scripts in addition to their first-party ones. They were able to use link rel prefetch on their daily edition pages, improving next page performance loading by 75%. In addition to this, they also took advantage of the tip that Eva was just walking through, critical path CSS optimizations. This is that optimization where you're sending down 14 kilobytes worth of content in your first round trip, and if you're able to squeeze in enough of your critical styles in there, you can actually improve first meaningful paint by quite a lot. So here, they were able to shave off a second of their first meaningful paint by taking advantage of this optimization. And finally, on Nikkei, they took advantage of the purple pattern. Now, purple is a pattern that was first discovered by the Polymer team a few years ago, and it stands for push, render, precache, and lazy load. So what Nikkei are doing is that they're pushing their critical resources using link rel preload and server push. They're rendering their main article content quite quickly. They're pre-caching their top stories using Service Worker, so this gives them offline access to read articles as well. And they're lazy loading code. So they're lazy loading code, and they're also using skeleton screens to improve the perceived performance of these pages. So we talked about how performance can help businesses to give users a better experience. But on users, we have one more thing that we think could help with the future.
Well, as you've heard during the keynote, we believe that machine learning represents an exciting opportunity for future in many areas. So what if we could take these two worlds of machine learning and web performance and blend them together? Maybe it could lead us to some really, really interesting solutions. Today, we want to tell you about our experience with machine learning and explain why we think it has a large potential. Here's an idea that we hope will spark more experimentation in the future, that real data can really guide the user experiences we're creating. Today, we make a lot of arbitrary decisions about what the user might want or need, and therefore what is being worth being prefetched or preloaded or precached. If we guess right, we are able to prioritize a small amount of resources, but it's really hard to scale it to the whole website. At the same time, we have a wealth of data about typical user behavior readily available. So Adi, how can we use that data?
So we actually have data available to better inform our optimizations today. Using the Google Analytics reporting API, we can take a look at the next top page and exit percentages for any URL on our site. In fact, we have a little tool for this that anybody can check out. Here it is for developers.google.com/web. And as we can see here, a lot of the users that land on the Chrome DevTools documentation actually end up going over to Lighthouse. So we could potentially prefetch that page. Folks that land up on the PWA docs will usually check out the PWA checklist. And we could use this data to improve our page load performance. This gives us the notion of data-driven loading for improving the performance of websites. But there is one piece missing here. Having a good probability model is important because we don't want to waste our users' data by aggressively over-prefetching content. We can take advantage of that Google Analytics data and use machine learning and models like Markov chains or neural networks in order to implement such probability models. This is a lot less subjective and error-prone than manually deciding what we should be prefetching or preloading for our sites. We can then wire this all up using link rel prefetch inside of our sites so that as the user browses through the site, we're able to actually fetch and cache things that they need ahead of time, improving our page load performance. Now, we can actually go further than this. Earlier, we talked about code splitting and lazy loading, but in a single page app, we're often dealing with routes, chunks, and a bundler. So instead of just prefetching pages, we could actually go more granular. What if we could prefetch individual resources for a page or a number of pages? Well, across all these ideas, we've been focused on trying to make some of these a little bit more low friction for web developers to adopt. And so today, we're happy to announce a new initiative we're calling Guess.js. Guess.js is a project focused on data-driven user experiences for the web. We hope that it's going to inspire exploration of using data to improve web performance and go beyond that. It's all open source and available on GitHub today. This was built in collaboration with the open source community by Minko Geshev, Kyle Matthews from Gatsby, Katie Hampenius, and a number of others. So let's take a look at what Guess.js provides us out of the box. The first thing it provides us is a Google Analytics module for analyzing our user navigations. It has a parser for popular frameworks, allowing us to map those URLs back to your framework's router. We then have a comprehensive Webpack plugin that's able to do machine learning training on some of that data to determine all of our probabilities. We're able to bundle the JavaScript for your routes and chunks with the potential for future clustering of those chunks. And we then are able to wire it all together for you so that we can prefetch those chunks of JavaScript as the user navigates through the site. We've also got experimental support for applying these concepts to static sites. Now, that's enough talk. What about showing you how this works in practice? So here we have a demo of Guess.js in action. What we're first going to do is we're going to load up our app. We're in the DevTools. We're in low-end mobile emulation over slow 3G. This app's rendered very quickly. And what we can see in the network panel is a number of routes that have already started to be prefetched because we have high confidence they're going to be used. We can toggle on a visualization of this. So in pink, we have pages we have high confidence the user's going to want. In green, we have low confidence, and in yellow, we have mild confidence. We can actually start to navigate through this application. So let's say we go to cheese. We can visualize this again. We can see that cheesecake is a page that users will often navigate to. As you can see, it loaded instantly because it's already in the user's cache by the time that they go to it. Contextually, we're able to display to you in this demo all the visualizations of confidence levels we have for different pages as we navigate through the site. Even this last page, the custard, loaded really, really quickly using these techniques. Now, prefetching is a great idea in practice, but we want it to be mindful of users' data plans. And this is where we use navigator.connection.effective-type to make sure that we're only prefetching things when we think that your connection can handle it. So this is our demo of Guest.js using Gatsby. By the way, this also happens to be a PWA with a great performance score, so thank you to both Minko and Kyle for helping with this. Check out Guest.js, let us know what you think. So today we talked about quite a few things, but at the end of the day, performance is about inclusivity. It's about people. It's about all of us. We've all experienced slow page loads on the go, but we've gotten an opportunity today to consider trying to give our users more delightful experiences that load really, really quickly. So we hope that you took something away from this talk. Remember that improving performance is a journey. Lots of small changes can lead to really big gains. So check out some of the things we talked about today. Talk to us in the web sandbox if you've got any questions. That's it from us. Thank you.
The sun
Hello and welcome to I/O Live. I'm Timothy Jordan, and I'm standing here with Jeff Dean, the head of AI at Google.
Hi, Tim. Thanks.
Hi, Jeff. All right, let's start with a background of Google's work in AI.
So we've been using machine learning and AI for the last 20 years in some of our products, but in the last 5 or 6 years, we've really sort of dramatically accelerated our use of machine learning and AI into more and more of our products. We've really used it to make our products more intelligent, to make them sort of more accessible, to really improve the product and build products that we couldn't build any other way.
What's new with the technology that we're making available, say, the last year and at I/O?
In the last year, for example, we've made really great strides in improving TensorFlow, our open source machine learning system. One of the things I'm really excited about is the TensorFlow.js release, which essentially allows TensorFlow programs to be run in the browser just as normal web pages with sort of machine learning embedded code in them. And it's really easy for people to create really interesting new machine learning applications and then people to run them by just loading up a web page. It's pretty fantastic.
And TPUs?
So we announced the third version of our TPU processor line. It's custom machine learning accelerators. The TPU V3 is really, really exciting. It's quite hot, so it actually is our first liquid-cooled processor that's in our data center. And the pods are actually larger scale than the TPU pods that we announced last year, so they're 8 times as powerful, more than 100 petaflops of compute, which is just an unbelievable amount of compute. And the really exciting thing is that allows us to make sort of more accurate models, machine learning models that can train on more data, that can train more powerful and more accurate models, and then we can use that to improve our products.
I think one of the things that makes me most excited about the technology that we're making available, it's that whole spectrum. All the way from TensorFlow JS, which is a very accessible way to get into machine learning, and AutoML, all the way up to TPUs, so like our advanced users have all that compute to do cool stuff with.
Yeah, I mean, I think there's going to be a lot of different levels of expertise and experience in using machine learning, and we want to make all of them able to use machine learning to improve their products and lives.
All right, so let's talk about what people are doing with machine learning as we're getting there. What are some things that people are doing in the world with machine learning that you're the most excited about?
Yeah, so there's like lots of different applications. One that I'm really passionate about is the use of machine learning to improve healthcare. I think there's a real opportunity there for both kind of medical imaging related problems. We've been doing a lot of work on diabetic retinopathy and other kinds of medical imaging problems, but also in how patients' lives are affected, how doctors are able to care for patients with making better decisions. A lot of advances there. It's going to be great.
Okay, so there's these big problems that we're tackling with machine learning. What about everyday problems? Is there something that you encounter every day that you would love somebody to apply AI to?
Yeah, I mean, I think as you start to have a machine learning lens as you walk around the world, you can see things that could be better. For example, when I pull up to a stoplight and it's red and there's no cars coming the other direction, that's just silly, right? We should have computer vision based stoplights that just allow people to go when it's safe to go. And that would be like a simple improvement in the world that would improve lots of people's lives.
Thanks for joining me.
Thank you.
And thank you for watching I/O Live. To learn more about what Google is doing in AI and ML, head on over to google.ai. And to catch more videos like this, head on over to g.co/io/guide.
Cassava is a really important crop. It provides for over 500 million Africans every day.
When all other crops fail, farmers know that they could rely on their cassava plants to provide them food.
There are several diseases that affect cassava, and these diseases make the roots unedible. It is very crucial to actually control and manage these diseases.
So we're trying to use machine learning to respond to those diseases.
And TensorFlow is the best foundation for our solutions. The app that we've designed can diagnose multiple diseases. It's called Nuru, Swahili for light, the light that farmers can use to see their problems and find solutions. You wave your phone over a specific leaf, look at it, and if it has a symptom, a box will pop up saying you have this problem. When you get a diagnosis, we have an option for you to get advice and learn about the best management practices.
The object detection that we use through TensorFlow relies upon our team annotating images.
We've collected over 5,000 high-quality images of different cassava diseases for this project. We use a single-shot detector model on a mobile net architecture. It's able to make predictions in less than 1 second.
Instead of having to implement thousands of lines of code, TensorFlow provides a library of functions that allow us to build architectures in much less time.
We need something that can be deployed on a phone without any connection. TensorFlow is able to shrink these neural networks to be able to fit on your mobile device.
The human input is absolutely critical. We're really building something that augments your experience and makes you better at your job.
So with AI tools and machine learning, you can improve the yields, you can protect your crops, and you can have a much more reliable source of food.
AI offers the prospect to fundamentally transform the life of hundreds of millions of farmers around the world.
You can see a product that can actually make someone's life better. This is kind of revolutionary.
So the whole point of the AIY projects team at Google is to build artificial intelligence kits that let makers take the cool parts of Google Intelligence and put them into their builds. Last year we released the voice kit, Train Fast, which was a kit that lets you record your voice and analyze it and get the text back from what you said. This year we're releasing the Vision Kit. It does not need an internet connection. It does not need the cloud. You program it with the neural network model, and the kit then gives you back data on what it sees. So if I give it a face, the light will come on, and then as I get happier, the light will change from blue to yellow. So this is our MobileNets neural network. This is an object classifier, and it's got 1,000 different common objects in it. We have a banana, and let's see, a screwdriver. Yeah, it's got that pretty good. It's got an apple, not just an apple, it's got the type of apple as well. And even water bottle, which is tricky because it is a clear thing, so it's not really a thing, it's just reflecting other things. So learning how to use these things and how to make it detect what you want to detect is going to be part of the fun. Our face detector code tells us not only that there is a face in the image, but it also tells us where the face is. It gives us the geometry about the face. So we can use that to build a tracker that can follow me wherever I go. We've shown you face detection, object recognition, and face tracking with the Google AIY Vision Kit. But this is just the beginning. Click on the link below to learn more. We're really looking forward to seeing what you build with this kit.
Hello and welcome to I/O Live. I'm Timothy Jordan, and I'm standing here with Jeff Dean, the head of AI at Google.
Hi, Tim. Thanks.
Hi, Jeff. All right, let's start with a background of Google's work in AI.
So we've been using machine learning and AI for the last 20 years in some of our products, but in the last 5 or 6 years, we've really sort of dramatically accelerated our use of machine learning and AI into more and more of our products. We've really used it to make our products more intelligent, to make them sort of more accessible, to really improve the product and build products that we couldn't build any other way.
What's new with the technology that we're making available, say, the last year and at I/O?
In the last year, for example, we've made really great strides in improving TensorFlow, our open source machine learning system. One of the things I'm really excited about is the TensorFlow.js release, which essentially allows TensorFlow programs to be run in the browser just as normal web pages with sort of machine learning embedded code in them. And it's really easy for people to create really interesting new machine learning applications and then people to run them by just loading up a web page. It's pretty fantastic.
And TPUs?
So we announced the third version of our TPU processor line. It's custom machine learning accelerators. The TPU V3 is really, really exciting. It's quite hot. So it actually is our first liquid-cooled processor that's in our data center. And the pods are actually larger scale than the TPU pods that we announced last year. So they're 8 times as powerful, more than 100 petaflops of compute, which is just an unbelievable amount of compute. And the really exciting thing is that allows us to make sort of more accurate models, machine learning models that can train on more data, that can train more powerful and more accurate models, and then we can use that to improve our products.
I think one of the things that makes me most excited about the technology that we're making available, it's that whole spectrum. All the way from TensorFlow.js, which is a very accessible way to get into machine learning, and AutoML, all the way up to TPUs, so like our advanced users have all that compute to do cool stuff with.
Yeah, I mean, I think there's going to be a lot of different levels of expertise and experience in using machine learning. We want to make all of them able to use machine learning to improve their products and lives.
All right, so let's talk about what people are doing with machine learning, because we're getting there. What are some things that people are doing in the world with machine learning that you're the most excited about?
Yeah, so there's like lots of different applications. One that I'm really passionate about is the use of machine learning to improve healthcare. I think there's a real opportunity there for both kind of medical imaging related problems. We've been doing a lot of work on diabetic retinopathy and other kinds of medical imaging problems, but also in how patients' lives are affected, how doctors are able to care for patients with making better decisions. A lot of advances there. It's going to be great.
Okay, so there's these big problems that we're tackling with machine learning. What about everyday problems? Is there something that you encounter every day that you would love somebody to apply AI to?
Yeah, I mean, I think as you start to have a machine learning lens as you walk around the world, you can see things that could be better. For example, when I pull up to a stoplight and it's red and there's no cars coming the other direction, that's just silly, right? We should have computer vision based stoplights that just allow people to go when it's safe to go. And that would be like a simple improvement in the world that would improve lots of people's lives.
Thanks for joining me.
Thank you.
And thank you for watching I/O Live. To learn more about what Google is doing in AI and ML, head on over to google.ai. And to catch more videos like this, head on over to g.co/io/guide.
Cassava is a really important crop. It provides for over 500 million Africans every day.
When all other crops fail, farmers know that they could rely on their cassava plants to provide them food.
There are several diseases that affect cassava, and these diseases make the roots unedible. It is very crucial to actually control and manage these diseases.
So we're trying to use machine learning to respond to those diseases.
And TensorFlow is the best foundation for our solutions. The app that we've designed can diagnose multiple diseases. It's called Nuru, Swahili for light, the light that farmers can use to see their problems and find solutions. You wave your phone over a specific leaf, look at it, and if it has a symptom, a box will pop up saying you have this problem. When you get a diagnosis, we have an option for you to get advice and learn about the best management practices.
The object detection that we use through TensorFlow relies upon our team annotating images.
We've collected over 5,000 high-quality images of different cassava diseases for this project. We use a single-shot detector model on a mobile net architecture. It's able to make predictions in less than 1 second.
Instead of having to implement thousands of lines of code, TensorFlow provides a library of functions that allow us to build architectures in much less time.
We need something that can be deployed on a phone without any connection. TensorFlow.
All right. Hello. Okay. Who's interested in AI?
Woo!
Me too. Me three. Okay, so I'm the moderator today. I'm Diane Green, and I'm running Google Cloud and on the Alphabet board. And I'm going to briefly introduce our really amazing guests we have here. I also live on this Stanford campus, so I've known one of our guests a long time because she's a neighbor. So let me just introduce them. First is Dr. Fei-Fei Li, and she is the chief scientist for Google Cloud. She also runs the AI lab at Stanford University, the Vision Lab, and then she also founded Sailors, which is now AI for All, which you'll hear about a little bit later. And is there anything you want to add to that, Fei-Fei?
I'm your neighbor.
That's the best. And so then the other, so now we have Greg Corrado, and actually there's one amazing coincidence. Both Fei-Fei and Greg were undergraduate physics majors at Princeton together at the same time. And didn't really know each other that well in the 18-person class.
We were studying too
No,
hard.
it was kind of surprising to, go to undergrad together and then Neither of us in computer science, and then rejoin later, only once we were here at
All
Google.
paths lead
Yeah.
to AI and neural networks and so forth. But anyhow, so Greg is a principal scientist in the Google Brain Group. He co-founded it. And more recently, he's been doing a lot of amazing work in health with neural networks and machine learning. He has a PhD in neuroscience from Stanford. And so he came into AI in a very interesting way. And maybe he'll talk about the similarities between the brain and what's going on in AI. Would you like to add anything else? Or?
No?
Yeah.
Sounds good.
Okay. So I thought, since both of them have been involved in the AI field for a while, and it wasn't, you know, it's recently become a really big deal, but it'd be nice to get a little perspective on the history, you know, yours in vision and yours in neuroscience, about AI and how it was so natural for it to evolve to where it is now and what you're doing. And start
Sure.
with Fei-Fei.
I guess I'll start. So, first of all, AI is a very nascent field. In the history of science, of human civilization, this is a field of only 60 years of age. And it started with a very, very simple but fundamental quest, is can machines think? And we all know thinkers and thought leaders like Alan Turing challenged humanity with that question, can machines think? So about 60 years ago, a group of very pioneering scientists, computer scientists like Marvin Minsky, John McCarthy, started really this field. In fact, John McCarthy, who founded Stanford's AI lab, coined the very word artificial intelligence. So where do we begin to build machines that think? Humanity is best at looking inward and ourselves and try to draw inspiration from who we are. So we started thinking about building machines that resemble human thinking. And when you think about human intelligence, you start thinking about different aspects, the ability to reason, the ability to see, the ability to hear, to speak, to move around, make decisions, manipulate. So AI started from that very core foundational dream 60 years ago, started to proliferate as a field of multiple subfields, which includes robotics, computer vision, natural language processing, speech recognition. And then a very important development happened around the 80s and 90s, which is a sister field called machine learning started to blossom. And that's a field combining statistical learning, statistics with computer science. And combining the quest of machine intelligence, which is what AI was born out of, with the tools and capabilities of machine learning. AI as a field went through an extremely fruitful, productive, blossoming period of time. In fact, fast forward to the second decade of 21st century, the latest machine learning booming that we are observing is called deep learning, which has a deep root in neuroscience, which I'll let you talk about. And so combining deep learning as a powerful statistical machine learning tool with the quest of making machines more intelligent, whether it's to see or is it to hear or to speak, we're seeing this blossom. And last, I just want to say, 3 critical factors converged around the last decade, which is the 2000s and the beginning of 2010s, which are the 3 computing factors. One is the advance of hardware that enabled more powerful and capable computing. Second is the emergence of big data, powerful data that can drive the statistical learning algorithms. And I was lucky to be involved myself in some of the effort. And then the third one is the advances of machine learning and deep learning algorithms. So this convergence of 3 major factors brought us the AI boom that we're seeing today, and Google has been investing in all three areas. Honestly, earlier than the curve. Most of the effort started even in early 2000s. And as a company, we're doing a lot of AI work from research to products.
Yeah. And it's been really interesting to watch the divergence and exploration in various academic fields, and then the reconvergence as we see ideas that are aligned. So it wasn't, as Fei says, it wasn't so long ago that fields like cognitive science, neuroscience, artificial intelligence, even things that we don't talk about much more like cybernetics, were really all aligned in a single discipline. And then they've moved apart from each other and explored these ideas independently for a couple of decades. And then with the renaissance in artificial neural networks and deep learning, we're starting to see some reconvergence. So some of these ideas that were popular only in a small community for a couple of decades are now coming back into the mainstream of what artificial intelligence is, what statistical pattern recognition is, and has really been delightful to see. But it's not just one idea. It's actually multiple ideas that you see that were maintained for a long time in fields like cognitive science that are coming back into the fold. So another example beyond deep learning is actually reinforcement learning. So for the longest time, if you looked at a university catalog of courses and you were looking for any mention of reinforcement learning whatsoever, you were going to find it in a psychology department or a cognitive science department. But today, as we all know, we look at reinforcement learning as a new opportunity, as something that we actually look at for the future of AI, that might be something that's important to get machines to really learn in completely dynamic environments, in environments where they have to explore entirely new stimuli. So I've been really excited to see how this convergence has happened back in the direction from those ideas into mainstream computer science. And I think that there's some hope for exchange back in the other direction. So neuroscientists and cognitive scientists today are starting to ask whether we can take the kind of computer vision models that Fei helped pioneer and use those as hypotheses for how it is that neural systems actually compute, how our own biological brains see. And I think that it's really exciting to see this kind of exchange between disciplines that have been separated for a little while.
You know, one little piece of history I think that's also interesting is what you did, Fei, with ImageNet, which is a nice way of explaining, you know, building these neural networks where you labeled all these images and then people could refine their algorithms by, go ahead and explain that just real quickly.
Okay, sure. So about 10 years ago, that the whole community of computer vision, which is a subfield of AI, was working on a holy grail problem of object recognition, which is you open your eye, you can see the world full of objects like flowers, chairs, people, you know, and that's a building block of visual intelligence and intelligence in general. And to crack that problem, we were building as a field different machine learning models. We're making small progress, but we're hitting a lot of walls. And when my student and I started working in this problem and started thinking deeply about what is missing in the way we're approaching this problem, we recognized this important interplay between data and statistical machine learning models. They really reinforce each other in very deep mathematical ways that we're not going to talk about the details here. That realization was also inspired by human vision. If you look at how children learn, it's a lot of learning through big data experiences and exploration. So combining that, we decided to put together a pretty epic effort of we wanted to label all the images we can get on the internet. And of course, we Google searched a lot. And we downloaded billions of images and used crowdsourcing technology to label all the images, organize them into a data set of 15 million images organized in 22,000 categories of objects, and put that together, and that's the ImageNet project. And we democratized it to the research world and released it open source. And then starting in 2010, we held an international challenge for the whole AI community called ImageNet Challenge. And one of the teams from Toronto, which is now at Google, won the ImageNet Challenge with the deep learning convolutional neural network model, and that was year 2012. And a lot of people think the combination of ImageNet and the deep learning model in 2012 was the onset of what
We
Greg
gave
is
people
building.
a way to compare how they were doing.
Exactly,
And it was really
yeah.
good. So, yeah. And so, Greg, you've been doing a lot of brain-inspired research, very interesting research, and I know you've been doing a lot of very impactful research in the health area. Could you tell us a little bit about that?
Sure. So, I mean, I think you know, the ImageNet example actually sort of sets a playbook for how we can try to approach a problem. The kind of machine learning and AI that is most practical and most useful today is ones where machines learn through imitation. It's an imitation game where if you have examples of a task being performed correctly, the machine can learn to imitate this. And this is called supervised learning. And so what happened in the image recognition case is that by Feifei building an object recognition data set, we could all focus on that problem in a really concrete and tractable way in order to compare different methods. And it turned out that methods like deep learning and artificial neural networks were able to do something really interesting in that space that previous machine learning and artificial intelligence methods had not, which was that they were able to go directly from the data to the predictions and break the problem up into many smaller steps without being told exactly how to do that. So that's what we were doing before, is that we were trying to engineer features or cues, things that we could see in the stimuli that then we would do a little bit of statistical learning on to figure out how to combine these signals. But with artificial neural networks and deep learning, we're actually learning to do those things all together. And this applies not only to computer vision, but it applies to most things that you could imagine a machine imitating. And so the kinds of things that we've done, like with Google Smart Reply and now Smart Compose, we're taking that same approach, that if you have a lot of text data, which it turns out the internet is full of, what you can actually do is you can look at the sequence of words so far in a conversation or in an email exchange and try to guess what comes next.
You know, I'm going to interrupt here a little bit and get a little more provocative here.
All right.
So you're talking about, you know, neural-inspired machine learning and so forth. And so, you know, this artificial intelligence is kind of bringing into question, what are we humans? And then there's this thing out there called AGI, artificial general intelligence. What do you think's going on here? Are we getting to AGI?
I really don't think so. There's a variety of opinions in the community, but my feeling is that, okay, we've finally gotten artificial neural networks to be able to recognize photos of cats, right? That's really great. We also, it's now can...
Feifei, was that AGI when we recognized a cat?
No, that's not enough
Yeah.
to define AGI.
So the kind of thing that's working well right now is this sort of pattern recognition, this immediate response where we're able to recognize something kind of reflexively. And we now have, I believe, machines can do pattern recognition every bit as well as humans can. And that's why they can recognize objects in photos, that's why they can do speech recognition, and that's why they can win at a game like Go. But that is only one small sliver, a tiny sliver, of what goes into something like intelligence. Notions of memory and planning and strategy and contingencies, even emotional intelligence. These are things that we haven't even scratched the surface. And so to me, I feel like it's really a leap too far to imagine that having finally cracked pattern recognition after some decades of trying, that we are therefore on the verge of cracking all of these other problems that go into what constitutes general intelligence.
Although we have gone way faster than either of you ever expected us to go, I believe.
Yes and no. Humanity has a tendency to overestimate short-term progress and underestimate long-term progress. So eventually we will be achieving things that we cannot dream of. But Diane and Greg, I want to just give a simple example to define AGI. So the definition of AGI, again, is an introspective definition of what humans and human intelligence can do. I have a 2-year-old daughter who doesn't like napping. And I thought I'm smart enough to scheme to put her in a very complicated sleeping bag that doesn't get herself out of the crib. And just a couple of months ago, I was on the monitor watching this kid, 2-year-old, where for the first time, I was training her for napping by herself. She was very angry. So she looked around, figured out a weak spot on the crib where she might be able to climb out, figured out how to unzip her complicated sleeping bag that I thought I schemed to do really, to prevent that, and figured out a way to climb out of a crib that's way taller than who she is, and managed to escape safely and without breaking her legs.
Okay, how about AGI equivalent to my cat or equivalent to a mouse?
If you're shifting the definition, sure.
I see, okay.
But even cat, I think there are things that the cat is capable of doing.
So I do think that if you look at an organism like a cat from a behavioral level, like how cats behave and how they respond to their environments, I think that you could imagine a world where you have something like a toy that is for entertainment purposes that approximates a cat in a bunch of ways, in that the sorts of behaviors that the human observe, you're like, oh, it walks around, it doesn't bump into things, it meows at me every once in a while. I do believe that we can build a system like that. But what you can't do is you can't take that robot and then, dump it in the forest and have it figure out what it needs to do in order to survive and make things work.
But it's a goal. It's a healthy goal.
It's a healthy goal. And along the way, like you both, at least we all three agree that AI's capacity to help us solve all our big problems is going to outweigh any kind of negative, and we're pretty excited about that, I guess. Like in cloud, you're kind of doing some cool things with AutoML and so forth.
Yeah, so we talk a lot, Diane, about the belief of building benevolent technology for human use, right? Our technology reflects our values. So I personally, and I know Greg's whole team is working on bringing AI to people and to the fields that really need it to make a positive difference. So at Cloud, we're very lucky to be working with customers and partners from all kinds of vertical industries, from healthcare, where we collaborate, to agriculture, to sustainability, to entertainment, to retail, to commerce, to finance, where our customers bring some of the toughest problems and their pain points, and we can work with them hand in hand to solve some of that. So for example, recently we rolled out AutoML, and that is the recognition of the pain of entering machine learning. It's still a highly technical field. The bar is still high. Not enough people are trained experts in the world of machine learning. But yet, our industry already has so much need to, tag pictures, understand imageries, just as an example in vision. So how do we answer that call of need? So we worked hard and thought about this suite of product called AutoML, where the customer, we lower the entry barrier by relieving them from coding machine learning custom models themselves. All they have to do is to give us provide the kind of data and concept they need. Here's an example of a ramen company in Tokyo that has many shops of ramens, and they want to build an app that recognizes the ramens from different ramen stores. And they give us the pictures of ramens and the concepts of their store 1, store 2, store 3. And what we do is to use a technique, a machine learning technique that Google and many others have developed called learning to learn, and then build a customized model for the customer that recognize ramens for their different stores. And then the customer can take that model to do what they want.
I can write a little C++, maybe some JavaScript. Could I do AutoML?
Absolutely. Absolutely. We're working with teams that they don't have not even C++ experience, and we have a drag and drop interface, and you can use AutoML that way.
Because I really believe that there are so many problems that can be solved using this technique that it's critical that we share as much as possible about how these things work. I don't believe that these technologies should live in walled gardens, but instead we should develop tools that can be used by everyone in the community, and that's part of why we have a very aggressive open source stance to our software packages, particularly in AI. And that includes things like TensorFlow that are available completely freely, and it includes the kinds of services that are available on cloud to do the kind of compute, storage, and model tuning and serving that you need to use these things in practice. And I think it's amazing that the same tools that my applied machine learning team uses to tackle problems that we're interested in, those same tools are accessible to all of you as well to try to solve the same problems in the same way. And I've been really excited with how much how great the uptake is and how we're seeing expanding to other languages. Mentioning JavaScript, quick plug for TensorFlow.js is actually really awesome.
Yep. Oh, and you should probably run it on a TPU.
Yes, exactly.
It does give a nice boost. But so you're building, with machine learning, we're bringing it to market in so many ways because we have the tools to build your own models, the TensorFlow. We have the AutoML that brings it to any programmer. And then what's going on with all the APIs and how is that going to affect every industry and what do you see going on there?
So cloud already has a suite of APIs for a lot of our industry partners and customers, from translate to speech to vision to...
which are based on models that we built.
Yes, we can build. For example, Box is a major partner with Google Cloud, where they recognize a tremendous need for organizing customers' imagery data to help customers. So they actually use Google's Vision API to do that. And that's a model easily delivered to our customers through our service.
Yeah, it's pretty exciting. Greg, how do you think that's going to play out in the health industry? I know you've been thinking about that.
Yeah. So healthcare is one of the problems that a bunch of people are working on at Google and a lot of people are working on outside as well, because I think there's a huge opportunity to use these technologies to expand the availability and the accuracy of healthcare. And part of that is because doctors today are basically trying to weather an information hurricane in order to provide care. And so I think there are thousands of individual opportunities to make doctors' work more fluid, to build tools to solve problems that they want solved, and to do things that help patients and improve patient care.
I mean, I think you were telling me that so many doctors are so unhappy because they have so much drudgery to do. Is this a big breakthrough?
Yeah,
or?
Absolutely. I mean, I believe that there's been a great, when you go to a doctor, you're looking for medical attention, right? And right now, a huge amount of their attention is not actually focused on the practice of medicine, but is focused on a whole bunch of other work that they have to do that doesn't require the kind of insights and care and connection the real practice of medicine does. And so I believe that machine learning and AI is going to come into healthcare through assistive technologies that help the doctors do what they want to do better.
By understanding what they do and assist them. No substitute for the human.
No, I don't think so.
Yeah.
No substitute.
Speaking of human, Feifei, do you want to talk a little bit about why you think this humanistic AI approach is so critical?
Yeah, thank you. So if we look at the history of AI, we've entered phase 2. The first 60 years is AI as more or less a niche technical field where we're still laying down scientific foundations. But starting this point on, AI is one of the biggest drivers of societal changes to come. So how do we think about AI in its next phase? What is the frame of mind that should be driving us? Has been on top of my mind. And I think deeply about the need for human-centered AI, which, in my opinion, includes 3 elements to complete the human-centered AI thinking. The first element is really advancing AI to the next stage. And here we bring our collective background from neuroscience, cognitive science, whether we're getting to AGI tomorrow or in 50 years, there's a need for AI to be a lot more flexible, nuanced, learn faster in more unsupervised, semi-supervised, one-shot learning ways, to be able to understand emotion, to be able to communicate with humans. So that is the more human-centered way of advancing AI science. The second part is the human-centered AI technology and application, is that I love what you're saying, that there's no substitute for humans. This technology, like all technology, is to enhance humans, to augment humans, not to replace humans. We'll replace certain tasks. We'll replace humans out of danger or tasks that we cannot perform. But the bottom line is we can use AI to help our doctors, to help our disaster relief workers, to help decision makers. So there is a lot of technology in robotics, in design, in natural language processing that is centered around human-centered AI technology and application. The third element of human-centered AI is really to combine the thinking of AI as a technology as well as the societal impact. We are so nascent in seeing the impact of this technology, but already, like Diane said, that we are seeing the impact in different ways, ways that we might not even predict. So I think it's really important, and it's a responsibility of everyone, from academia to industry to government, to bring social scientists, philosophers, law scholars, policymakers, ethicists, and historians at the table, and to study more deeply about AI's social and humanistic impact. And that is the 3 elements of human-centered AI.
That's pretty wonderful, and I think we at Google here, Alphabet, are working as hard as we can to do humanistic AI. You mentioned what we need to be careful about out there with AI and regulatory. What are some of the barriers to, I think every company in the world has a use for AI in many, many ways. I mean, it's just exploding in all the verticals. But there are some impediments to adoption. For example, in the financial industry, they need to have something called explainable AI. And could you just talk about some of the different barriers you see to being able to take advantage of AI?
We should start with healthcare.
Yeah, so I think that there are a bunch of really important things to consider. So one of the things is, of course, we want to have machine learning systems that are designed to fit the needs of the folks that are using them and applying them. And that can often include not just giving me the answer, but telling me something about how that was derived. So some kind of explainability. So in the healthcare space, for example, we've been working on a bunch of things in medical imaging. And it's not acceptable to just tell the doctor that, oh, something looks fishy in this x-ray or this pathology slide or this retinal scan. You have to tell them, well, what do you think is wrong? But more importantly, you actually have to show them where in the image you think the evidence for that conclusion lies, so that they can then look at it and decide whether they concur or they disagree, or, oh, well, there's a speck of dust there, and that's what the machine is picking up on. And the good news is that these things actually are possible. And I think there's kind of been this unfortunate mythology that AI and deep learning in particular is a black box, and it really isn't. We didn't study how it worked because for a long time it really didn't work that well. But now that it's working well, there are a lot of tools and techniques that go into examining how these systems work, and I think explainability is a big part of it in terms of making these things available for a bunch of applications.
So in addition to explainability, I would add bias. I think bias is an issue we need to address in AI, and I see bias from where I said two major kind of bias we need to address. One is the pipeline of AI development, starting from the bias of the data to the outcome of the bias. And we have heard a lot about if the machine learning algorithm is fed with data that does not represent the problem domain in a fair way, we will introduce bias. Whether it's missing a group of people's data or biasing it to a skewed distribution, these are things that would have deep consequences, whether you're in the healthcare domain or finance or legal decision making. So I think that is a huge issue. Very nicely that Google is already addressing that. We have a whole team at Google working on bias in this.
That's true.
And another bias I think it's important is the people who are developing AI. It's the human bias. And the lack of diversity is also another bias.
It's so important, and that kind of brings me to maybe we're getting close to the end, but if you, where is AI going? I mean, how prevalent is it going to be? I mean, we look at our universities and these machine learning classes have 800 people, 900 people. There's such a demand. Every computer science graduate wants to know it. Where is it going? I mean, will every high school graduating senior be able to customize AI to their own purposes? And how will, what does it look like 5, 10 years from now?
So from a technology point of view, I think that because of the tremendous investment in resource, both in the private sector as well as in the public sector now, many countries are waking up to invest in AI. We're gonna see a huge continued development of AI technology. I'm mostly excited either at Cloud or seeing what Greg's team is doing, AI being delivered to the industries that really matter to people's lives and work quality and productivity. But Diane, I think you're also asking is, how are we educating more people in AI, right? So
both making it easier to use and educating them, and what's it going to look like? What do you predict?
So, that's a really tough question, because at the core of today's AI is still calculus, and that's not going to change.
So I think that from the tech industry perspective, or from the computer science education perspective, I think that we're going to see AI and ML become as essential as networking is, right? Like, no one really thinks about, oh, well, I'm going to write some software and it's going to be standalone on a box and it's not going to have a TCP/IP connection, right? Like, we all know that you're going to have a TCP/IP connection at the end of the day somewhere, and everyone understands the basics of the networking stack, and that's not just at the the level of engineers, that's at the level of designers, of executives, of product developers and leaders. And the same thing I think is going to happen with machine learning and AI, which is that designers are going to start to understand, how can I make a completely revolutionary kind of product that folds in machine learning the same way that we fold in networking and internet technologies into almost everything we build. So I think we're going to see tremendous uptake and it becoming kind of a pervasive background part of the technologies. But I think that in that process, the ways that we use AI are going to evolve. So I think right now, you're seeing a lot of things where AI and machine learning adds some spice, some extra little coolness on a feature. And I think that what you're going to see over the next decade is you're going to see more of a core integration into what it means for the product to actually work. And I think that one of the great opportunities there is actually going to be the development of artificial emotional intelligence that allows products to actually have much more natural and much more fluid human interaction. We're beginning to see that in the assistant now with speech recognition, speech synthesis, understanding dialogues and exchanges. But I think that this is still in its infancy. We're going to get to a point where the products that we build, they interact with humans in the way that the humans find most useful, just out of the box.
And I spend a lot of time with high schoolers, because I really believe in the future. You know, we always talk about AI changing the world, and I always say the question is, who is changing AI? And to me, bringing more human mission thinking into technology development and thought leadership is really important. Not only important for the future of our technology and the value we instill in our technology, but also in bringing the diverse group of students and future leaders into the development of AI. So, you know, at Stanford, at Google, we all work a lot on this issue, and personally, I'm very involved with AI for All, which is a nonprofit that educates high schoolers around the country from diverse backgrounds, whether they're girls or students of underrepresented minority groups, and we bring them onto AI, onto campus, university campus, and work with them on AI thinking and AI studies.
And at Google, we're just completely committed to bringing all our best technologies to everybody in the world. And we're doing that through the cloud, and we're bringing these tools, we're bringing these APIs, and the training and the partnering and the processors. And we're pretty excited to see what all you guys are going to do with it. Thank you very much.
Thanks, everybody.
Yeah.
And community, what the needs of community are, and then how do we envelop the technology, just what you said. And I know for Ryan, community was really important. So and I talked to a lot of experts. It wasn't just me sort of coming up with things. I talked to a lot of people who really knew, nanotechnologists, neuroscientists, archaeologists, geologists, geographers, on a daily basis, to understand how to fold that in. And I think one of the biggest things that I did was I tried to find, a lot of the tech was based on biomimetics. So I tried to find in nature and in the different cultures what the use of something was and then the evolution of it. Because at the end of the day, it is all about the evolution of it, how we are in society and how we are advancing technologically. So it was me relating these things back in a way that represented what they are really used for and how they would have evolved over time. And I think technologically, oftentimes, it is the thing for the thing's sake and not here is, you know, something that has been such a big part of a tradition of any nationality, any ethnicity, any culture, religion, and this is how it becomes useful in a futuristic and advanced way. If that means technology, then that's the way that it would be. So that's sort of how I strung those together. And then pulling from nature. That was a huge one. And thereby keeping everything organic, in a sense. So it becomes not such a scary thing, but a very organic thing, because we're so used to seeing certain things in nature, patterns, shapes, you know, geometry, all of these things, math, science, it's all around us constantly. So it was really easy at some point to start just looking just into nature, because it is science. It is technology. You know what I mean? Like the way everything works. So looking beyond the hardware and the finish of the hardware of it and into the organic nature of it all. That's like a little dive into how it went.
It must have been a very full 14 months working on this film.
Beyond. We were on 3 continents, we were in 2 states, and I had a team at any given moment that were 500 strong, just in my department. So we went 14 months, and we went hard as we could go for 14 months to get this done, and put every last, like my whole team put every last inch of themselves. So, you know, it was a beautiful thing because we represented the diaspora, just our crew. So it was a micro version of the macro that we were building in Wakanda. I lived that every single day for a little over a year.
All right, I want to ask you about what's next, but it doesn't have to be specific projects. But it's like, where do you go from here with everything that you've talked about, right? Like the production design itself, but like the bigger themes and ideas that you're working on.
You know, challenging myself, I think, to try to continue to do things that are out of my comfort zone. Something I learned from Ryan Coogler, who has taken me from Fruitvale Station to a boxing movie, Creed, to a comic book movie, Black Panther. I want to continue the trend on my own and not just be in a place that I feel comfortable. My next project with Melina Matsuko, who is a director for Insecure, I'm just working on the pilot for Why the Last Man, which is a graphic novel.
Yes, I've read the entire series. So good.
So I'm going to be designing the pilot. We're working on that currently. I can't really say much more than that, but it's super exciting. The script is phenomenal. And our approach to it is going to be, I think, something really cool. So I'm really super excited about that. Worked with Beyonce again. That's all I can say about that. And the future is wide open. And if Denis Villeneuve is listening, I'd love to do Dune.
Yes.
I throw that out every opportunity I can get. Denis?
Yes. Hannah, thank you so much for joining me and sharing your story and all the work that you do.
Thank you so much. It's super exciting. I'm so happy to be here, and I think I'm going to learn something today, too. So, you know, it's all about soaking in all this greatness. So, fabulous. Thank you.
Thank you. I'm Timothy Jordan, and this is I/O Live.
All the way up now.
I can't imagine how anybody passes a problem that they know that they can fix and doesn't try to fix it. That's not some complicated thing. It's just stop talking about it and start doing it. I feel an absolute obligation to serve. I did 2 tours in Iraq as a helicopter pilot. I loved being part of the cavalry. But then I got injured, and that caused me to lose my ability to fly. One day you're a soldier, and then overnight they rip off that tag and slap veteran on your chest. I didn't know where to start looking for the next thing. What I do is math and engineering, So I had to find a way to apply those things in a meaningful way. Service doesn't end when you get out of the military, it just changes. And I started reading about the research that they were doing at the Human Engineering Research Lab. And I thought, man, I gotta go be a part of that. HURL's mission is to help people with disabilities increase independence and quality of life. I prepare the software to support the research that we do. One of the big things that I've done is help us transition to using Android tools. They make things really accessible. Anybody can sit down and start using these technologies and perform the tasks that we hope that it'll be useful for. That's the right thing to do, is to make things not just able to be used, but to be used with the same sort of joy or ease as I do. A big part of why open technology is so attractive to engineers like myself is there's such an active community of people designing and innovating.
Welcome to Pittsburgh.
All three of my children have a disability. The fact that my son has autism is just one little part of him, but almost his entire existence is defined by that autism. There was part of me that hoped someday I'd be able to help my son be able to live independently and give him a future. That's part of why I became an engineer, it's part of why I got into this field. There's going to be a time where someone like my son will have gotten a better opportunity, a better swing at this thing. I'm not going to sit around and wait for somebody else to fix the problem. There's not a minute to be wasted thinking about anything but the good things that we can do.
This is I/O Live, and I'm Timothy Jordan, and I'm standing here with Hannah Beekler, who is a production designer. You may know her from Black Panther.
Hello.
Hi, how are you today?
I gotta give it one of these. Great, I'm doing great. I'm so happy to be here.
Me too. We're really glad that you came here to talk about your work and to talk about diversity and inclusion and how that's affected by representation in media.
Absolutely. I mean, I think a big important part of that is if you don't see it, you can't be it. And so putting those things into our narrative work and films, which, you know, everybody finds the time to go see a good movie, as noted by Infinity War, and, you know, and to represent a huge portion of the, you know, population in that way. I think when people see it, they realize, like, I can do that. I can have those same goals in life because it's not going to be impossible. And I think that that's such a huge, important part of my work and my body of work over the last 3 years.
Yeah, one of the things I think about a lot is that I was really lucky growing up, wanting to be an engineer and seeing lots of engineers that looked like me. And that was inspiring, and I really want that for everyone.
Absolutely. I mean, I think inspiring the next generation of young scientists who are females, young kids of color, who see a world where they have a sense of pride, where they have a sense of, you know, reaching back and seeing their tradition and their culture and their ancestors and all those things, even being a part of their future. And I think walking away with a huge sense of themselves that they otherwise may not know or have had privy to, or so it's lifting spirits that's so important when it comes to representation. It's not only about getting into certain fields; it's about who we're raising in the world for the future, because I know I'm going to be relying on my young child to take care of me, and I want him to know some things. So, you know, it's always on my mind, and it's something that I think I'm now more than ever driven to do and include as part of my design aesthetic.
Yeah, it's almost like if you can see it, you can be it.
Absolutely. And I've been watching, you know, I watch all the videos on Twitter. People will send me stuff of teachers teaching about the sort of, you know, things that we did. You know, I did a deep dive, but it was sort of a lighter dive into the technology in Black Panther and the science in Black Panther. And teachers are coming up with a way to teach their class using Black Panther as an example of sort of our vibranium and our sound science that we use in the movie, and to see that becoming part of like a curriculum and kids getting excited about it because they see themselves and yeah, I can do this you can't ask for anything more. And so I've always thought, like, what can I do to better the world as one individual? And I didn't really know ever what that was until I think after Black Panther, and I saw the response of young kids, and it was all about the representation. And so, that does become a design choice, and it's something that I think that I'm just going to do now forever.
Let's talk about that a little bit more, because you're on record as saying that when you were working on Black Panther, you were just focusing on it being good.
Yeah.
Right? But then afterwards, looking back on how big a deal this is for how many people, how has your perspective changed?
I mean, it hugely, because it was just, you're kind of in it, and you can't, like you were saying, see the forest through the trees. So you're just wanting to make sure it's good and it's right and that people are going to be happy and proud, and that, you did the right thing, you made the right choices, because at the end of the day, it was a lot of responsibility in some aspects. So and then after when I saw it, I was like, my eyes were, because I did a little bit of the VFX, I was there for a little bit, but I didn't see the final edit. I saw one of the cuts. So when I was there in the theater with everybody else, I was blown away. I was like, this is insane. I can't believe I did this. and seeing the responses, it's just on another level. It's just, it's really hard to put into words or articulate in a way that others can understand, because it really is made me speechless in a sense. There hasn't been the words made yet to describe what that's like, but it was certainly always about making a good movie with a great story, and hopefully everything else sort of fell in line. And then we had other great filmmakers, Ruth Carter, who is Oscar-nominated costume designer, who I worked with really intensively to make sure that what we did matched up, because a lot of what she did in the foreground on the characters defined who they were on screen. So that also gave back to the representation of powerful women who had their own agency about them and could make their own decisions and stand up for themselves and could think quick on
My husband and I have been in a somewhat long-distance relationship for a few years now. We talk on the phone and message a lot. But perhaps what's most enjoyable for me is when I visit him, I leave little notes all over his apartment. And sometimes when I'm home alone, he'll start changing the color of the smart lights in my living room to let me know that he's thinking of me. Our human conversations take a lot of different forms. We don't just talk verbally. Depending on where we are and what we're trying to say, we might write, hold hands, or even change color of smart lights. It's these human conversations that have inspired us to create conversations with technology. It's no surprise then that we're starting to incorporate more modalities into our digital interactions as well. With this increased number of devices and complexity of interactions, it might feel overwhelming to design for the Google Assistant. If you look at the Google Assistant today, I can talk to it not just through the speaker in my living room, but also through my car or my headphones. I can tap on my phone or my watch. But how do we design for an increased number of complexity of devices? I'm Saba Zedi, and I'm an interaction designer on the Google Assistant team. I'll be talking about how you can design actions across surfaces and give you some frameworks and some tips.
And hi, I'm Ulash. I'm an engineer on Actions on Google. And later on, I'm going to tell you how to build an action using the design principles Saba will talk about.
Okay, so before we can get started to understand how to design actions across surfaces, we need to get a better understanding of what those experiences can look like. Let's start with a journey through a user's day. You wake up in the morning to the sound of an alarm ringing on your Google Home. Without even getting out of your blanket, you can say, "Hey Google, stop." You get up, get ready, and as you're about to head out, you want to make sure you don't need an umbrella. So you turn to the smart display in your hallway and you ask, "Hey Google, what's the weather today?" You're able to hear a summary and also at a glance see the hourly forecast. As you're walking to your car, you take out your phone and tap on it to ask the Google Assistant to order your favorite from Starbucks. It's able to connect you to Starbucks where you can quickly place your order. As you're driving, you want to listen to your favorite podcast or the news. And you can ask Google Assistant for help in a hands-free way, and it can connect you, for example, to NPR News Update. You go about your day, and when you come back home, it's time to make dinner for your family. You turn to the smart display in your kitchen and you ask, for example, Tasty for help with a recipe, like in this case, pizza bombs. Tasty comes back and you can hear and see on the screen step-by-step instructions and the ingredients. After dinner, it's time to unwind with your family in the living room. You decide to play a BuzzFeed personality quiz, and it's a great way for your family to get together around a shared device and have some fun. And then you head to bed. You say, "Hey Google, good night." It's able to start your custom bedtime routine, which includes, for example, setting your alarms or telling you about your day tomorrow. So as you can see, users were able to interact with the Google Assistant similar to human interactions in that there were a lot of different ways and contexts. And although there were a lot of different devices, there are some overarching principles. So let's take a look at them. First, the experience was familiar. Whether it was morning, evening, or commute, users can access their favorite Google Assistant actions whenever, wherever they need them. The Assistant was available in different contexts. You saw it being used on the go and at home, up close and from a distance, and in shared and private settings. So as you're thinking about your actions, think about all the different contexts it may be used in. And lastly, different devices lend themselves to different modes of interaction. Some were voice only, some were visual, and some were a mix of both. And we'll talk a bit more about the strengths and weaknesses of each of these modalities in a bit. First, let's take a deeper look at a couple of those devices and see how these principles apply. You've already heard about smart displays now. They were announced earlier this year. And even though it's a new device, users can expect it to feel familiar. It's essentially like a Google Home with a screen. It's designed to be used at home, from a distance, and as a shared device. And as you can see in this shoe inspiration action example, even though there's a screen, users still interact with the device through voice. They don't have to tap through complex app navigation. Instead, the visuals are designed to be seen at a distance. And of course, the user can walk up to the screen and touch it if they want. Next, let's take a quick look at phones. One thing to note here is that we're making phones more visually assistive as well, similar to smart displays, allowing for a greater focus on the content. These devices, as you know, are great for use cases on the go, up close, and in a private environment. And users can interact with the Google Assistant on the phone through both voice and visuals. So hopefully that gave you a better sense of what the experiences on Google Assistant look like across devices. Now, in order to design for so many devices, it helps to have a vocabulary to help categorize them. At Google, we use this design framework called the multimodal spectrum. It helps us categorize devices based on their interaction types. So on one end, you have voice-only devices, like the Google Home and other smart displays that you have to hear or talk to. On the other end, you have visual-only devices, like a phone or a Chromebook that's on mute, and most watches. So you have to look at these devices or touch them. And in the middle, you have what we call multimodal devices, in that they're a mix of both. Cars and smart displays that rely primarily on voice, but have optional visuals, are known as voice-forward devices. Phones and Chromebooks with the audio on, which can use a mix of both voice and visuals, are known as intermodal devices. So now we have a vocabulary for categorizing these devices. But before we can start designing for them, it helps to understand the strengths and weaknesses of each of these modalities. Let's talk about voice first. Voice is great for natural input. We've been using it for millennia. Whether you're a kid, a senior, someone who's not tech savvy, it's still really intuitive. It's great for hands-free far-field use cases, like setting a timer in the kitchen while you're cooking. And it helps reduce task navigation. So for example, if you were out on a run, you could ask your favorite Google action that's about fitness and ask it about your workouts, instead of having to pull out your phone, navigate to that app, and search for that answer. Similarly, you could ask the Google Assistant to play the next song without having to mess with any controls. So voice has a lot of benefits. It's great, but it does have some limitations, and that's where visuals come in. Think about the last time you were at a cafe. You probably walked past all the pastries, looked at the menu, and made eye contact with the cashier. Think about how difficult that interaction would be if it was just through voice. Have a listen at what the menu would sound like if it was through voice alone.
Espresso, latte, vanilla latte, cappuccino, mocha, Americano, flat white, hot chocolate, black coffee and tea.
That feels pretty overwhelming, right? It's like watching all the options go by and catching the right one. It's like looking at a ticker. Voice is ephemeral and linear, and that makes it very difficult to hold a lot of information in your head. By contrast, the menu is a lot easier to scan if it looks like this. And you can imagine that the problem gets compounded if you also had to compare prices and calories. So visuals are great for scanning and comparing. We also use them a lot to reference objects in the world. So I can look at all the baked goods and then point to the one that I want, instead of, for example, having to hear or say out loud something like, that small sugar cookie with a chocolate drizzle. So voice and visuals both have their benefits, and it often is useful to use both. So in this example, we usually prefer to look at the menu, but then talk to the cashier in order to check out and pay. Similar benefits to using both voice and visuals exist in the real world as well, or in the digital world as well. And that's what makes multimodal devices like phones and smart displays such a unique opportunity. By leveraging the best of both voice and visuals, they're able to provide really rich interactions. But how do we design for them, along with designing for speakers? One thing to keep in mind, again, is to start with a human conversation. You might have an app already, but avoid the temptation to duplicate it. Instead, try to observe a relevant conversation in the real world, or role play it with a colleague, and write down that dialogue. You'll realize that not everything that's in your app does well as conversation, or vice versa. Instead, think of your action as a companion to your app that's faster in certain use cases. Now, I won't go into detail into how to write good dialogue or create persona, but I highly recommend you check out our brand new conversation design website at that link there. It goes into great detail into how to get started. So we've learned that we need to create spoken dialogue and then add visuals to it. So let's take a look at an example of how to do that and how that helps us scale. So if you haven't already, I'd encourage you to check out the Google I/O 2018 action that helps you learn more about this event. We started by writing a spoken dialogue as if it was for a voice-only device like a Google Home. And it includes terms like this one. So a user can say, browse sessions. And we respond with a spoken response like, here are some of the topics left for today, and so on. Now, in order to take this dialogue and scale it, we need to take every turn like this and think about all the ways we can incorporate visual components to it. So this would include, for example, display prompts, cards, and suggestion chips. In our example, we can accompany that spoken prompt with a display prompt like, which topic are you interested in? This helps carry the written conversation on a screen. We can add a list of sessions as a card. A user could tap on that, for example. And we could have a suggestion chip like, none of these. And this helps the user know how to pivot or follow up a conversation. Once we've constructed our response to have spoken and visual elements, we can then map that response to the multimodal spectrum from earlier. So depending on whether the device has visual or audio capabilities or how important voice is, we can choose the right components. So you already saw what our response would look like on a Google Home. We would simply have the spoken prompt. Let's take a look at what the response would look like across some of the other devices. A smart display is a voice-forward device. So we still need to show all the spoken prompt and make it carry the whole conversation. We don't really need a display prompt anymore, especially if we're going to have better visuals like the list and the chips. A phone, on the other hand, is an intermodal device. And we need to have both the voice and the visuals carry the conversation. In this case, you might notice that we shortened the spoken prompt because we can direct the user to look at the screen for more details. And Ulash will talk more about how you can do that. And of course, the rest of the visual components are there as well. And finally, if your phone was on silent, we would simply ignore the spoken prompt, and the visual components are able to carry the complete conversation. So now we've learned that in order to scale our dialogue, we need to write spoken prompts and then add visuals to them, and that helps us map across devices. But how do we know what kinds of visuals to add? I'd like to leave you with 5 tips for how you can incorporate visuals into your dialogue. For that, let's take this made-up assistant action called the National Anthem Player on a smart display. As the name suggests, a user can ask for a country, and it will come back with the national anthem for that country. When you invoke this action, it gives you a welcome message that sounds like this.
Welcome to National Anthem Player. I can play the national anthems from 20 different countries, including United States, Canada, and the United Kingdom. Which would you like to hear?
So as you can see, the device is currently writing on the screen what it's saying out loud. And this is really a missed opportunity, especially given that by now we've learned that visuals have some strength over voice, and that smart displays are great for showing rich, immersive visuals. So tip number 1 is to consider cards rather than just display prompts. In this case, we've swapped out the words for a carousel. Users can quickly browse through the list and select the country that they want. You'll notice this is kind of similar to the menu example we looked at in the cafe, where visuals are helping someone scan and compare options. Additionally, things like maps, charts, and images are also great on visual devices because they're difficult to describe through voice, similar to the cookie. Second, consider varying your spoken and your display prompt. This is particularly useful for devices that are intermodal, that might have a display prompt next to a card. And some of that information might be redundant. So in this case, we're stripping out the examples for the countries in the display prompt because the card already shows a lot of examples. Third, consider visuals for suggestions. Here, we know that the user is a repeat user, so we're reordering the list so that their most frequently visited countries show up first. We're also using suggestion chips to allude to the user how they can follow up or pivot a conversation. This kind of discovery can be quite difficult through voice alone. Next, you can use visuals to increase your brand expression. We used to allow you to change your voice and choose a logo, but now we're also going to be allowing you to choose a font and the background image. And Ulash will talk more about how you can do that. As you can see here, the experience looks a lot more custom and immersive. And lastly, visual devices are great for carrying conversations that started on a voice-only device. So for example, if I use this national anthem action on a Google Home and I wanted to see the lyrics, the action can send a notification after a few steps to my phone. And I can take out my phone and read them there. So hopefully those 5 tips will help you in incorporating more visuals into your dialogue. Let's summarize what we've learned so far on how to design actions for the Assistant. First, users interact with the Google Assistant in a variety of different ways and contexts. So this could include at home or on the go, up close at a distance, or through voice or visuals. In order to design across so many modalities, it helps to keep in mind the multimodal spectrum and think of your responses as having visual components as well as spoken components. And lastly, learn and leverage the strengths of each of these modalities. We learned, for example, that visuals are great at scanning, brand expression, and discovery. So instead of just showing on the screen what you're saying out loud, try to use cards instead. All right, now I'm going to hand it over to my colleague Ulash, who's going to talk about how you can develop these actions.
Thank you, Saba. Hi. So we said that the Assistant runs on many types of devices, and in the future it will run on many others. Luckily, we make it easy for you to build your action in a way that it will run well on all these devices today, as well as devices in the future. So let's go through an example. To walk you through this, I'm going to use a test action I created called California Surf Report that gives wave height and weather information in beaches in California for surfers. So currently, I only have spoken responses, no visuals yet. So let's see what this sounds like on a voice-only device, like the Google Home.
Cruise looks fair for most of today. Waves will be from 2 to 3 feet in the morning to 3 to 4 feet in the afternoon. Expect waist-high swell in the morning with northwest winds. Shoulder-high surf in the afternoon with southwest winds.
OK, great. Pretty informative. So now let's take a look at what this sounds like and looks like on a voice-forward device, like a smart display. Switch to demo, please. OK, Google, talk to California Surf Report.
OK, let's get the test version of California Surf Report.
Welcome to California Surf Report.
Tell me the surf report for Santa Cruz.
Surf in Santa Cruz Beach looks fair for most of today. Waves will be from 2 to 3 feet in the morning to 3 to 4 feet in the afternoon.
OK, I cut it short because I think we all get the idea. So as you can see, spoken responses are a good way to get started and working well on many devices. But when we have a screen, we can make it a lot better. So let's see how. One of the best visuals we can add, and the easiest ones to add, is a basic card. And here's an example from the Node.js client library of how to add a basic card to your responses. So we start with the spoken prompt as usual, and the second statement of ask adds a basic card. A basic card can have a title, subtitle, body text, and optional image. So let's see what this looks like on our smart display again. Let's switch to the demo, please. OK, Google, show me the surf report for Santa Cruz.
Surf in Santa Cruz Beach looks fair for most of today. Waves will be from 2 to 3 feet in the morning to 3 to 4 feet in the afternoon. Expect waist-high swell in the morning with northwest winds. Shoulder-high surf in the afternoon with southwest winds.
OK, great. Now it looks much better. So we have a nice visual for it rather than huge lines of text. And here are some other kinds of cards you can use. There's a carousel list card that allows you to display a set of things that the user can choose from. There's also a newly introduced table card. Another great way to add visuals to your action is to use suggestion chips. Suggestion chips allow the user to understand what they can do in this turn in the conversation. And also, they simplify user input. You can learn more about responses at the link. And by the way, all of this, like I promised, works equally well on an intermodal device, like a phone. As you can see, we have formatted the font sizes and the layout to fit the intermodal form factor. OK, great. So next, maybe what we want to do is shorten the spoken response a bit, because it's a bit repetitive with the information that's already on the card. Users can just look at the display for these. So how do we do this? We have a feature in the API called capabilities. So instead of thinking, if Google Home do this, else if Smart Display do that, think about what capabilities the surface that the user is interacting with you on have. Does it have a screen? Can it output audio? The capabilities of the device are reported to you in every webhook call, so you get to know what this is on every conversation turn. And here's a sample list of capabilities that we support. And you can learn more at the link. So in our use case, what we're looking for is the screen output capability. This indicates that the user device has a screen, so we can show them a card. Oh, and by the way, if you don't want your responses to differentiate between ones with displays and ones that are voice only, you can always add a card, and we'll just strip it out for you silently. So this makes it easy for you to build if you don't want to differentiate. And here's, again, the Node.js client library snippet that shows how to use this. So in the first if statement, we determined that the user's device does not have a screen. So we have the full content in the spoken response. In the else clause, we know that there's a screen. So we shorten the spoken response and end it with a phrase like, here's a report, to lead the user to the screen. And then we append the basic card to the response. So let's see how this looks like on our smart display now. Switch to demo, please. OK, Google, show me the shortened surf report for Santa Cruz.
Surf in Santa Cruz Beach looks fair for most of today, with 2 to 3 foot waves in the morning and 3 to 4 foot waves in the afternoon. Here's the report.
So that sounds a lot more concise and user-friendly. Another way you can use capabilities is to require that your action only run on devices that have the capability. This is what we call static capabilities. And you can configure these through the Actions on Google console, as you can see here. But only use this if your action absolutely makes no sense without that capability. So for example, the national anthem player action that Saba talked about would not make sense on a device without audio. So this would be a good place to use that. However, for the Surf Report app, it equally works well on voice-only and display-only devices. So it wouldn't be a good place to use this. You can configure all this using the Actions on Developer Google console. Another high quality and easy way to target multiple surfaces is to use Google libraries we call helpers. So I've been asking California Surf Report, the surf report with the beach name. But if I don't say the beach name, I get a prompt. Which beach? Now, this doesn't tell me what I can say. It doesn't tell me which beaches this action actually supports. So we can fix that with a helper called Ask with Carousel. What Ask for Carousel does is it presents the user with a list of options to pick from and associates visuals with each item. In addition, when the user utters the query to select an item, Google does the matching of the query to the item. So we can deal with variations in how people pick things much better. So let's make our prompt better with the Ask with Carousel helper. And again, the Node.js library snippet here, we start with the spoken response with the prompt, and we add a carousel to it. And carousel is made up of items, and each item has a list of phrases that you think the user might say to match this item, and visuals associated with each item so the user can understand what they're about to tap on. So let's switch to the demo and see what this looks like. OK, Google, show me the surf report.
Which beach do you want to see the report for?
OK, so this is the example where I'm a little confused as a user. OK, Google, show me the beach carousel.
Which beach would you like to know about?
OK, great. Now it's much easier for me to understand what the possible options are, and even tap on one if I want to go with that. And we always continuously improve the experience with these helpers. This is one of the advantages of helpers, is that we continue to modify them to optimize them for surfaces. Now, since we launched the Card API last year, we've since come up with Smart Displays. As you noticed on Smart Displays, each conversation turn takes up the entire screen. So given this fact, maybe we can make our visuals more branded and give them a little bit more flair. So we're introducing styling options this year. So here's how it works. Let's switch to the demo, please. So here's a new tab in the Actions on Google console called Theme Customization. You can modify the background color, primary color, so that's like the font color of the text, and the typography, and even set a background image. So let's try a few things here. Let's say we want to make this cursive. Let's add a background image. All right, what do we got here? OK, so this is the landscape aspect ratio image. And then we want to add a portrait image as well. All right, all set. Now all we have to do is save. And then we click Test right here to update our test version. All right, now let's see what this looks like at the demo, on the demo. OK, Google, show me the surf report for Santa Cruz.
Surf in Santa Cruz Beach looks fair for most of today, with 2 to 3 foot waves in the morning and 3 to 4 foot waves in the afternoon. Here's the report.
I think now that looks really beautiful. Smart displays are coming out later this year. However, you can start building your action against these visuals today using the updated simulator. So we've added a new simulator device type for smart displays, as you can see here. And we've also added a display tab, which shows you the full screen version of what you would get on a smart display. you can also use this with the phone. And on the left side, as usual, you have the spoken responses as well as an input box where you can put user queries. One last thing. We said the assistant is in many places. So if the user is interacting with your action using a voice-only device, maybe they also have a device that has a display on it. For example, a phone. So what if in your current turn in the conversation, you really want to have your response display something? So for example, in the surf report action, the user might ask us for the full report, and we want to return the hour-by-hour wave height graph. So how do we do that? There's a feature in the API called multi-surface conversations, and here's how it works. In each API call to your webhook, we report not only the capabilities of the device that the user is currently using, but the union of the capabilities of all the devices the user owns. So in this example, what you see is that the current user device only has a voice output capability and has no screen. But in available surfaces, we can see the screen output capability. So the user seems to have another device with a screen on it. So how do we use this? We, again, in the client library, we have a function to help you to inspect if the user has a certain capability among their devices. Now we determine that the user has a device with this capability. How do we transfer the user to the other device? We have a function, ask for new surface, that does this. And you can give it a notification that will appear on the target device, in addition to the list of capabilities that you require for continuing your conversation. I'm not going to demo this, but here's what it looks like. So let's say the user said, show me the full report, and they're talking to you on a Google Home. So you would call the ask new surface function that I showed you earlier, and we ask the user permission to send the conversation over to the user's phone. And if the user accepts, then there's a notification sent to the new device. The conversation ends on the current device. And when the user taps the notification, then they resume the conversation from where you left off, like this. Note that this is not just for single responses. This works equally well when you want to continue the conversation. So we bring the full context over so you can continue from where you left off. So to sum up, we've built a lot of features in the API for you to add visuals to your responses. So please use them. And we make it such that we take your responses and optimize them as best as possible to all these surfaces, and surfaces in the future without extra work from you. And if you wanted to customize your responses, always think of capabilities and not individual device types. This way, we can run your action on new devices without any extra work from you.
Thanks. Thank you. So I'd just like to end with an invitation for you. Next time you order coffee at a cafe or do a presentation like this one, start to notice all the different modes of interactions you use every day. And let the richness of those human conversations inspire how you design actions for your users and help us evolve what it means to have conversations with technology. Here's some links to resources we mentioned and how to give feedback. So also come just talk to us. We'll be with our team at the assistant office hours and sandboxes, ready to answer your questions and showing off some of the devices. So thank you and good luck.
Thank you.
And the men who, you know, treated them on this equal playing field. There was no like, oh, we need to make it easy for the girls. You know, you saw the door fight. You saw the king treat them as if they were, when they were the most powerful, you know, guards in Wakanda. So it's all of those things mixed together. Then you talk about the technology on top of that. You're giving a new generation, old generations, my generation, a whole another narrative than the one that we've sort of heard for the last how many ever decades.
Let's talk a little bit more about the technology, but not go away from the human aspects that you're talking about. And I think one of the things that's always really interested me in technology is not how to make tech just sort of better on its own, and then teach people how to use it, but rather teach technology how to be better for people. Absolutely. And I think that you've really captured in this film an intersection with culture and people and technology. How did you approach that?
Oh, that's heavy, man. You know, very carefully, because it's really trying to understand community, what the needs of community are, and then how do we envelop the technology, just what you said. And I know for Ryan, community was really important. So and I talked to a lot of experts. It wasn't just me sort of coming up with things. I talked to a lot of people who really knew, nanotechnologists, neuroscientists, archaeologists, geologists, geographers, on a daily basis, to understand how to fold that in. And I think one of the biggest things that I did was I tried to find, a lot of the tech was based on biomimetics. So I tried to find in nature and in the different cultures what the use of something was, and then the evolution of it. Because at the end of the day, it is all about the evolution of it, how we are in society and how we are advancing technologically. So it was me relating these things back in a way that represented what they are really used for and how they would have evolved over time. And I think technologically, oftentimes, it is the thing for the thing's sake, and not here is, you know, something that has been such a big part of a tradition of any nationality, any ethnicity, any culture, religion, and this is how it becomes useful in a futuristic and advanced way. If that means technology, then that's the way that it would be. So that's sort of how I strung those together. And then pulling from nature. That was a huge one. And thereby keeping everything organic, in a sense. So it becomes not such a scary thing, but a very organic thing, because we're so used to seeing certain things in nature, patterns, shapes, you know, geometry, all of these things, math, science, it's all around us constantly. So it was really easy at some point to start just looking just into nature, because it is science. It is technology. You know what I mean? Like the way everything works. So looking beyond the hardware and the finish of the hardware of it, and into the organic nature of it all. That's like a little dive into how it went.
It must have been a very full 14 months working on this film.
Beyond. We were on 3 continents, we were in 2 states, and I had a team at any given moment that were 500 strong, just in my department. So we went 14 months, and we went hard as we could go for 14 months to get this done, and put every last, like my whole team put every last inch of themselves. So, you know, it was a beautiful thing, because we represented the diaspora, just our crew. So it was a micro version of the macro that we were building in Wakanda, and I lived that every single day for a little over a year.
All right, I want to ask you about what's next, but it doesn't have to be specific projects. But it's like, where do you go from here with everything that you've talked about, right? Like the production design itself, but like the bigger themes and ideas that you're working on.
You know, challenging myself, I think, to try to continue to do things that are out of my comfort zone. Something I learned from Ryan Coogler, who has taken me from Fruitvale Station to a boxing movie, Creed, to a comic book movie, Black Panther. I want to continue the trend on my own and not just be in a place that I feel comfortable. My next project with Melina Matsuko, who is a director for Insecure, I'm just working on the pilot for Why the Last Man, which is a graphic novel.
Yes, I've read the entire series. So good.
So I'm going to be designing the pilot. We're working on that currently. I can't really say much more than that, but it's super exciting. The script is phenomenal. And our approach to it is going to be, I think, something really cool. So I'm really super excited about that. Worked with Beyonce again. That's all I can say about that. And the future is wide open. And if Denis Villeneuve is listening, I'd love to do Dune.
Yes.
I throw that out every opportunity I can get, Denis.
Yes. Hannah, thank you so much for joining me and sharing your story and all the work that you do.
Thank you so much. It's super exciting. I'm so happy to be here, and I think I'm going to learn something today, too. So, you know, it's all about soaking in all this greatness. So, fabulous. Thank you.
Thank you. I'm Timothy Jordan, and this is I/O Live.
All the way up now.
I can't imagine how anybody passes a problem that they know that they can fix and doesn't try to fix it. That's not some complicated thing. It's just stop talking about it and start doing it. I feel an absolute obligation to serve. I did 2 tours in Iraq as a helicopter pilot. I loved being part of the cavalry. But then I got injured, and that caused me to lose my ability to fly. One day you're a soldier, and then overnight they rip off that tag and slap veteran on your chest. I didn't know where to start looking for the next thing. What I do is math and engineering, so I had to find a way to apply those things in a meaningful way. Service doesn't end when you get out of the military, it just changes. And I started reading about the research that they were doing at the Human Engineering Research Lab. And I thought, man, I gotta go be a part of that. HURL's mission is to help people with disabilities increase independence and quality of life. I prepare the software to support the research that we do. One of the big things that I've done is help us transition to using Android tools. They make things really accessible. Anybody can sit down and start using these technologies and perform the tasks that we hope that it'll be useful for. That's the right thing to do, is to make things not just able to be used, but to be used with the same sort of joy or ease as I do. A big part of why open technology is so attractive to engineers like myself is there's such an active community of people designing and innovating.
Welcome to Pittsburgh.
All 3 of my children have a disability. The fact that my son has autism is just one little part of him, but almost his entire existence is defined by that autism. There was part of me that hoped someday I'd be able to help my son be able to live independently and give him a future. That's part of why I became an engineer, is part of why I get into this field. There's going to be a time where someone like my son will have gotten a better opportunity, a better swing at this thing. I'm not going to sit around and wait for somebody else to fix the problem. There's not a minute to be wasted thinking about anything but the good things that we can do.
everybody. Wow, it's a nice stage. OK, well, I am delighted to be here. I have a clock. We're going to get to see Hannah Beachler after me, so that's going to be super awesome. I am the warm-up act. I'm John Maida. Good to see all of you. This is something I made 3 years ago. Does anyone know this TV show? No, you don't know this TV show. Well, I spoke at the 50th anniversary of Star Trek, and it was a true honor. But I didn't think about Star Trek a lot until that moment. And I made this image, and I showed it. And people were asking me, why am I Scotty? And I was like, well, Scotty is an engineer, and I wanted to be an engineer. And I was asked, well, why not Sulu? Because he's Asian. And I said, I don't want to be Sulu. I want to be Scotty. I want to be an engineer. But it was in that moment I realized the reason why I didn't want to be Sulu is because I thought he was weird. In the sense that I thought it was strange how Sulu didn't speak with some kind of thick Asian accent on TV. And I thought, that's weird. Something's wrong with him. And it always stuck with me, why did I think it was wrong that he sounded like a Californian? I never thought of it until that moment. And that's the general topic of this presentation. Now, if you have a question and you got introvert, just text me your question, 253-217-4017. And we'll be able to interact. Because the problem with this kind of conversation thing is it isn't a conversation. It's like a one-way thing. So go ahead and text me a question at 253-217-4017. And I'm watching the clock. OK, here we go. OK, design and tech reports. There's 4 of them now. They're long. So you can read them in the microtype, et cetera. The big conclusion after 4 years of work has been to ask questions about how can design and tech be more inclusive. If we can figure this out, we can unlock incredible possibility and profitability. The problem with the word design, however, is that it means too many things. So the report defines design as 3 kinds of design. There's classical design, like your glasses. There's design thinking, this idea of using Post-it notes to create structure of ideas. And there's computational design, the kind of design that is powered by Moore's law. It's a different kind of design. It uses a material that didn't exist 100 years ago. What's a computational designer? I've defined this as roughly 4 type of things you have to have as a computational designer. You don't have to know how to program, but you have to be technically literate. You also have to think critically about technology. For you, technology is a responsibility. So you wonder how things are being used. You also use all kinds of design. You aren't stuck in just computational design. And lastly, you're very curious about new things. Because designers love to learn new people, new customs, new anything, because it's how they learn. So designers are inherently diversity positive. It's a very important point. Now, if you think about the value of design, it's been demonstrated by all the M&A activity, the mergers and acquisition activity of agencies. So I reported on this report, over 20 agencies were acquired by consulting companies, because consulting companies are finding value in design for their clients, which is a big deal. Never happened before. Now, the problem, however, is that classical designers tend to diss design thinking. You know what I'm talking about? Like, oh, design thinkers, they have the Post-it notes and the Sharpie markers with a whiteboard. You know, classical designers don't think of them as real designers. But I always tell classical designers, well, they make more money than you do. So important to note, design thinking is not a bad thing. It's a different kind of design. Also, I found that being in Silicon Valley for a while, we tend to forget there's the rest of the world. So I'm a big fan of China and all the design work being done there. Design of cars, design of experiences, especially mobile, and more recently, using AI to design banners, designs. They're just so further ahead than many people seem to have the impression in the United States. And that's kind of an embarrassing problem. Also, the other problem I've seen in tech is that it indexes to younger people, which is a great opportunity. But there's also an incredible opportunity in the older generation. Because I don't know if you all know this, but you all will get older. Yeah, it's not a problem. It's a real thing. And as you get older, things change. The first thing that changes is your eyesight. So for all designers who love 6.5 point, better give it up. Looks awesome, especially in light. But you won't be able to see it once you hit 40-something. And at Automatic, we call this the Bolder generation. Get it? Bolder? We like that. OK. Good news is that design is being used sooner in the process. It used to be in tech that you'd make the technology, and oh my gosh, it finally works. And you'd spray design on, called Make It Pretty. That was great 10 years ago, but because the competition is so fierce now, you have to bake design into the product. And you can see globally, we did a survey of 2,000 people, the trend is design is being used early in the process, which is a big deal. Now, when we talk about computational design, however, it's important to note that computational design uses the computer. And if you were, who was there in the 80s, come on, 80s people, right? People didn't like people who used the computer for design, right? You're made fun of, like Rudolph the Red-Nosed Reindeer. You were a bad designer because you were using the computer. There was a time. But the computer kept on getting more interesting. It came out of print. It became interactive. Who remembers Macromedia Director? Macromind, come on. Yes, yes. This stuff has been happening for a long time, interaction design. More recently, have these tools gotten more interesting, specifically by integrating things like machine intelligence. We can all feel it coming, and that's kind of exciting, but also scary at the same time. Let's see here. OK, so when we think about machine intelligence, my favorite demo, and this is all sourcing real data off the internet, this is Siri saying something in iOS 9.
1 liter is 33.81 fluid ounces.
This is iOS 10.
1 liter is 33.81 fluid ounces.
This is iOS 11.
1 liter is 33.81 fluid ounces.
Got really good fast, didn't it? That's what's happening. These quantum leaps are occurring. Linearity is being thrown out, and that's really important. And so when people ask in design, should I learn all these things? If you don't learn them, you'll be left behind. And so it's so key to stay at the forefront. Now, I also had this question. When do you expect AI to replace most visual designers? And it's interesting because the average says at least 5 years till visual designers get replaced. Not everyone, of course, but some design jobs. I think it's going to be much sooner, quite frankly, because all the information from companies like Google and companies in China as well are that a lot of rote things can be done by machine intelligence. Here are some of my favorites. I love that you can remove the watermark. I wonder why you'd want to do that. You can perfect contrast. This is MIT work. In a dark image, awesome image. You can also take 2 photos and make a new photo out of them, too. This is work from NVIDIA. You can also generate infinite variations of ideas just with pattern libraries in machine intelligence. You can also, as you all know, in this audience at least, you can change people's faces, and you can fix drawings. What's important to note, though, is that we see these warnings. Consider the photos. That's how you tell if it's fake. But it's so hard to tell if things are fake these days. It's going to get harder and harder. So we are human beings. We like to mess with the machine. So this is one of my favorite things. If you click on this button, this will randomly hit things so your browser gets confused. So we humans love to confuse machine intelligence. Put a pixel there. I don't know where it is anymore. It says machine intelligence. So we'll keep looking for this to try to stop the inevitable, which is that computers are learning so quickly. And when they learn so quickly, they learn bad things. I'm not sure if you remember it, but in July 2015, the Wall Street Journal reported how images mistakenly tagged black people as gorillas was happening in 2015. The algorithm was fixed. Why did it exist? Because the database had more light faces than darker faces, so the database was dumb. And so these data dumbness is occurring all over the place as machine intelligence ingests more data, which contains incredible biases that we have unfortunately let sit out there for too long. So how do we change that? I think we change that by rethinking a few things. And that is, where does technology evolve the quickest? And in the report, we pointed out that there's 2 regions. You see the red regions, the hot regions? That's where all this stuff is happening, right? This region of the country, New York. But if you flip the map, this is a map of inequality, income inequality. If you flip it, you see the exact opposite, that where tech is not impacting is where poverty is growing the quickest, because the skills gap is so large. This audience here is probably in the 0.01% of the most advanced people in the world. That said, the entire world is behind in computation, understanding the impact of Moore's law. And this is a very subtle intellectual privilege problem today. So when we look at what technology has done, it's been able to be extremely smart at optimizing our experience, and therefore making nothing we understand real or not real. And we all know it's happening, and it's amazing, but it's also quite disturbing. My mother, by the way, her favorite newspaper is the National Enquirer. So I'm always checking out the headlines. I just picked this up. Look out, Google. They know too. So is the digital divide related somehow to poverty and inequality? I think it's hard to say they're related or it's causal or correlated, but there's something connected that we cannot miss. And that is that if you don't have access to computation, you are excluded. And if you don't understand what it can do, you're excluded. And so technology keeps shooting off without them, us. So what's the solution? I'm passionate about remote work. I'm at a company that is all remote, automatic. Who works remotely? That's quite a few. So remote work is neat because it takes you out of these bubbles of tech. I guess I'm hopeful that at Automatic we're trying to figure out a world where WordPress is a good design for all. How do we do that? We have to use the fact that we can go anywhere because we're remote. So for instance, let's see, I was visiting Appalachia. And in Appalachia, I heard the story about how it was a coal miner who's teaching code to ex-coal miners. And he said, you know, you people are from the 3-dimensional world. You're 3D. You live in cities with skyscrapers, you know, and if you're from a smaller city, you're in a town, you live in 2D. In 2D, you have like no skyscrapers, just streets. And he said, here in Appalachia, we live in 1D. There's one street, and we all live off of it. That's where I realized the neat thing about remote work is you're 0-dimensional. And by being 0-dimensional, you can travel anywhere. And so we're trying to use this advantage to go into all kinds of places, anywhere in the world, and to connect with people. And I can tell you that this experience of being remote is a very powerful way to reduce exclusion, because you can be including by just going anywhere you think is necessary. Now, this is my favorite quote by the lawyer Vernay Myers. Diversity is being invited to the party. Inclusion is being asked to dance. Say this over to yourself. It's such a powerful idea, because if you don't have both, nothing occurs. And so when you ask how to be more inclusive, it's quite easy. Just ask, where do you spend your time? Who do you hang out with? Look at the people in the room around you. Are they diverse in some way? If they're not, you're going to have to do something terrible to yourself. You're going to have to make yourself uncomfortable. And it's exciting to be uncomfortable. Oh my gosh, you say the dumbest things. And you stumble, and you become stupid, and you become smarter and a better person through it, I believe. So all of you who are not found yourself in this way, enjoy it. It's so exciting. I'm a big entertainment fan, and I've been tracking all the movies that have put diversity and inclusion at the center of them, and they're doing very well financially. Movies like Wonder Woman, directed by Patty Jenkins. Star Wars had a much more diverse cast. The Foreigner by Jackie Chan. Who's seen The Foreigner? The Foreigner, where the terrorists aren't dark-skinned people. That was brand new. And The Big Sick, of course. And these are doing really well financially. This is teaching machine intelligence and the business world that this is a pattern to take note of. I like Kumail Nanjiani's quote, there's so many movies from different points of view that are making a ton of money. Don't do it because it's better for society and representation, even though it is. Do it because you'll get rich. you'll get that promotion, right? This thinking seems crass, yet it sits at the center of how change will start to occur. And I believe that as we see more of these kinds of things, wonderful things will happen. I want to close on, my mother went to see Black Panther. This was her review. It went kind of viral. Hi, John. Just came back from seeing Black Panther. It was very good. And we actually went to see Avengers last, me and my mom. I was in Seattle. My mom's like 83 years old. She's like, you know, little woman with a cane. You know, we're walking out of Avengers. And I said, Mom, how was it? Oh, it wasn't as good as Black Panther. You know? So anyways, thank you. And we'll have Hannah next, so please stay seated.
This is nuts. Look at all the faces.
Wow, I'm so happy. I get to interview Hannah Beachler. Yes.
Yeah, all right. Hey, y'all. Good to be here. This thing is a little weird, so you might see me kind of being a little weird.
So how's it been walking around this area?
I'm sorry?
How's it been walking around?
Cool.
Wandering
we
around,
went, hung out at the auditorium, and walked around some of the tents, and ate, and sat on the grass, and it was fabulous.
Anything catch your attention?
I mean, I was just looking at everything. The area is beautiful, and I think everything has been great. I've been talking to some great people, and it's been awesome.
Hmm. So, my mother loved Black Panther. I'm sure you weren't surprised, though.
What? I'm sorry?
I'm sure you weren't surprised.
That your mother loved it?
Yeah.
Not really. You know, honestly, that was part of what we tried to do was, you know, make it so everybody could love it. It wasn't really geared towards one specific anything. It was more about creating a feeling and a moment, and you know what I mean? I'm pretty into my emotions. I would call myself an emotionalist, if you will. And that's really what drives me is, you know, creating things from a place that people can relate to. And then that, you know, expands.
Had you heard of Black Panther when you got the job? Or?
Yes, I did. I had heard of the character and the comics, and I kind of knew it because I knew Marvel. I've certainly asked my son, who's 20, right away when I knew I was going to interview for the job that, you know, tell me all about, you know, the MCU and all of that. And he was like, here's a Marvel dictionary. And I sort of started from there. So I knew of him, but over that 14 months, I really got to know him.
So a superhero.
Superhero.
Was your reaction positive, yay, superhero, or superhero?
My reaction to it being superhero?
Yes.
I mean, I was really super excited because it was challenging. It's, you know, I've done so many things that are so different from each other that anything that is going to challenge me, I instantly want in on, you know. And working with Ryan Coogler, the amazing director, again for the third time, was, you know, without question, I was going to be involved with that. So I never thought I would ever do something like a superhero movie. That's not where I saw my career going. That's not what I thought I wanted to do. But then that's life. It's not really what you think in the beginning. But as, you know, I started to get into it, I was like, you know, why not? I didn't think I would do a boxing movie. I didn't think I would work with Beyonce. I didn't think I would, you know, work on a little $1 million movie that would win an Oscar. So I don't generally go into anything thinking anything other than how do I make this work? How do I make this the best it can be? And, you know, for each film, it's something different. So for Panther, there was a reason behind it for Ryan and I, and same with all the other projects.
So you had to look 1,000 years in the future. And you didn't come to Silicon Valley to look at that future.
No.
Talk about that.
Well, first I had to look 1,000 years in the past. That was a big part of Wakanda, was the honoring of the culture and the tradition and the diaspora, the African diaspora, that really is what Wakanda is representational of. So I had to look backwards because I think the past is a very important bridge to what the future is. And that needs to inclusion in design, in this world of what I was doing for Black Panther. Looking into the future, I didn't know, and you know what, honestly, I didn't know that Silicon Valley could help me for my needs. I didn't think that I was going to find in there, and honestly, I didn't really know much about it. I live in New Orleans. It's a very small town. I don't live in Los Angeles. I don't live in New York. I live in a place where the population is like 250,000 to 300,000 people. You know, I didn't know much about Silicon Valley. I kind of knew what I saw on TV. Sounds familiar. But I didn't really know how that could help me create this technology, which you would think was kind of crazy. Because what I knew I needed to do was evolve something that Silicon Valley, to me, I felt had no interest in, which is this culture. So there was, you know what I mean? I felt like I kind of had to give an autonomy to this story and a narrative that at times is restricted. Just in general by society, like the ability to tell communities' ability to tell their own story, how they want it told, and based on what they want it based on. So that was sort of me kind of being the person who made sure that the representation of the culture that we were digging into and creating a fictional one on top of it stayed to what I needed it to be, and I didn't know that Silicon Valley could help me. Now, I did reach out to a lot of experts about all kinds of stuff, geology, geography, archaeology. We talked to experts in architecture who were doing future cities, people who were sort of architectural archaeologists that could talk to us about some of the architecture, you know, pre-colonial sub-Saharan Africa, and then of course going to South Africa, traveling all over South Africa for 3 weeks and sort of understanding that, because at the heart of Black Panther was the question of what is it to be African, and so that's sort of, you know, why I felt like I didn't want to go or need to go to Silicon Valley. I don't know if that is like, and I mean, that's honest. That's the honest truth. And because I was so busy, I was like, you know, I'm just going to have to do this. I'm just going to have to figure this one out. And I didn't really know. 1,000 years into the future, here's the thing. It's hard enough to go any amount into the future and understand what you think might happen or how people would respond. So I found myself getting to this place where I started thinking about technology in the future, how Wakanda would use technology. Technically, Black Panther is placed in 2018. It's not sci-fi. It felt sci-fi because Wakanda, you know what I mean? We have to remember it's not science fiction. It's supposed to live in this universe, which is 2018. So I had to make sure it felt grounded enough that people weren't like, it's space. But it also had to be advanced enough where people thought, maybe this is something that's going to come around in 50 years, 60 years or something. It's not impossible, you know. And then you had to add sort of with the vibranium, the fantasy of it all. So, you know, and I'm rambling, so I don't even know if I answered the question, but, you know, that's sort of, I might have lost myself on that.
Actually, when you were describing that, I remember walking my mom out of the theater, because she can't walk very well, because she has diabetes and her feet are really, makes it hard. So she's walking really slowly and talking really slowly. And I remember when we just left the theater, she said, you know, Black Panther was so beautiful. All the scenery, everything was so beautiful. And it's a thing that stuck with her, how beautiful the movie is. And it's optimistic. And so where did that come from and how you were able to translate that?
I mean, I like to do things that are beautiful, you know, and I think that's another part of Black Panther is changing this idea of narrative of how we see things. You know, it was a challenge to me of how I saw Africa, what I thought about Africa. Just because I'm Black doesn't mean I'm an expert on African culture, right? So I really had to dig in and challenge myself about like, okay, well, what do I think? What are my biases? What was I raised with? From my American experience, you know, this is a land that's 1,000 miles away, and as far as I know, my ancestry begins and ends at slavery, and then the culture that came afterwards was this bastardized idea, or we were told it was a bastardized culture. You know, we're not African, we're not American, so it became this bastardized culture in a sense, right? And you go through all of these different points in time throughout American history. So I needed to rediscover like what that was, thousands of miles away from where I live, and how I'm connected to that, you know, because oftentimes you feel like the hyphenate between the African and American. You're really not either one. You know, so it was, what is it to be African? Because this is a movie, Wakanda's African, and it's not African American. And, you know, one of the little things that Ryan was so brilliant at doing in the film with Killmonger's character, who's the villain, if you haven't seen it. Has everybody seen Black Panther? Is that a thing? Awesome. So Killmonger, played by the fabulous Michael B. Jordan, if you notice something about him is his names. And part of the reason behind him having so many names is because, you know, our American ancestry is that we have been given so many names. We were Negroes, we were black folk, we were colored, we were Afro-American, we were African-American. And that's sort of how this has gone over time. So what Ryan did was he gave Michael Jordan the Njidaka name, but they also called him Eric. They also called him Killmonger. They also called him Eric Stevens. So he's that representation of African American, never having a true identity. From different places and different people called him different things. And that's the tie back. And those are the types of things that we were trying to do. That is a piece of representation in a sense. And we'll get to representation because I think that's mostly what we want to be talking about is how that is so important in Black Panther.
Right.
You know, technologically, scientifically, you know, through your STEM, and then also socially and economically. And so there's so many little things that we did in there. I mean, it goes so deep into how we brought in the representation, and that was one of them. And it was in such a small story way that you don't even really realize that's what's happening, because Shuri calls him Eric Stevens, T'Challa calls him Njidaka, his father calls him, you know, Ross calls him Killmonger. His father calls him Eric, you know. Wow. So it's, he doesn't have an identity, and he's going to Wakanda to try to figure that out. Wow. And that's sort of the representation of where we are as sort of the lost tribe, as we called it. I'm
such a Ryan Coogler fan, so I'm like, I can see that detail. I didn't see it.
Small
you
detail.
Described it. When we were talking last week about representation,
yes,
you mentioned the production designer Wynn Thomas, and I looked up Wynn Thomas. I hadn't heard his name before. And he has credits for Hidden Figures, A Beautiful Mind, Analyze This, all of Spike Lee's movies. So you mentioned seeing him on television or something?
I saw he was nominated for an Academy Award for Mars Attack, the Tim Burton film. And I happened to be watching the Academy Awards that year, and I was like, oh, who's this black man doing this thing that I want to do? And that was really the first time that I really saw that. I was like, oh my goodness, what is this? Because I'd always been a big fan of Bernardo Bertolucci, who is an Italian director, back in the 50s, 60s, 70s, and in 80s. And his designer, Fernando Scarfiati, was someone who was really a big influence to me. He was this Italian man way back when, but my design aesthetic, you know, is highly influenced by his. But seeing him never made me feel like, yeah, I can do that, because he's this Italian guy. You know what I mean? Like, of course he can. He's an Italian guy. Like, I'm this farm girl from Ohio, you know, who literally runs around with bare feet and riding my horse to the store to get Jolly Ranchers when I was like 6. Like, how do I get to that?
Right.
How do I get, there's no path for me there. So I kind of started thinking, like, what are some of the other things that I could do where there might be a path that's still creative, and that's how I had to think, knowing that that wasn't something that was for me. But then when I saw Wynn, which was much later in my life, that's when I realized, like, you know what, I can actually go for this. I mean, that didn't actually mean that I could go for it, but seeing it certainly made me feel that way. And I took that chance, and that gave me an opportunity to get into this industry and really go far. I mean, as I got into it, I realized, like, oh, this is really hard. I'm the only one. And I am the only one. And that's a really strange thing, to think that you are the only black female who does this, who does what I do. And at this level. You know, there's one other one, Tony Barton, you know, and she's an art director working on television for Marvel. And I kind of saw her on Twitter, and I was like, you know, like, let's be friends. And she's like, I don't even know you. And I'm like stalking her on Twitter, like, I want to be girlfriends. And she's like, okay, maybe call my agent. Maybe don't. But we finally kind of, like, I broke her down, and she finally decided to be my friend. And we're kind of besties. Don't quote me. And don't go up to her and be like, Hannah said you were besties, because she'll be like, I don't know who she is. But that's, you know, you want to find likeness. You want to find relatability. And when you look at communities, I think, you know, one of the other things, too, is when you look at communities who are associated with not, like, having a lot of tech and not, you know, having access to a lot of tech, and you start relating, you know, your economic status to your racial profile, that all of a sudden, especially in poverty, the black community becomes associated with this idea of not being tech savvy or wanting tech or having that type of thing. Do you know what I mean? Within their community. And it's basically all based on accessibility. It's not there because how many representation is not just in front of whatever it is, you know, or like throwing the pretty on it that seems to be representing a group or a culture, but actually having the voices creating it. You know, is it how, you know, you look at it like, was it important for me to be the production designer on something like Black Panther? You know, or the Infinity Wars designer Charles Woods, would he be able to have then done that? And so I do believe that the representation behind the camera, I'll say, because that's what I do. I mean, behind the desk, I don't, you guys stand, or I don't, I don't, you know what I'm saying? Or however it goes, is as important as creating an app or creating something, you know, specifically as having the voices there that then has the experience in those communities. Because you really don't know what you don't know, and that's what I learned by going to Africa. Like, I don't know what I don't know, but I knew that I was going to look at it with beauty. I knew I was going to look at it with the lens of absolute modernism and beauty and capability, all the things that I wanted to put into Panther. Like, I wasn't looking for the commercial with the poverty-stricken children. I wasn't looking for the things that we're told the continent is. I was looking for the joy and the pride and the dignity of the people that lived there. And, you know, that's the choice we make for wherever we are, because I met people who lived in the rural parts of Africa just as much as people lived in the modern cities like Johannesburg and you know, we were in Durban, we were in Cape Town. So it's you know, you could see someone dressed in their traditional Zulu or traditional Xhosa and in the city. You know, just as much as you might see that in the rural areas. So I decided not only to find myself and realize that I think I've been African this entire time, but that I was determined to find all the beautiful things that I, you know, was told weren't there. You know, because that then really came back to who I am as a person. You know what I mean? It really related back to who I am and how I felt about myself and the confidences I had. So it all kind of like, our fictional world building bleeds back into our realities.
We have 2 minutes left. Could you share a nonfiction story you shared with me that moved me very much, which was about the director Ryan Coogler, who I'm a huge fan of. And I've always, when in Silicon Valley we talk about leadership, you know, CEO, or the product manager is the CEO of the product, and all these CEO-ish things. I think of Ryan Coogler as one of the great CEOs of our time and creatives.
Yep.
And you shared a story about him. Could you talk about
when
that?
I was talking to myself?
Yes.
So you obviously know I'm kind of weird. So I'm going to tell this story. Don't hold it against me. But so we're working on Creed, and we're tech scouting, which is we go to look at all these locations, and you can spend all day. And we had stopped at this coffee shop. And I got my coffee, and everybody was getting their coffee, but I was kind of working out a problem. And when I'm trying to work out a problem or solve a problem, I talk out loud to myself, because that's the best way to do it, for me, apparently. And, you know, my friends and stuff were like, poke fun at me, like, oh, you're crazy, you're talking to yourself. And so, you know, sometimes I do, and I don't even know I'm doing it. So Ryan comes walking over to me, and he was like, are you talking to yourself? And I was like, you know, a little like, oh, you know what I mean? I know you and love you, but yeah. And the first thing he said, he looked at me and he said, that's a sign of a really healthy mind and a really intelligent person. And he kind of turned around and walked away. And I was kind of like ready to get the hit of like, oh, you're crazy, you know, kind of funny joke, but a little bit like of a slight. And that's not at all where his mind came from. It looked for the immediate positive thing about the thing that I was doing that sometimes people think is weird or could make you feel a certain way about yourself that eventually starts beating you down and making, you know, defining who you are because you're hearing negative things about it. That is who Ryan is. He's the person that will constantly lift people up, you know, will constantly, and he's not perfect, I promise. There's days when I'm like, please make a decision. You have like 2 hours. But, you know, and he does all the things that directors do that can, you know, completely bother you, or things that are like amazing. But he's the type of person, like we would be on set for Warrior Falls, which was the big waterfall where they had the big fight. And he gathered us all around in a big circle. You know, some people were in the water, and he really told us why that scene was important. This is before we even started shooting. He really started to say why that scene was important to him, and really talked about having all the fictional tribes of Wakanda in one place and represented by all the references that we use of the tribes, the different tribes in sub-Saharan Africa, and how that was a part of him really feeling complete. And, you know, you were holding hands, and he's telling us all this, and we're standing in this circle, and you just feel like you can take on the entire world, you know, at that point. So that's who he is as a director and my friend. And he's a really important voice because his perspective on anything and everything is the most unique perspective you will, I promise you, ever hear from anybody. If you ever get a chance to talk to him, because he will turn a situation and make you see it from a side you were never maybe even meant to see it from, and all of a sudden your world opens up. And so I can always, and he would be standing here going like, oh, please stop, but but he is really that great. So
well, thanks for sharing that story. What a leader and what a designer. Thank you, everyone. Thank you.
Welcome to Google I/O. For someone like me who grew up without a phone, I can distinctly remember how gaining access to technology can make a difference in your lives. That's why we've been so focused on bringing digital skills to communities around the world. We have trained over 25 million people, and we expect that number to rise over 60 million in the next 5 years. Healthcare is one of the most important fields AI is going to transform. We announced our work on diabetic retinopathy, and we use deep learning to help doctors diagnose it. We can predict the 5-year risk of you having an adverse cardiovascular event, heart attack or strokes. We've been working with our partners using de-identified medical records. It turns out if you go and analyze over 100,000 data points per patient, more than any single doctor could analyze, we can actually quantitatively predict the chance of readmission 24 to 48 hours earlier than traditional methods. It gives doctors more time to act. We are bringing another feature to Gmail, Smart Compose. We use machine learning to start suggesting phrases for you as you type. All you need to do is to hit tab and keep auto-completing. Another product is Google Photos. So we are bringing a new feature. If you took a picture of a document which you want to save for later, we can recognize, convert the document to PDF, and make it much easier for you to use later. Or if you happen to have a very special memory, something in black and white, we can recreate that moment in color and make that moment even more real and special. And we are adding, as of today, 6 new voices to the Google Assistant. John Legend's voice will be coming later this year so that you can get responses like this.
At 10 a.m., you have an event called Google I/O Keynote. Then, at 1 p.m., you have margaritas. Have a wonderful day.
I'm looking forward to 1 p.m.
Today, the Assistant is available on over 500 million devices. Now, by the end of this year, the Assistant will support 30 languages and be available in 80 countries. But one step that we've been working on is something we call Pretty Please.
Hey Google, talk to Voicetron.
Daddy, you forgot to say please. Tell me a story, please.
Thanks for asking so nicely. You're very polite.
I know.
So the Assistant understands and responds to positive conversation with polite reinforcement.
Now, sometimes the Assistant can actually be more helpful by having a lower visual profile. So let's say I'm heading home from work. I have Google Maps showing me the fastest route during rush hour traffic. Hey Google, send Nick my ETA and play some hip-hop.
Okay, letting Nick know you're 20 minutes away and check out this hip-hop music station on YouTube.
Let's say you want to ask Google to make you a haircut appointment. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you.
So how can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd.
Sure, give me 1 second.
That was a real call you just heard. The amazing thing is the Assistant can actually understand the nuances of conversation. We've been working on this technology for many years. It's called Google Duplex. It brings together all our investments over the years in natural language understanding, deep learning, text-to-speech. I'm really excited to announce the new Google News.
With the new Google News, we set out to help you do 3 things. First, keep up with the news you care about. Second, understand the full story. And finally, enjoy and support the sources you love. Our AI constantly reads the fire hose of the web for you, the millions of articles, videos, podcasts, and comments being published every minute and assembles the key things you need to know. We're also excited to introduce a new visual format we call newscasts. You are not going to see these in any other news app. Newscasts give me an easy way to get the basics and decide where I want to dive in more deeply. Full coverage is an invitation to learn more. It gives a complete picture of a story in terms of how it's being reported from a variety of sources and in a variety of formats. This is by far the most powerful feature of the app. And here in the newsstand section, it's easy to find and follow the sources I already love and browse and discover new ones. And if there's a publication I want to subscribe to, we make it dead simple. Because you're signed in with your Google account, you're set. We're rolling out on Android, iOS, and the web in 127 countries starting today.
Growth of Android over the last 10 years has helped fuel the shift in computing from desktop to mobile. And as Sundar mentioned, AI is going to profoundly change industries. And this brings me to the new version of Android we're working on, Android P. Adaptive Battery uses on-device machine learning to figure out which apps you'll use in the next few hours and which you won't use until later, if at all, today. With Android P, we're going beyond simply predicting the next app to launch to predicting the next action you want to take. We call this feature App Actions. What's happening here is that the actions are being predicted based on my usage patterns. The phone is adapting to me and trying to help me get to my next task more quickly. Slices are a new API for developers to define interactive snippets of their app UI that can be surfaced in different places in the OS. With MLKit, you get on-device APIs to text recognition, face detection, image labeling, and a lot more. And MLKit also supports the ability to tap into Google's cloud-based ML technologies.
Our team has heard so many stories from people who are trying to find the right balance with technology. One of the first things we focused on was helping you understand your habits. Android P will show you a dashboard of how you're spending time on your device. As you saw earlier, you can see how much time you spent in apps, how many times you've unlocked your device today, and how many notifications you've received. Android P lets you set time limits on apps and will nudge you when you're close to your limit that it's time to do something else. If you turn your phone over on the table, it automatically enters Do Not Disturb, so you can focus on being present. No pings, vibrations, or other distractions. You can tell the Google Assistant what time you aim to go to bed, and when that time arrives, it will switch on Do Not Disturb and fade the screen to grayscale, which is far less stimulating for the brain and can help you set the phone down. Well, today, we're announcing Android P Beta.
Maps was built to assist everyone. We've mapped over 220 countries and territories and put hundreds of millions of businesses and places on the map. We're adding a new tab to Maps called For You. It's designed to tell you what you need to know about the neighborhoods you care about, new places that are opening, what's trending now, and personal recommendations. We've created a score called Your Match to help you find more places that you'll love. Your Match uses machine learning to combine what Google knows about hundreds of millions of places with the information that I've added.
Let me paint a familiar picture. Your phone says, head south on Market Street. One problem, you have no idea which way is south. So you look down at the phone, you're looking at that blue dot on the map, and you're starting to walk to see if it's moving in the same direction. Our teams have been working really hard to combine the power of the camera, the computer vision, with Street View and Maps to reimagine walking navigation. So here's how it could look like in Google Maps. Notice that you also see the map, so that way you stay oriented. You can start to see nearby places, so you see what's around you. Now, with smart text selection, you can now connect the words you see with the answers and actions you need. So you can do things like copy and paste from the real world directly into your phone. You're at your friend's place, you check out this trendy-looking lamp, and you want to know things that match that style. And now Lens can help you. You open the camera, and you start to see Lens surface proactively all the information instantly. And it even anchors that information to the things that you see.
Waymo is the only company in the world with a fleet of fully self-driving cars with no one in the driver's seat on public roads. So Phoenix will be the first stop for Waymo's driverless transportation service, which is launching later this year. Soon, everyone will be able to call Waymo using our app, and a fully self-driving car will pull up with no one in the driver's seat to whisk them away to their destination.
Hi, IO Live, it's Todd Kirkleman, and I am here with Asad Naweed, who is a software engineer on ARCore. So, Asad, what's new in the world of augmented reality?
Hi, Todd. So today at I/O, we're announcing two new features in ARCore that we're really excited about. We are announcing augmented images and cloud anchors.
Okay, those sound very impressive, but what are they? What's augmented images?
So augmented images is a set of APIs inside ARCore that allow developers to create AR apps that can recognize images in the real world and then anchor virtual content with respect to them. So if your app can recognize an image, let's say this portrait up here, then it can make that image come to life and overlay virtual content on top of that image and make it do interesting things that weren't possible before.
So what kind of apps do you see taking advantage of augmented images?
One other thing that I'm really passionate about is education. And children's education in particular, you could create an app that recognizes the images in a children's storybook. And if kids previously, when they're just reading a storybook, can now point their cell phones at the storybook and then see the story come to life on top of their books, right there and then.
Alrighty, let's check out one of these demos here.
Yeah, so this is augmented images. And we'll see that ARCore finds this image and then makes it come to life like that.
Whoa!
So this is what I was talking about when I meant immersive experiences, is that as we move the phone slightly at an angle, we see that the 3D model actually turns with us. And if we end up going a little closer, we'll see that the effect is much more pronounced. You can actually take a look at the structure of the cubes as they are there, and it's so much more immersive than the standard 2D painting, because now you have this box that's reaching into the wall, and the image is no longer there, and it's actually been superimposed by this 3D model that's dynamic and can move, and I can get different perspectives on it depending on where I am. So yeah, that's what's really exciting about this.
And is this a phone with any special hardware, any special features? What is this that we're looking at this on?
So this is just a phone that's running ARCore, and ARCore doesn't have any specific hardware requirements, short of maybe just like a good camera and a good gyroscope and accelerometer, but that's about it.
All right, and here we have another augmented image. Let's see what's going on here.
Yep, so this is another image that the app knows how to recognize. And now that it's done that, we can see what grows as we move the phone up. And this then grows into like a massive tree that an artist has put together that's rooted at the augmented image. So if you keep going all the way up, you'll see that it becomes like a really, really, really nice tree. And as you bring the phone down, the tree will ultimately sink back into the augmented image that it detected. So these are the kinds of visual experiences and like things that come to life rooted at images that the app knows how to recognize. And that's what we're really excited to see what developers are going to do with.
Wow, that is super cool. I could actually just stay here all day and watch the tree grow and shrink, but I think I have other interviews to do.
No, you're more than welcome to come back when you're done.
All right. Well, if you need me, folks, I'll be hanging out here making augmented reality trees grow. And then the second piece of technology we were talking about were cloud anchors. So what is that, and what does that allow me to do as the developer?
Cloud anchors allow you to create and host anchors, AR anchors, and share them between different people and different devices. And that's really exciting, because then suddenly you have the ability to create apps that two people can use together to anchor content in the world and see where other people have anchored content in the world as well. One other thing that we're really excited about is that the cloud anchors are actually cross-platform. We're also really excited to announce that anchors created on ARCore devices will also be recreatable on iOS devices running ARCore on iOS. And that opens up the door to so many different possibilities and a significantly larger user base. So now iOS developers can also use ARCore cloud anchors.
All right. So basically, we are setting up a multiplayer game where both devices, an iOS and an Android device, are agreeing on the same augmented reality space that they're sharing. Is that basically what's going on here?
Yes, that's exactly what's going on here, Todd. I have in my hand an iPhone that's running ARCore on iOS, and Brian has an Android device, and we are going to play the same game together. And
all right, let's give this a try here.
You can see right there is where Brian has placed his board, and I will place mine here. And when I am ready, we are now going to play a game where I have to fire onto Brian's light board. And when I do that, it effectively lights Brian's board up. And then he has to color all of my shots, all of my dots before I manage to do the same thing for him. And he is seeing these boards in the exact same place that I am seeing them in. And I can see him playing the game with me, and the only reason why this shared AR experience is possible is because of the magic of cloud anchors. Woo! So yeah, just to kind of like reiterate, this is an iPhone. It's not an Android device, and we do have ARCore Cloud Anchors supported on both iOS devices and Android devices, and we're really excited to see what developers are going to do with this.
That is super awesome. I can't wait to play some really fun augmented reality multiplayer games around my living room.
Well, definitely, and yeah, it's a blast for everyone, like the whole family, yeah.
Oh my gosh, that was super cool. If you want to see more exciting videos like this one, head on over to g.co/io/guide for lots more videos featuring me and the rest of the I/O Live crew.
You guys see it, right? Go. Okay. Good afternoon, everyone. Welcome to the AIY introduction session. How's everybody for I/O so far? Everybody had a good lunch today? Yes. Okay. As you can see on the screen, the name of this session is called Introduction to AIY. Well, what is AIY? AIY is a new line of product makes for developers like you, makers all around the world, to applications for artificial intelligence by yourself. That's the name of AIY, where that came from. Today, join with me, my colleagues in developer relations. My name is Bill Luan. I have Dushan, Sebastian joining me. We will give you a full introduction of the current AIY product line. So before we start, let me introduce my colleagues, my product line. So before we start, let me introduce my colleagues. So Dushan.
Hey, thank you, Bill. Hello, everyone. My name is Dushyant. I'm part of Google's developer relations team in India. I'm really excited here to show you some amazing demos on AIY Voice Kit. But before we start, I'll invite Sebastian to give you a quick overview of what is AIY and kind of set the context for this talk.
Thank you, Dushyant. So thank you very much for being here in person or watching this on YouTube. I'm Sebastian with this very complicated last name. I've joined Google quite recently, just about 11 years ago. And with my teams, what we do around the world, especially in emerging markets, is we help developers and startups build better mobile and web applications. Today, I want to talk to you about AIY. But before this, let's talk about DIY, do it yourself. So do you know what this is? It's not a UFO. It's actually a musical instrument, which makes very nice sounds. But no, it was not invented in prehistoric times. It was actually created in the year 2000 in Switzerland. Switzerland is actually the country where I'm officially based. Well, that is when I'm not in one of the other UFOs, which we call planes, because I travel quite a bit to visit my teams. Do you know what this is also? It's a window into DIY culture. Let me take you through a very brief history of humankind's appetite for DIY. And if you read the book Sapiens, A Brief History of Humankind, you'll know what I'm talking about. Our human ancestors were already building tools, as probably you know, weapons, instruments, using stone and wood. Now, if we skip a few generations of humans, we're still using wood to create things. This is one of my brothers, Matthias, and my sister, Lydia, some 30 years ago. And I'm sure you or your siblings did the same thing, tinkering with stuff or everything you could lay your hands on. Now let's fast forward to what I call the electronics age. Do you remember in the 90s how desktop computers, I'm not even talking about laptops, but desktops, were so expensive? Who among you, show of hands maybe, to see who built computers with their, with spare parts? Yeah, I did that too, quite a few of you. And I'm the only one who's too old for this. On this animated image, you can see how I've used an overhead projector and a dismantled LCD screen to build a cheap homemade video projector. But then obviously, my mom got annoyed because all the electronics were everywhere in the living room. So she said, go outside, you need some fresh air. Okay, so I went outside, and that's me reusing garbage bags. $1 of garbage bags to build a solar balloon. It can almost lift me up. Not quite, but I'll get there one day. But the appeal of electronics was just too strong. So my siblings and I got back inside, and one of my brothers, the other one, Florian, started tinkering with 3D printers, homemade 3D printers. This is my other brother, the one on the right. On the left is actually a photo in the museum. As I said, DIY is in our DNA from very, very early on. It's also in Google's DNA. 4 years ago, you may remember a Google engineer from the Paris office, and I mentioned Paris because I'm actually French. And this engineer came here at I/O to show the VR platform he had built using cardboard during his 20% innovation time. Since then, this has become, 2 years ago, what we call the Daydream VR platform at Google. Here's what's interesting now. The maker culture is all about hardware on one side, physical objects, and on the other hand, software. This combination of DIY culture with a hacker culture. You may have heard of Maker Faire since 2006. You may have makerspaces around you, and if there's none in your city where you live, then why don't you start one of these makerspaces? The great thing about this maker culture is that you learn through doing, with your hands. You make mistakes, so what? Doesn't matter. That's a very good way to learn. So try new things and learn from each other. Figure out new applications that you can create with that technology. It doesn't matter what your background is. In fact, it's even better when you can mix and match different domains to find new applications of the technology. Now let's take a look at what has happened in the past few years. You now have microcontrollers like Raspberry Pi. The cloud has become cheaper. Lithium batteries have become cheaper. Did you know that lithium batteries, their cost has decreased by 80% in 8 years, over the past 8 years? And I'm sure you've heard about AI, artificial intelligence, especially since yesterday, right? And concepts like machine learning, deep neural networks. It sounds complicated, right? It doesn't have to be. It doesn't have to be. And this is why, with AIY, do-it-yourself AI, artificial intelligence, that we introduced last year, you can have fun. Because the idea of this maker culture is, before anything else, to have fun. Using, in this case, artificial intelligence, we want to put AI literally in your hands so that you can solve real problems. Our AIY kits are open source. They combine hardware and software, and they integrate AI directly on the device themselves. The essence, as I mentioned previously, is to keep it low cost, using readily available components that you can find almost anywhere on the planet. And the kits are very easy to assemble. Dushyant, how long does it take to assemble one of these kits?
15 to 30 minutes.
15, 30 minutes. OK, let's say 1 hour, because my mum's going to say I'm very clumsy. Thank you, Mum. I know she's watching. So let's say not more than an hour to assemble these kits. Dushyant and Bill, right after, in just a few minutes, will demo some of these kits to show what you can do with them. So the voice kit and the vision kit. But stay with us. In the coming weeks and the coming months, there'll be more to announce in that space. Now let's take a look, and I'll finish off with this, at what some of you have already created. In this example, I'm going to show you in just a few seconds, a 16-year-old with no programming experience has managed to come up with the following use case. Let's play the video for just about 20 seconds.
Shop for New York Yankees baseball hats. So what's actually happening now?
Woo!
So she just said done, right?
Yep.
Okay.
So what actually happened was that when it said done, it's just sent links to my email.
Okay.
After finding it on eBay. So it'll find results online, send links in an email to me, and I'm going to receive those so then I can quickly click and buy something.
So what happened here with Lawrence and the high school kid was shopping for a product. I don't know if you heard at the beginning. I'm shopping for some baseball caps, and was searching on eBay for results, which were emailed right after when the device said done. So let me take you through the code. It's just a few lines of code. It's not 100 lines. It's not 1,000 lines. It's just about 20, 30 lines. And I want to show this to you to show that even if you're not an experienced programmer, you can actually learn from that. I'll keep it very simple. The first line that you can see here is this action triggered when the user presses the button on top of the device. Now let's examine what happens next. We take the words that were said and store them in a local variable called keyword at the bottom. And what happens next? We import a range of libraries. Now don't worry. You can be like me. You don't have to understand all the libraries. Just copy and paste it. It works. You try to understand afterwards, which library does what. After all, it's all about learning by example. So when I said it's about learning by doing, this is exactly what I mean by that. Just copy and paste the libraries that you need. A few lines here. And after that, we're going to call the eBay API. This is the line that you see in the middle. And with that line, we get the results back from eBay, and we're going to read these results, as you can see at the bottom. And finally, what we do, you may remember in the video that all the results are sent over email. Here's the code. We're going to go through each result, the first 3 lines of the code up there, and format all this in an email. You can recognize, right? Even if you're not an experienced programmer, like something like from to subject line. That's it, nothing more. The last thing we do is just connect to the server, the email server, and just send the email and get the device to say, done. That's it, there's nothing more. You can literally copy and paste that code. It will work. Now it's your turn to do things with AIY. And if you're not inspired enough, I'll have Dushyant now to come on stage to do a demo with a voice kit. So thank you very much for listening, and welcome Dushyant back on stage.
Thank you, Sebastian. My name is Dushyant. I'm part of a developer relations teams at Google. And like everybody, we all are excited about the possibility of AI has in front of us, correct? This only becomes more meaningful and more impactful when all of us kind of have an access to this wonderful platform. At Google, we have been sharing our work and advancement in the field of artificial intelligence by building products, sharing through our research papers, and now with the AIY kits, we are taking to even more people in a more playful way. Yet, it is strong enough for you to solve some really good problems. So let's see how we can kind of solve some of those things. And when we are thinking about this kit together, we're thinking, what makes sense, correct? What would be a right way of putting this in front of people? And of course, voice was one of the things that was very evident, correct? We all like talking. Imagine if we have a power of playing around with a voice, how fun it would be. Sundar did mention in the keynote yesterday about WaveNet, correct? How you can kind of create different voices. So in this demo, I'm just going to talk about the capabilities of AIY Kit with Cloud Speech API and Google Assistant API. But of course, there's much more than this. So the Voice Kit was launched sometime mid last year, if I'm not wrong. And it had got a lot of attention. The Voice Kit basically has a combination of few software and some of the hardware there. It was marketed along with Raspberry Pi Foundation to kind of see what are the feedback we can get from the existing Maker community and try to improve our offering. We launched the second version of Voice Kit sometime in January to kind of incorporate all those feedbacks and make it all in a one-box component kit. So that's what you get today. If you go to AIY website and look at Voice Kit, this is what you'll probably find there. But what does the kit contain, correct? From a hardware point of view, it has Raspberry Pi Zero. It has Voice Bonnet, which is basically a piece of hardware which understands which does a lot of audio processing for you. And the Voice Bonnet has different components. It has a mic, it has a codec, microcontroller, general purpose input-output, and an arcade button to basically kind of give you visual indication of what's happening with your Voice Kit at any point of time. And from a software point of view, it basically runs on Raspbian Linux, correct? It uses Google Assistant API and uses Cloud Speech API. But of course, you could do a bunch of things with that. This is just scratching the surface of the Voice Kit. So how can you get started? Very straightforward. Think of it as a three-step process. Step 1 is in terms of assembling the kit. Step 2 is setting up your device. And step 3 is now you have set up everything, you could kind of go ahead and build some of solution by yourself. So if you open the kit, this is what it looks like. First thing, ensure you have all the right components. Like you have a cardboard, all the different hardwares that is mentioned on the website. Just verify that you have all those components ready with you before you start assembling together. Once you verify, the next step what you need to do is kind of build an engine. Think of it as building a car, correct? You're building an engine. So putting Raspberry Pi and your Voice Bonnet together. Once you kind of put the engine together, then now you're building a chassis, correct? So it's a kind of structure for your car or structure for your Voice Kit. So you basically take it, cardboard and kind of give it a structure of a speaker. Once you build the cardboard, then you put the engine inside it. You put the kind of Raspberry Pi and Voice Bonnet inside it. That's it, correct? It's super easy, super fun. For me, when I tried first time, it took somewhere around 15 to 20 minutes, but I'm sure you guys are much advanced than me, and you could kind of try to even faster. The key here is not to do fast, but kind of do it in a nice, fun way out of it. So yeah, that's it. You kind of assembled your Voice Kit. Step 2 is basically set up your device, correct? At this point of time, what you want to do is that now I have my device or my Voice Kit is more or less kind of in a nice shape and form. Let me kind of give a voice to it. Let me see if everything is working fine. So I have a already built Voice Kit here, and I'm going to switch back to my Voice Kit and see if everything is working fine there. Can we switch to demo? give it a second. It should be. Yes? Sorry for the glitch. I think I'm booting up my machine here. Yes. And it's live. So before you start, you want to kind of ensure that you have everything running for you. So things like, let's say you're connected to network. This could be either a wired network or a wireless network, or if you're tethering from your phone, just ensure you have some sort of connection, because a voice kit needs to be connected to internet. Underneath it's using Google Assistant and Speech API for recognition purpose. So let's see if this is my Wi-Fi, but I'm not using Wi-Fi. Let me see if I'm online. And cool. Looks like I'm all set from an internet point of view. Let's see if my audio is working fine, or the kit audio is working fine.
Front, center.
Seems okay. Let me see if it recognizes my voice. Testing 1, 2, 3. Testing 1, 2, 3. Seems to be okay. So now I'm almost set, correct? The good thing is that VoiceKit comes with some of the pre-built demos as well. It's good to kind of see if those are also working fine before you kind of start building yourself. So if you go to the Py directory and look at Python voice examples, which is here. And I'm just going to try this library demo. Cool. OK, Google, what's time right now? OK. Sure. OK. Let me try one more time. Let me try with this one. Hey, Google, what's time right now?
It's just a bit shy.
Okay. We'll try one more time. Otherwise, we'll just kind of walk you through what it does at this point of time. Is that whenever I say something, OK, hey, Google, what's the time right now?
It's 1:50.
Thank you. So you could try a bunch of things. I mean, what I was doing is that I was just testing if things are working fine. Now, of course, you could, at this point of time, ask a bunch of other questions, like, hey, Google, what's the distance to moon? OK. But at this point in time, what it would have done is that it would have looked at some of the services available online and try to kind of fetch an answer for you and display it to you. Now, things are kind of, seems to be OK. Let me see if we could, if we can build something or not. Let me go back to presentation. Can we go back to slides? Yeah. So our device was kind of, so it's always good to see if device is working fine before you kind of start building by yourself. I have build a typical shopping experience. Hopefully, it should work fine. But let's see, given the setup was not really up to the mark. But let's give it one more shot. Can we switch to demo? So Sebastian did show, correct? He was showing the code, which was mostly about, giving a command to a voice assistant saying that, okay, shop for something. And then it was trying to identify a text, and it was calling one of the API, which was from eBay, I believe, and then trying to basically fetch some of the result and send it as an email. I've tried to mimic similar behavior. And let's see if demo gods are with me. So what I'm doing at this point of time, I'm just going to ask for maybe shop for something, correct? There's a Mother's Day is coming up, and I won't be in time for it, and I want to send something to my mom. And I was thinking, what could be an interesting thing? Apparently, the smartwatch is a big thing. So I thought, okay, maybe let me gift her a smartwatch. So let's see if I can find a smartwatch using my voice kit. Hey, Google, shop for smartwatch. Cool.
Done.
So if you look at what it did, it basically recognized my voice or my command, and it connected to that particular service and displayed some of those smartwatches available for me to purchase it. Now at this point of time, I could take this output and either send an email, like what Sebastian was mentioning, or if I have a smart display device, I could basically post it there, or give a nice visual list that, okay, these are some of the things, or I could engage in a little bit more conversation with that. Can we move back to slides? But there are tons of things you could do that, correct? What I was trying to emphasize here is that, there's a lot of things possible with the voice that you could play around with it. You could also not just look at the software as a one side of it, but you could also experiment with some of the things on hardware. So let's say we have seen people taking the old toys and putting the voice kits or some of the other AI kits into it and revive the bodies or bring life to those toys. We have seen people build customized shells for voice kits. There are people who have done device remix, so giving voice and vision to a Roomba vacuum cleaner. So you could tell them, okay, no, don't go to this side of a house, but go to the different side of house section. Or you could create completely custom voice actions. So tons of things is possible. If you want to know more about what is there, you could follow us on Instagram or Twitter, or follow the discussion on Reddit with AIY projects. With that, I'll invite Bill to know more about what's happening on Vision Kit.
Thank you. Thank you, Dushyant. Is my voice okay? All right, let me continue with the second product line in the AIY product family, which, as you can see, is the Vision Kit. The Vision Kit is a relatively new product, and it's just being released end of last year. And we had a new version update the first quarter of this year. So the latest version is 1.1. As you can see, launched in December of last year. It has the latest Raspberry Pi Zero, and the WH, the header, it's soldered on the board. So it doesn't have the problem in the early version that you have to solder the pins yourself. It's much easier. It comes with the Raspberry Pi camera version 2 and the Google-made Vision Bonnet circuit board. And that's where all the software, hardware, artificial intelligence, where Google put into the product. It's on the Vision Bonnet board. The most unique things of this particular product, it doesn't require you to connect to the internet. You can work with a vision recognition software on the box by itself alone. So before we start, let's go through the list of materials that Dushyant did for the voice kit, a similar thing. In terms of the hardware, as I mentioned, it has the latest Raspberry Pi Zero board and the camera. And Google produced this Vision Barnet. This Vision Barnet circuit board contains the Intel vision recognition processor, which has all the computing power to help you do the vision recognition. In addition to that, it has the camera support, and it has the connections to the Raspberry Pi cable connector. It also has the general purpose input-output, so-called GPIO connector, allow you to do more things, which I'm going to cover shortly. And also, it has the crypto chip on board, help you to encrypt the signals, okay, to add more securities in terms of the application. Then on the software side, and also has the button, as well as the cardboard form, allow you to fold into the device. On the software side, the operating system is the same. It runs on the Linux Raspbian operating system. We include a TensorFlow, the so-called Inception and MobileNet software. It's on the device, which allow you to build AI models to work with this device to do applications in AI. It has the built-in software for facial recognition, as well as the general object recognition. So all these software is on the device. You're ready to use. And in terms of its component, let me get into a bit more detail because this is a relatively new product. On the hardware level, at the bottom, which is the Raspberry Pi Zero with the head soldered on, as I said, the Raspberry Pi Zero has the built-in Wi-Fi and the Bluetooth support. So you can connect the internet if you want without a cable with Wi-Fi connects to internet. It has a GPIO connection, which allows it to connect directly with a flex cable to the Google Vision Barnet circuit board. That circuit board with additional flex cable connects to the Pi camera, as well as the additional accessories like the LED and the push button and the buzzer. There's a piezo buzzer on the device that as your application necessary, you can have it generate sound. Then on the software side, it runs on the same Linux Raspbian operating system, and the program runs is all in Python code. So it has the Python interpreter on top of that. And at Google, the software we put together contain 3 different modules, if you will, in terms of the vision process. The first is the TensorFlow module that does the vision inception. Second, it has the facial detection software. And the third has the object detection software. So with these software on board and with all this hardware, and you, through the API calls, write your applications interface with these components. So this is how everything put together. Okay? And then let me go through the same process Dushyant mentioned in terms of the voice kit. So first is you assemble it. In terms of assemble, very similar. You bought the box, it has these parts, cardboard, whatever. As you can see on the screen, in terms of the process building is relatively easy. You basically hook up the Raspberry Pi with the Vision Barnet cable, with that orange color cable, hook them together, stack them together, and then fold the car box, insert this module into the middle, almost like you put the engine in the car, as Dushyant mentioned, right? Hook up the button, and that's it. I can build this thing. First time I built it, about 40-some minutes. Second time I built it, it took me only 20 minutes. So it's very simple. In fact, I have a plug for myself. I made a video tutorial of how to assemble it on YouTube. So for those of you who don't want to read the instructions, you can watch the video. Okay? But it's very simple, very easy. Okay? All right, so to assemble that, congratulations. In less than an hour, you'll be able to just build a device like that. Okay, in terms of setup, this is very simple. As I said, this does not necessarily need to hook up to the internet. So the connection is all you need is just a power supply. Have a power supply connects to it, and you're ready to go. And because of the facial recognition software we're building into the device, after you power it up, it will automatically run the facial detection software. So right now, on the desk, I have this Vision Barnet with me, And as you can see, the top LED blue light, the button is lighted up. Now, if I point this to my face, as you can see, the blue light indicating the camera is capturing my face. If I show to the camera with a smiley face, a happy face, the light color of the LED will change to yellow. And if I'm showing a frowning face, it will go back to blue. So let me demonstrate this. Can everybody see, right? It changes the color. Now, let me say, this is not some kind of a magic. It is AI at working. So what happened, it is a software inside with the AI TensorFlow model with the facial recognition. Actually, I'm going to get into in a minute, to make a facial recognition software just like that. So there's not much of a setup. Just power on, hook up the power, and you can do facial recognition. This demo is called Joy Detection. Okay? It's a part of a product we ship with the device. All right, so assembly, very easy. Setup is very easy. How to make your own solutions. Okay, there's a lot of software you could do. And let me do another demo. So please switch the screen to the output of my other device. Do we have output? We lost the video signal, seems like. It's on, is it? Don't power down. Unplug it yet. Oh, okay, here we go. All right, apologize for the connection glitch. All right, so as you can see right now, I'm running the Raspbian software operating system, and there's a window showing the software. Let me, by starting a simple demo, which is the object classification. So I'm going to start with demo, and as you will see on the screen, on the right-hand side, it will have the camera, the video image coming, captured by the camera. And on the table, I have an apple and a banana, and also a Coke can, just some random object that I put together. Now, as you can see on the left side of the screen, there's an output stream out, starting putting on the screen, which is by the object classification software that we put on the device. Now, I'm going to explain all that in a minute. But first, let me do a demo. Let me just point this to banana. And you should see on the left hand of the screen, it will say, it detects this object, a banana, I hope, right? Now, if I point this to an apple, not only it will recognize it's an apple, in fact, it should say Granny Smith. It actually recognizes the type of the apple, okay? And I tried it earlier. I pointed this Coca-Cola can. I don't know what it will say. But earlier, it was telling me, I think it's a punching bag. Well, lots of punching bag, it's red color. It looks like this. So let me stop the application and let me make this window a little bigger. And as you can see on the left side, the first column number, it is the object recognition, it recognizes it. It says it's a banana. The number after that is the so-called confidence score. How confident the AI think this is a banana, or similarly to an apple, which is Granny Smith's apple, okay? So this confidence level tells you the recognition part, whether it thinks it truly is an object it detects. These numbers, these kind of feedback from the software, you can use to make a lot of applications, okay? Let's switch back to the slides. So this, as this image on the screen, as you can see, very similar, right? It recognizes the object along with a confidence score. You can use this number to help you design your applications. So exactly what can you do with a Vision Kit, the AI with Vision Kit? Well, number one, as I said, you can see already does the object detection, and it has a facial detection. This is all software built into it. And through API calls, you can leverage these. It has the automatically be able to take in photos, videos, and send it output to your application. It has the image classification, which you just saw, be able to tell apple and banana, and a whole bunch of other stuff, okay? But most importantly, right, as the Joy Detect demonstrated, you can run your own AI machine learning software in this device by building your own customized TensorFlow model, okay? Now, some of you may be thinking, how do I do that, right? It's a bit confusing in terms of building a TensorFlow model. That's very powerful stuff. How do you do that? All right, so let me introduce to you the process of how do you do your customized model. So first of all, the first number one, every machine learning model you build in TensorFlow, you're building a model to train, right? So specify and train your own model is the first step. And the second, just like any other TensorFlow model, you get the end results, you do a so-called export model to a so-called frozen graph, okay? Any model you can generate a frozen graph. But a frozen graph has its own format. That format does not understood by the Vision Barnet hardware, okay? So somehow we need to make a match. And that match is done, the next step is the so-called compiler. Google provides this so-called Barnet model compiler. You take the frozen graph binary code and compile and run the compiling through the compiler code, you generate a so-called your own customized computer graph, okay? So the artifact-wise is in the end result, you're going through these three steps, you have a binary file. That file defines your machine learning model. Then on the hardware side, of course, we have a Raspberry Pi, we have a Vision Barnet. Raspberry Pi has a Python program. You use the API calls, you send this computer graph, if you will, to the Vision Barnet. So in the next step, you write some code. You can look at our tutorials and the example models. Calling a model function basically is send this computer graph into the Vision Barnet. In this particular case, the computer graph and the Vision Barnet, they match. They understood, okay, what's going on. And then you have a camera coming a stream of inputs. Those inputs are coming as a binary number. But because of this computer graph, we arrange these inputs into whatever the machine learning tensors, okay, which basically is a bunch of multidimensional arrays, okay? So now next step is you need to match this tensor, a bunch of arrays, to the image with your model. And this is what we call do this computing. Basically, the step is you write a program, you have this Vision Barnet hardware, and does the calculation, and will send the signal to the output. And here's the code, okay? How do you define your face object, okay? As you can see, the face object was defined with the bounding box, the face score, and the Joy score. You write an arguments code like that, and this is your structure. You send this structure, okay, and say, in my model, I need this to have 4. And these 4 numbers matches my machine learning model. And finally, in your application code, you just say, let me get results from this tensor, whether the Joy score, the face score, whatever, and you take that into your end result. And you can make a decision and say, if the score is based on some number, above some number, change my color line, okay? So this is exactly what you do in terms of using your own machine learning model with the Vision Kit. All right, so with that, let's talk about extend your project, right? We talk about software, but how about hardware? On the AIY board, there's the red circle area I pointed out. It has additional GPI pins. With those pins, you can control output. Turn on the lights, turn on the fans, you know, sending out, making some noise, whatever you could do. So with these things, you could expand your project, and with that controller on board, you can do a lot more things, okay? So hardware-wise, as a maker, we could do more things. All right, so we've gone through all these. We talk about the assemble, how do you set up, and how do you do your own things. And most importantly, I want to say, to use AIY, the power of AIY really it is connected to many of the services Google provide, right? Like Google Assistant, like TensorFlow. You want to leverage all these power of service behind you. And AIY, we are part of a global open source community, right? We publish this on GitHub. We work with Raspberry Pi Foundation. We work with Hackster. So immerse yourself with the online maker communities around the world, okay? And this is the part of the fun of building makers, AIY. I want to take this opportunity to tell everybody, for the audience here, those of you from the US, okay, you could join a contest going on right now, organized by Techster with the Ministry of Education in China. It's so-called Young US-China Makers Contest. The winners will get an all-expense-paid trip to China. So those of you in the room, you are American makers. Please join this contest. And more details on Techster website. All right, the key takeaway from our talk today, what Sebastian and Dushan mentioned in their part of the talk and mine, the key takeaway is resource-wise, the global AIY website is this address, AIYprojects.withgoogle.com. The kits can be purchased right now at the Target store in the US. And also, next weekend in the Bay Area, there's a Makers Fair. Those of you who are in the area joining the Makers Fair, you can get the kits from the Makers Fair. Learning using Raspberry Pi, using Python programming, this is a part of the thing that you need to get yourself involved to expand your applications. And using TensorFlow machine learning model to really build the power of AI into applications. And that's the power of AIY. And finally, to summary, and I would say call to action, the things you guys could do, right? Everyone could do. Get AIY kits and start building and have a lot of fun, of course. And learning many Google services. At Google I/O, we have sessions on Google Cloud, on Google Assistant, on TensorFlow. Please join and learning a lot of those knowledge and skills. And get a lot of different sensors, controls. Hook up to the GPIO ports on those devices. Okay, you can build a lot of fun applications and leverage your AI capability. And then lastly, joining online communities. We will very soon publish a global AIY model exchange and put your application on that, share your knowledge with the global developer communities. So with that, along with Sebastian and Dushan, we want to thank you for coming, join our session today, start your AIY journey today. Thank you very much.
Todd Kerpelman here, and I am joined with Abe Haskins, who is a developer programs engineer on the Firebase team. Hi, Abe.
Hi, Todd.
So what is this exciting game that we see going on behind us right here?
This is AppShip 2018. This is a Firebase-powered multiplayer arcade spaceship thrilling game.
Extravaganza.
Extravaganza, yeah. It's a phenomenon.
That's what I was thinking. And so how is this game making use of Firebase?
So we started weeks ago when we generated thousands of custom rocket ships that we turned into sprites, which we turned into cards, which we got printed. And we did that all with Cloud Functions and other Google technologies. And then once we had those printed, we built scanners that can scan the cards using the new ML kit from Firebase. Then we made a game which received updates from the scanner using real-time database. Once you're in the game, it loaded your actual sprites from cloud storage for Firebase. And once you're in the game doing stuff, it shoots out analytics to Google Analytics for Firebase. So it's all Firebase through and through.
Yeah, I noticed every attendee here is getting a appship.io card, each one with a unique rocket on it. Did you design all these rockets by hand?
I basically did, yeah. Whew. We made a tool that allowed you to go and mass produce rockets by picking and choosing parts that went together.
This is mine with my custom spaceship. And basically, when you scan it in at these scanners over there, everybody just sort of has their own spaceship magically appear in the game. Yep. And so that's all being powered through Firebase.
Yeah, it's all being powered through Firebase. Like I said, we use Cloud Functions to actually generate the sprites, generate the cards, and we had the cards printed, and we connected all the cloud storage real-time database, so we're writing back when you scan it in. We have history on all the cards.
So there's a lot that's been going on with Firebase. What are your highlights of the things that have been happening with Firebase over like the last year?
Well, I personally normally work on Cloud Firestore, so I was super excited that we got to launch that. But we also have performance monitoring for keeping an eye on your app. We have A/B testing for trying out new things. We have ML-Kit, which is obviously a huge, everything about ML is exciting and awesome, and I'm glad I got to use it a little bit here. Basically all that, we have so much cool stuff coming out.
Excellent, well, I'll have to check out more of it after I play a little appship.io and I don't know, kick your butt in it. All right, let's give it a try. So every attendee at I/O this year has a unique appship.io card that they can get here at the Firebase booth, Dome, and every card has a unique rocket design on it. So when you scan this QR code at one of these scanners, my special rocket will appear on screen there. That's me. No matter what kind of app you're developing these days, there's a good chance you'll want to store your data in the cloud. Maybe that's because your users want to share their data with their friends for some exciting in-app collaboration. Or maybe it's just because they'll want to access their data from more than one device. But storing data in the cloud isn't quite as easy as it first looks. You have to set up your own servers to host the data and keep them up and running day and night. You got to spend a lot of time on the client dealing with networking issues, including making sure everything still works when your user goes offline. You need to stay up all night wondering if you've gotten your security exactly right. And spoiler alert, you probably haven't. And then you need to make sure your service can scale no matter how many millions of users you might have. All of which is time you don't get to spend on building your app. This is where Cloud Firestore comes in. Cloud Firestore lets you store your data in the cloud so you can sync it across all your devices or share them among multiple users. And it comes with all the conveniences you'd expect from a Firebase product, like robust client libraries, full support for offline mode so your app will continue to work just fine whether you're connected or not, even on the web, a comprehensive set of security rules to help you manage access and sleep at night, and an easy-to-use data browsing tool. It also lets you structure your data in ways that make sense to you thanks to its powerful querying and fetching capabilities. Cloud Firestore works in near real time, automatically fetching changes from your database as they happen. Or you can request and fetch data manually. It's completely up to you. Cloud Firestore brings you the best of Google Cloud Platform's powerful database infrastructure with features like multi-regional data replication for extra reliability, strong consistency to make sure everybody's on the same page, and multi-document transactions so you can perform complex operations on your data. And we've designed it to handle the toughest workloads from the world's most popular apps so it can scale automatically to support yours. But it still integrates with other Firebase products, including Firebase Authentication for easy sign-in, and Cloud Functions, which lets you run all sorts of server-side logic in response to changes in your database. All of which means you get a truly serverless development experience. And that means you can spend less time on infrastructure issues and more time building your app. So give Cloud Firestore a try today. You can find all our documentation here, try a sample or two, and start building something great.
Stability issues can derail the success of even the best apps. Buggy apps make your users unhappy, and they might uninstall your app, leave a bad App Store review, or write negative social media. Apps can generate a lot of different crashes, and manually tracking them is time-consuming. Even if you're able to collect all of this data, it's difficult to figure out which crashes to troubleshoot and fix first. Firebase Crashlytics helps by automatically collecting, analyzing, and organizing your crash reports. It also helps you understand which issues are most important so you can prioritize those first and keep your users happy. It combines a real-time dashboard and alerts to keep you aware of your newest issues and any sudden changes in stability. The dashboard shows crashes ranked by overall impact on your users, giving you the information you need at a glance. Crashes are intelligently grouped across versions of your app, with individual stack traces easily explored in the dashboard. Sometimes you might hear about crashes from users that you can't reproduce. With the help of logs and key value pairs in Crashlytics, you can add some context to each stack trace and see what your app was doing before the crash. When the crash is reported, this extra information is sent to Crashlytics, becomes visible in the dashboard, and gives you the context you need to help pinpoint the exact cause of the crash. Non-fatal errors can be reported in the dashboard too, so when your code fails but doesn't crash your app, you can still get full reports in the dashboard. If your app is built with the NDK on Android, Crashlytics will capture native stack traces as well. Crashlytics is easy to integrate with 0 lines of code required on Android. With iOS, just use CocoaPods for simple integration. You can count on Crashlytics to help stay on top of the stability of your app, spend less time troubleshooting issues, and more time doing what you love with Crashlytics. And to learn more and get started with Firebase Crashlytics, check out the documentation right here.
the line. Think of all that we can do with just one of me and one of you. Doing what we want now. No one's ever gonna take us down. Feeling like we're supposed to. Now the sun's out, sun's out. And 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 now the sun's out, sun's out.
Good afternoon, everyone. Thank you for joining us at Google I/O. You are at What's New in Android Support Library. If you were looking for sandwiches, you did not go far enough. And everyone's still here. Wonderful. So I'm Alan Viverette. I'm the tech lead for the Android Support Library.
Hi, I'm Armas, and I'm a software engineer on Android Support Library.
Hi, and I'm Kathy Kam, the technical program manager for the Support Library.
And today we're going to be talking about what is new in the latest version of the Android Support Library, as well as some new things that you can look forward to in the future. And on this beautiful spring day in Mountain View, California, we're going to start with a little bit of spring cleaning. We're going to talk about some technical debt that has been building up in the Support Library. So we're on Twitter, we're on Stack Overflow, we're on Reddit. Maybe we're on Reddit a little bit too much. But we noticed some basic aspects of the support library that were a little bit, let's say, messy. So we've reached out and spoken with developers and tried to find out some ways that we can improve the basics of support library and lay a strong foundation for future work. And we got a lot of good feedback, some very high level, some very specific. We know about the issues with showing and hiding the IME, but we drilled down to the basics. We got feedback on our Maven packaging, so our artifact and package names. Our Java packages have become a little bit confusing as support library has aged. And in general, we've built up a lot of technical debt. So like last year, we're going to talk about what's old in the Android support library first. So we started in 2011 with Support v4. And as I'm sure everyone here knows, that provided backward compatibility for devices running SDK4, the first public release of Android. And we grew. We gained libraries for watch components, car components, testing, support for SDK 13, 4, 11. So we have a lot more than just backwards compatibility now. But we still got these artifact names. So we've got Support v4. Everyone's familiar with that. Support v13. Who knows what's in Support v13? Literally less than 10 people. Aramis knows. So, Support v13 at this moment contains nothing because our minimum SDK for everything is 14. v13 just redirects to v4. v4 actually redirects to a bunch of other components. These are both just umbrella artifacts on Maven. So, why do we have all of these weird versioning names in our Maven artifacts and in our package names? Well, they're kind of hard to change, but these are confusing. It's not a great place to start if you're new to Android development. We also have a lot of versions of all of these libraries. So recommendation is something that was added back in 23 and hasn't changed a lot since then. So we have 30 versions of basically the exact same library. And what does the versioning scheme mean here? Well, 24 means it was released at Google I/O when SDK 24 came out. We had an Alpha 1 corresponding with the first public release, DP1, Alpha 2 for DP2, Beta 1 for DP3. But it doesn't make a lot of sense for us to be corresponding to just the I/O releases. Wouldn't it be great if we had alpha and beta releases for every version of the support library? And wouldn't it be great if we didn't have to do that for every single library, even if it hadn't changed? So you may have seen like a 24.0 that should have had a little bit more testing. Maybe there should have been a beta 2 there. Or maybe you pulled in 25.4 and found some bugs that really should have been in alpha. So we've been doing a lot better about testing, but wouldn't it be great if our .0 releases weren't still alpha quality? So today we're going to focus on fixing how we structure our libraries, how we handle changes to them, and how we ship them to developers. And we're using this to form the foundation for Jetpack. And we're calling it Android Extension Libraries, or Android X for short. So welcome to What's New in Android X. We'll be talking about foundational features, foundational changes, new features, and what you can expect from us in the future. First, though, I'd like to talk about the relationship between Jetpack, which everyone may remember from the keynote, and Android X. So Jetpack is a set of guidance, recommended libraries, and tools. And this is going to teach you how to create good apps. This may include libraries that are in Android X. This may eventually include libraries that aren't in Android X. And as guidance changes and evolves, you may see that some things in Android X become deprecated and are no longer part of the Jetpack recommendations. Also, it's got this cute logo. Android X, on the other hand, is the libraries themselves. These are guarantees about versioning, API surface, dependency structure, and we do not have a cute logo. So let's dive into details. What exactly is going to be changing? We're going to have logical, smaller, more scoped artifacts. So for example, if you're looking for View Pager, it's going to be in the View Pager artifact rather than Support v4. You may remember the Support v4 split that we did last year, where we split out to Core UI and a number of other artifacts. We've done that again this year, so we have smaller artifacts. If you need View Pager, you just pull in View Pager. You don't pull in a bunch of other widgets that you may not need. This is, of course, non-breaking, like the split that we did last year. So if you pull in Support v4, you still get all of that umbrella of libraries. If you pull in Core UI, you still get View Pager and everything else. But you also have the option of just pulling in exactly what you need. So here's the split of the libraries. This is just a sample. So you'll see that Support Compat has been broken down into collections. This is a pure Java library. It's a jar instead of an AAR. It has no resources. You can use it with host tests because it doesn't have any dependencies on the Android package. Core is the backwards compatibility that you're used to from Support v4. You're going to see less of the Compat moniker in the future as Android X is becoming the primary development surface for a lot of framework APIs. So here you can see if you need swipe refresh layout, you pull in exactly that. You don't get anything that you didn't need. We're also moving to versioning that makes more sense. So instead of monolithic releases that are tied to Google I/O, we're going to reset from 28 to 1.0. And the major version number now actually means something. So previously, we would break binary compatibility on any minor version bump. And if you're using a library that depends on a specific version of support library, this can be really problematic. You may not even find out until runtime that some method signature that a library depends on has changed. Our move to strict semantic versioning with Android X means that you can always expect the major version number to indicate binary compatibility. Anything in a 1.4 version of the library, anything with a 1.4 dependency on a library, for example, would be compatible with 1.5, 1.6, all the way up until 2.0. We're also going to be doing per artifact versioning and release. So instead of a monolithic release, if we have a bug fix for recycler view, we release a .1 of just the recycler view library. You only have to pull in one new artifact, and if you don't need it, you don't have to pull it in. So it's going to be very low effort on the part of the developer. Right, and we want to make it easy to know what's inside each artifact. So as I mentioned, our Maven artifacts are now finer scoped. They correspond to features instead of very broad swaths of, for example, all of support v4. We have a consistent scheme of AndroidX.feature.package and class according to layer and functionality. And our Maven naming scheme reflects this. So our group IDs are going to be AndroidX.feature. This will correspond directly to the Java package. The artifact ID will be the feature. And if there's a subfeature, for example, recycler-view selection, you will see AndroidX.recycler-view, recycler-view-selection. You also notice that we've moved all of the v7, v4 explicit SDK explicit backwards compatibility or explicit compile SDK requirements. So our min SDK requirement is built into the Android manifests for these libraries, and we also make heavy use of the requires API annotation. So you may run into methods that may return a new object. So you may see something that returns compat, something that returns the actual object, and you can call that if you're on a newer platform. All right, so let's dive into an example of that. Here's an example of some libraries that you may already be using. We're unifying everything under the AndroidX top-level package. So everything that was in com.android support is now an Android extension library. Everything from android.arch is now an Android extension library. For the most part, we're preserving the names, but you'll see some simplifications. So Android Arch persistence room, for example, is now just room. When you're looking for room, you can find it very quickly. Let's dig down on support compat and CardView v7 specifically and take a look at some of the classes. So build compat has moved from an explicit v4 support to Android Core OS build compat. And in the future, you'll actually see a lot less of the compat suffix on classes. CardView v7 is now just cardview.widget, and the class is CardView. You'll find other supporting classes in cardview.util, etc. So hopefully this isn't too shocking. I think this is a very long-awaited refactoring that we've really been wanting to do for a long time. And you might be wondering, how do I get that? So we'll hand over to Armas. He's going to walk you through what it looks like to migrate your application.
Hello there. All right, thanks, Alan. So I will walk you guys through our migration story and how you want to get to the AndroidX library usage. So first things first, if you're using Android Studio, we will be providing an automated tool for migrating over. This tool is available starting with Android Studio 3.2 Canary 14 that shipped yesterday. This automated tool will be in the existing refactor menu that you probably, hopefully, love. And what we added is we added a new option that's called Refactor to AndroidX. And the single click will go and identify all the usages of Android support library old classes, and it will pull them up in the review pane where you're going to be able to see what has changed and what we're about to migrate for you. And after review, you click Do Refactor, and we'll go ahead and refactor. And what this will handle, it will go handle your source code, including your Kotlin classes. It will handle simple build scripts, unless you have something more complex, in which case we're going to publish maps of old artifact to the new artifact, so you can do the migration in a slightly more manual way. The migration will also handle resources, such as your layout files. And then finally, but not least, what you're going to have is we're going to handle migration of binary dependencies for ARs and jars. We know that many of you use third-party libraries that depend on support library. And there could be Glide or many other libraries. So to help you with that, we wrote a tool called Jetifier. And this tool performs binary translation using ASM, which jumps into the jar and goes and rewrites all the uses of the old support library to become the new support library. This handles code inside of the jar. It handles XML resources. It even handles ProGuard files. We will also publish a standalone jar that you can run manually if you'd like to have checked-in versions of these pre-builds that you depend on. And now let's jump to the laptop, where I'm going to give you a demo of how this tool works. And hopefully the demo works beautifully. And of course, here we go. All right, let's jump to the laptop. Right. So here you're looking at a Topeka Android app. It's available on Google Samples GitHub page. It's nothing super amazing. This is just using standard components and showing examples of how it works. As you see in the Android emulator, I'm running this app. It works. You can click on things. But now what we're going to do, we're going to jump into the refactor menu, hit the refactor to Android X. What this is going to do is going to go jump in and search through all the uses of all the old support library classes in both XML, Java, and all the other places that we migrate for you. And after it's done searching for, it's going to present all the things that it will suggest for you to migrate. And in this case, I'm looking at the specific sign-in fragment class, and you can see there's a bunch of uses of support library. And what is going to happen when I hit do refactor, it will go and rewrite all of these, and including build script files and everything. And of course, Gradle needs to go and sync again now because we just changed all of the dependencies and the class paths need to be reloaded. So now that's where you twiddle your thumbs a little bit and wait for Studio to do its thing. And now we are using new stuff. And now when I hit build and install, hopefully in a few seconds, at home you probably would go grab a coffee, but here we can't do that on the stage. But it will go and install it on the emulator any moment now. I will stall a little bit longer by saying other words. Ta-da! And now you see this is a new app. This is the same app using a brand new Android X library, and migration was fairly painless. So let's get back to the slides. All right. Of course, some of you are not using Android Studio. And for those people, we will be providing a giant CSV file that has a mapping of old class to the new class. And that, in addition to the standalone Jetifier tool, you should be able to hook up together in your build system and your IDE to do the migration manually if you're not using Studio. So in summary, we are providing these tools in Android Studio 3.2, Canary 14, and Jetifier is already in Google Maven. However, this is coming in really hot. Even the demo that I was using is actually not using Canary 14. It's using Canary 15 that's shipping next week because we found bugs when we were trying to do the demo. So please wait until Canary 15 to start using this. But when you do in Canary 15, please take a look at it, try to migrate your projects, and if you find any issues with it, please file bugs. We're very, we want this to make it as easy as possible, and we want you to migrate and start using all the new stuff. However, we know migration takes time, so we will still ship Android Support Library 28.0 alongside of Android X. However, note that this is the last feature release, so this is kind of like a little bit of a timeline for you to kind of move forward. And if you want to know a little bit more of how this works behind the scenes inside of Android Studio, there will be a talk about Android build system at 6:30 in this room. So hopefully you can go and take a look at that. So it's not all about refactoring. We also added new features. And I'm going to walk you through some of these. So the first feature I want to talk about is the recycler view selection. And this is a library that will allow you to handle item selection a lot easier. It will help you handle motion events and touch events and convert them into selection in the recycler view. This is a fairly flexible library where it allows for custom layout managers and a lot of custom actions that you can do with. So let's jump through and see how you use it. As you can imagine, you add a new dependency to your build.gradle file. And the important thing to note here is that we are using the new Android X artifact. This is the same stuff that Alan was talking about. So for the setup, what you need to do is you want to create a new layout, new adapter. And the adapter, the important thing is that it uses stable IDs. We're using a stock grid layout manager, and we set both of these on the recycler view. There's no selection code just yet. We're just doing the basic recycler view setup. The adapter, as I said, again, nothing super exciting. The only important thing here is that we're doing stable IDs. And this allows for consistent mapping from ID to the item. And then next, when we jump back to the activity, we set up selections libraries as key provider. And this, in conjunction with stable IDs, will allow for quick mapping between the IDs and the items that will handle the selection by the selection library. And now what we need to set up is the selection tracker, which actually is the actual machinery behind the scenes. And we pass in recycler view, the key provider, both of these that we just created, and then my details lookup. And my details lookup is actually a fairly simple class you need to override only one method, and then inside of that one, you return item details, and that returns the position and the selection key for the item that is for the given motion event. And finally, RecyclerView has no default selection mechanism. So what you have to do is you have to handle it on onBind. So there, you might want to change the background of the view, or you can use it by setting activated state. And to get activated state working, you use background for the view, and that background is a selectable drawable that has an activated state, which will allow to indicate to a user that the item has been selected. So this is the basics. This library has a lot more. You can set up band selection. You can add custom selection areas. You can have items that are not square. You can have circular handling and stuff like that. There's a lot of stuff you can do with this library. And an important part on this slide, that's my dog, Jack. All right, another thing that we added to RecyclerView is a list adapter. And what this does for you is it helps you to work with RecyclerViews that change the content over time. So all you need to do is submit a new list. We run a diffutils tool behind the scenes for you on a background thread, and then we run the animations based on how the list is changed. And this is all handled via a very simple API. And I'm going to walk you through it. So what you need to do is you create a diff callback. And diff callback has to implement two methods. First one, make sure that the items are the same, where you compare the item IDs. And the second one, you want to check that the content is the same, where you do a deeper comparison, essentially equals in Java. And in there, if there is a change, we'll know how to crossfade your item from one to the next. And then the adapter, what you need to do in onBind, you just call getItem, and you do your regular binding. And then that's all you need to do to get the animation working. And then a highly complex code in the activity, you call submitList with your list, and that's it, you're done. Note, this works really well with live data and RX Java observables. So if you need to do a slightly more advanced adapter, we also have a base adapter called async list differ. So if you need to do that, just go and look into that. If you would like to know more about list adapter and similar utilities, see Managing Infinite Lists with RecyclerView and Paging Talk on Thursday at 2:30. All right. So another thing that we added is AndroidX.WebKit library. And what it allows you to do is to get the APIs that we've added in WebView on the older versions in a backwards compatible way. This library works on API 21 and newer, where we introduced the updatable WebView through Play Store. So take an example of Safe Browsing API that we added in API 27. This prevents loading of malicious URLs in the WebView inside of your application. And previously, you could only use it on API 27 and newer, but now you are going to be able to use it on older devices. So similarly, we're going to add a Gradle dependency to get this working. Again, we're looking at AndroidX artifacts. Hopefully, you got this by now. And then we check if the feature is available. And if it is, we start safe browsing. It's as simple as that. And you get the safer experience with safe browsing, starting with API 21 and newer. And similarly, many other APIs that we added since API 21 now will become backwards compatibly available to your application. So hopefully, you'll check this out. So another library that we've renamed is Custom Tabs. This library became Android Browser. This doesn't actually change the functionality. It will continue to work with all the browsers that already implement this. So Chrome, Firefox, and Samsung Internet, all of them implement this. And if you're using it, it will continue to work. The cool thing about this, we added a new feature inside of the library, which is called Browser Actions. And what it allows you to do is allows you to hook into the context menu of the browser. So for example, now your Reddit app can finally open links in Incognito tab, which can be very handy. It works in Chrome, starting Chrome 66, and it will start working on other browsers when they adopt it. So again, to use this, it's fairly simple. You set up intents, pending intents for your browser action items, and this is optional. If you don't need any extra ones in your dialog, you can skip this part. Another optional part you set up is browser action tracking. So what this allows you to do is you can see what user ended up selecting inside of the dialog. And then finally, you just fire up the browser action dialog. And then you end up with something like this. And you can do additional actions yourself, or you can hook into the browser. Whereas previously, you weren't able to do this via simple intents because browsers weren't interested in exposing a lot of this functionality directly. Another library that I'm going to talk about is HEIF-Writer. HEIF stands for High Efficiency Image Format. And we introduced this support to the platform for HEIF in Android P. And alongside, we're launching this library that allows you to take byte buffers, surfaces, and bitmaps and write them to the file. Currently, it is only API 28 and newer, so not super useful. But we are working on a backport that will allow you to use it on older versions. Again, usage is very simple. You fire up the builder to create a new HEIF-Writer object. In there, you can set up a bunch of objects like image size or quality. You hit build, and once you have it, you start writing to it. You put in bitmaps, and once you're ready and you're done with, and you want to write it out to disk, you call stop with a timeout. And the timeout can be 0 if you want to have an indefinite wait. An important part here is you want to do this work off of UiFred because you're going to be doing disk. And to tell you a little bit more about other features in Android X, I invite Kathy. Thanks.
Thanks. Thanks, Aramis. So the next feature I want to talk about that we added in Android X is a feature called Slices. Slices is a feature that allows you to display content outside of your app. So the goal here is to have one reusable API that both the system and other apps can request content from your app. Today, we have already integrated with search. Our goal is to look into integration with notification, long press, or even home screen in the future. So what is this content that you get to present? This content is both templated and interactive. It's templated so that when you have kind of live content, you can display it in a rich and flexible layout. And the content is interactive because we allow you to add existing controls like widgets, existing widgets like sliders, toggles, or scroll viewer, so that together you can have live data with inline actions or even deep links into your app. You can also choose to integrate your slices with search. So a user can display app content by searching your app name or even general terms that you register. This is a win-win for both users and the apps because users can get rich live data immediately and for your app to reach millions of users. Because this is implemented in Android X, it is usable immediately up to API 19. So let's take a look at how you can use it. So as you would expect, we have to first import the libraries. There's 3 libraries you need to import, and here we're importing from Android X. The first is the slice builders that includes methods to build content in a templated format. The next library is the slice view. This contains method so that you can present the content. And the last library to import is slices core that contains methods for permissions. So to build a slice, you have to define a slice, implement the slice, and handle the slice action. Let's take a look at how we can do it. So the first thing we need to do is to let the system or other apps know that you have slices to provide. So you do that by implementing your slice provider. So you register your slice provider in your Android.manifest file. Next, you have to extend from the slice provider and implement your slice provider. You can have multiple slices for your app. So this is where the business logic happens. When a platform or another app wants to get your slices, you get a call on bind slice. There, you get a call with the URI of the slice being requested, and you have to return your slice immediately. So any content that needs to be loaded should be kicked off, and you would return it in build slice. So let's take a deeper look, and we're going to construct the slice here. And we get able to construct it with several builder classes, including row builder, grid row builder, and list builder. So let's take a look. So here, we can use the list builder to add a very simple header. The header contains a title and a subtitle, and you see the method add header that adds the header. Then to build on top of it, we can use the grid row builder. First, we get the latest weather information, and then we can loop through it, adding a cell to the grid row builder. And by just calling add grid row at the bottom, we append the rest of the slice to the header. So what you get here is that based on screen real estate, if it is small, we'll show a shortcut slice. The shortcut slice pick up an image from your slice. So because we have the weather image, it will pick that up. But if you didn't have an image, we'll show your app icon. And then if the screen real estate only allow for a small slice, it will be the header that's shown. And finally, if it has enough space, we will show the full slice. So to learn more about slices, there was a talk this morning that you can review. But I only just covered very basic of it. You can learn more about templates, permission, and integrating search in the other talk. And you can also meet the team at the office hour 10 tomorrow morning at 10:30. So the next topic I want to talk about is material component. We launched material components for Android back in Support Library 28.0.0 Alpha 1 in March. And we have also launched it for Android X yesterday. So as you know, material theming is designed to support great user experience. And we've made a lot of improvements since O. So one of the first things we've done as part of the Android X refactoring is that instead of being an android.support.design, we've moved it to com.google.android.material. We've done a lot of extensive usability study on how to make these widgets work well for you. So we have made them more usable and accessible. And we've updated styling so that you can better express your brand and included new UI components. So let's take a look. So here's an overview of the theming capability. On your right, there's a very brand agnostic baseline. And on your left, there is the Google branded. All of the components can pull from the theme so that it makes it super easy for you to have app-wide theming. Let's walk through some of this in code. As you would expect, we'll have to import the library. Here, note that it is coming from com.google.android.material. And to use our baseline theme, you define, kind of set the theme to be material components.light. This is the kind of very brand agnostic theme for you to start with. And then we provide a whole bunch of attributes that you can override so that all the widgets within the app can pick up. So here we have defined primary color and text as in theme.xml. And then on top of that, you can also define attributes for different text styles. We have some that comes out of the box, but you can also define your own. And all the custom widgets, if you have custom widget that uses these attributes, it can also pick up the theme. So let's take a look at some of the components that we've updated. First off is text field. We've done a lot of research, and we have improved the touch target, making it more easier for input and making it more usable and accessible. We've also added new states to it, which includes focus state, arrow state, disable, and text counter. So we've kind of think through all of it from the start to make your life easier. Next up is button. As you can tell, you can just use button the way you use today. By setting the material component light theme, we'll automatically inflate this to the material button that understand our themes and pick up all the attributes that you have set previously in your theme file. You can also use custom attributes with these. And then we're also providing two updated bars for you. The first is the bottom app bar. The bottom app bar allows you to add app actions into your app. What we have done here is that we have allowed you to, we've done research and saw that the phones are bigger. So we want to allow you to position your actions anywhere you want along the bottom app bar. So here we have a fab that is centered and then can be animated to be right aligned. The other bottom bar that we have updated is the bottom navigation bar. So just to clarify that, bottom app bar is for actions, and the bottom navigation bar is for different sections within your app. We do not recommend mixing these metaphors, but we provide both for you to choose from so you can build your app. So pulling all of this together is the material card view. That is a wrapper on the existing card view in the support library or Android X. We've simplified how this was built so that it has less elevation and shadow, and it also pulls from the theme and color. So here you can see all the elements coming together with the text, button, and all of that in the material card view. With this component, you will have to define using material card view explicitly. We're looking to see whether we can integrate it as well. So with that, you can learn more about this in stage 8 at 4:30 on how to incorporate what's new with material design in your code base. And Android X is only one part of Jetpack. So Jetpack is a set of components, tools, and guidance to help you build great Android apps quickly and easily. So we're at this talk, but we have 4 more talks for you to learn more about Jetpack. So with that, thank you. Alan, Aramis, and I will be hanging out at the Android tent right over there. So we'll hope to see and talk to you, all of you. Thank you.
Hold the continent is. I was looking for the joy and the pride and the dignity of the people that lived there. And, you know, that's the choice we make for wherever we are, because I met people who lived in the rural parts of Africa just as much as people lived in the modern cities like Johannesburg and you know, we were in Durban, we were in Cape Town. So it's you know, you could see someone dressed in their traditional Zulu or traditional Xhosa and in the city, you know, just as much as you might see that in the rural areas. So I decided not only to find myself and realize that I think I've been African this entire time, but that I was determined to find all the beautiful things that I, you know, was told weren't there, you know, because that then really came back to who I am as a person. You know what I mean? It really related back to who I am and how I felt about myself and the confidences I had. So it all kind of like, our fictional world building bleeds back into our realities.
We have 2 minutes left. Could you share a nonfiction story you shared with me that moved me very much, which was about the director Ryan Coogler, who I'm a huge fan of. And I've always, when in Silicon Valley, we talk about leadership, you know, CEO, or the product manager is the CEO of the product, and all these CEO-ish things. I think of Ryan Coogler as one of the great CEOs of our time and creatives.
Yep.
And you shared a story about him. Could you talk about
when
that?
I was talking to myself?
Yes.
So you obviously know I'm kind of weird. So I'm going to tell this story. Don't hold it against me. But so we're working on Creed, and we're tech scouting, which is kind of we go to look at all these locations, and you can spend all day. And we had stopped at this coffee shop, and I got my coffee, and everybody was getting their coffee, but I was kind of working out a problem. And when I'm trying to work out a problem or solve a problem, I talk out loud to myself, because that's the best way to do it, for me, apparently. And, you know, my friends and stuff were like poke fun at me, like, oh, you're crazy, you're talking to yourself. And so, you know, sometimes I do and I don't even know I'm doing it. So Ryan comes walking over to me and he was like, are you talking to yourself? And I was like, you know, a little like, oh, you know what I mean? I know you and love you, but yeah. And the first thing he said, he looked at me and he said, that's a sign of a really healthy mind and a really intelligent person. And he kind of turned around and walked away. And I was kind of like ready to get the hit of like, oh, you're crazy, you know, kind of funny joke, but a little bit like of a slate. And that's not at all where his mind came from. It looked for the immediate positive thing about the thing that I was doing that sometimes people think is weird or could make you feel a certain way about yourself that eventually starts beating you down and making, you know, defining who you are because you're hearing negative things about it. That is who Ryan is. He's the person that will constantly lift people up, you know, will constantly, and he's not perfect, I promise. There's days when I'm like, please make a decision. You have like 2 hours. But, you know, and he does all the things that directors do that can, you know, completely bother you or things that are like amazing. But he's the type of person, like we would be on set for Warrior Falls, which was the big waterfall where they had the big fight. And he gathered us all around in a big circle. You know, some people were in the water, and he really told us why that scene was important. This is before we even started shooting. He really started to say why that scene was important to him, and really talked about having all the fictional tribes of Wakanda in one place and represented by all the references that we use of the tribes, the different tribes in sub-Saharan Africa, and how that was a big a part of him really feeling complete. And you know, you were holding hands and he's telling us all this and we're standing in this circle and you just feel like you can take on the entire world, you know, at that point. So that's who he is as a director and my friend. And he's a really important voice because his perspective on anything and everything is the most unique perspective you will, I promise you, ever hear from anybody. If you ever get a chance to talk to him because he will turn a situation and make you see it from a side you were never maybe even meant to see it from, and all of a sudden your world opens up. And so I can always, and he would be standing here going like, oh, please stop, but but he is really that great, so.
Well, thanks for sharing that story. What a leader and what a designer. Thank you, everyone. Thank you.
Hello and welcome to I/O Live. I'm Timothy Jordan, and I'm here with Ilian, who is a principal engineer on Android, and he leads Project Treble. Hi, Ilian.
Hello, Timothy. How are you?
I'm super. How are you?
Excellent. Thank you.
So that keynote was amazing, and there was a lot of your work up there. In fact, Project Treble. I want to talk about that, but before, could you describe the problem? What are you solving with Project Treble?
What we're solving is what we call Android's version fragmentation problem, which is best explained. If you're an app developer, you have to deal with all of these Android versions that you have to implement against, and this is a massive pain to deal with. So this is the problem that we started addressing out with Project Treble.
And how you solve that with Project Treble is you make it easier for manufacturers to upgrade to the latest version, right?
Correct, yeah. I mean, for developers to have the latest, device manufacturers have to launch their devices on the latest or upgrade existing ones to the latest. But historically, it's been very difficult, which means expensive, to do that, which is why device manufacturers simply didn't do it. This is why we have Android version fragmentation today. The way that we solved it is effectively by lowering their costs. That's what Project Treble is.
All right, so Project Treble was introduced last year. What's new this year?
What's new this year is that we effectively completed the engineering portion of our work, and we embarked on an operational side of it, which the goal of it is to accelerate the deliverables, the intermediate deliverables of Android to the OEMs, to the device manufacturers, so that they can do their work to launch these devices and upgrade these devices much, much earlier than previously. So the end result is that we expect companies like Samsung, for example, to do their work this same year, in the same year when we launch Android.
That's awesome. Now, what OEMs are launching?
We have 7 companies in addition to Google's very own Pixel, of course, who are launching previews, betas this year. And these are Oppo, Vivo, Nokia, Sony, Essential, OnePlus, and Xiaomi.
Awesome.
That's a lot of companies. Yeah.
And you and I actually have our pockets full of some of these phones.
Yes, we do. We do.
I think it would be neat to show there's the same version of Android running on each of these different phones.
Yeah, that's what's beautiful about this, is that these are devices by completely different companies, which all run the same version of Android. That was never happening until now.
That's totally awesome.
And, there's one more thing, of course. In addition to these previews, we have a total of 18 devices by 11 manufacturers who will either launch or upgrade their existing devices to the latest of Android this year.
That's really cool.
It is.
So for developers, this again really matters because it simplifies their overall developer experience, which they can get started on by downloading the preview.
That's exactly right.
Ilian, thank you so much for joining us to explain all of that.
Thank you for having me.
To learn more, head on over to android.com/beta. I'm Timothy Jordan, and this is I/O Live. Hello, and welcome to I/O Live. I'm Timothy Jordan, and I'm standing here with Tim Sneath, a product manager on Flutter. Hi, Tim.
Hi, Timothy. How are you doing?
I'm doing very well, thank you. Let's talk about Flutter.
Yeah.
For those few developers out there that don't know what Flutter is yet, what is it?
Yeah, so Flutter is a toolkit for building native mobile apps for iOS or Android from the same code base. It's open, it's open source, and today at I/O we're announcing a new version of Flutter.
Oh, yeah, so that was my next question. What's new this week? There's a new version, what else?
Yeah, so this week we're announcing Beta 3. Obviously, it's the third beta of our product. We shipped the first beta at Mobile World Congress a couple of months ago, and now we're starting to get to the point where we really feel like it's ready for a lot of production use, and so we're encouraging people to start taking a look at Flutter.
Now, you've worked with developers using Flutter a lot. What would you say they're most excited about when they start using Flutter?
Yeah, so I think there are 3 things primarily that make Flutter a great platform for building apps. Number 1, we have native performance. We compile everything that you write to ARM code. We're powered by the Dart programming language, and that enables this really fast performance. Second thing is we have this unrivaled productivity. With Flutter, you can use this thing called hot reload, so you can write your code, you can continue to work with it, and see exactly the changes that you're making in real time on the device. And then thirdly, Flutter has this high velocity graphics engine that lets your dreams come true, lets designers choose what they want to build and developers put them into production.
Awesome, and there's a lot of people using Flutter today. What are some of your highlights of the apps that are out and live?
Yeah, so again, we've only just got into beta over the last couple of months, both internally at Google and externally. Internally, we power some things like our ads. If you ever create an ad campaign, you're using a Google app built with Flutter. Externally, probably the most famous one that was shipped the back end of last year was Hamilton. You know, the Broadway musical. They shipped a companion app for using Flutter that has had millions of downloads, a really great application. And then this week we're talking about some other new apps. Alibaba, the big Chinese online retailer, they've just shipped an app in Flutter that they're now rolling out to millions of customers. Groupon have an app that they're working on. We have just different kinds of apps from different industries: wine, retail, finance. Loads of different people are coming out with apps. And in fact, we've just seen several hundred apps just since we shipped beta go live on the Play Store.
If you want to get started with Flutter, what's your first step?
Well, there's one simple place you can go, and that's flutter.io. And there you can find sessions, you can find code labs. We're obviously live streaming 6 different sessions here at Google this week. There's a whole bunch of documentation, and of course you can download the Flutter SDK.
And that's all at flutter.io.
Flutter.io.
Thank you, Tim.
Of course, it's a pleasure.
I'm Timothy Jordan, and this is I/O Live.
Hamilton is one of the most talked about and best loved musicals, with shows on Broadway, in London, and around the country. We wanted something to make the show more accessible for our fans, so we wanted to develop an app to meet the needs of fans as we started to expand the brand. We turned to Posse, a New York-based development firm, to help us develop the Hamilton app.
Hamilton's Flutter app launched in the App Store and the Play Store 3 months after we wrote our first line of code. And we accomplished a ton. Fans can enter a daily lottery for a shot at $10 tickets, buy merchandise through an e-commerce experience, take selfie photos with the HamCam, and get daily news and updates.
We knew that this app needed to be rock solid, both in terms of performance and visual fidelity, and really represent the amazing experience that the Hamilton show itself provides. And ultimately, that's why we decided to use Flutter.
Flutter is a mobile UI toolkit that allows developers and designers to craft beautiful native experiences on iOS and Android, and is entirely free and open source.
We have very high expectations of quality for the apps that we build. We expect pixel-perfect results, and we need them to be very high performance. Flutter gave us a lot of opportunities that previously weren't available to us. The fact that it's a single code base drastically improved our ability to deliver a consistent experience across platforms. Its hot reload gives us an ability to build more features in less time.
It allowed me to make changes really fast and iterate through the UI without having to stop and restart the app. Coming from an iOS and Android background, it's something that I've been waiting for a long time. The Flutter developer community is very active. Drop-in packages helped us maximize productivity. It helped us integrate elements like Firebase and Cloud.
At the end of the day, we're just really happy that we found Flutter so that we can build these beautiful native interfaces for both iOS and Android from a single code base.
We're given a really tight timeline, and we turned the app around faster than I ever could have imagined. We were able to make changes right up to the night before we went live, and really feel confident about them. In fact, we pushed an entirely new feature to the App Store the day before we launched.
And since launch, Flutter's efficiency and speed has helped us to build new features, such as the recent trivia game. We're really excited because as the show continues to grow, we're going to be able to keep pace with a ton of new features that's going to make the app even better.
We couldn't be more thrilled with Flutter. It has enabled us to use one code base to deliver a truly high-quality app that Hamilton fans have absolutely fallen in love with.
We're thrilled with what Posse was able to deliver. The entire brand of Hamilton is about delivering on an experience for fans. They're thrilled about the new features that we're rolling out, and we're really excited to see where the app goes next.
Good? Cool. Hello, everyone. My name is Brahim Bouchiri. I'm a product manager on MLKit. We, as a team, and many of us are actually right here, are very excited to tell you about MLKit. You've heard about it from Dave at the main keynote, and you probably even looked at our documentation. But in this session, we'll tell you a little bit more, some of the behind-the-scenes stuff that we've been working on. So let me get started. I think it's important to look back a couple of years and look at machine learning and what's been happening, the context. And I try to quantify this the best way I could, and one way is to look at Google Trends, the most reliable source of data. And in this case, you could see that over the past 8 years, we had a 50x increase in interest in deep learning, right? And deep learning is not a new technology. It's been around since the 70s. What's changed is that we can finally kind of deliver on the promise of deep learning. We have enough compute, memory, and power on some of these devices to actually run those models that have been developed for quite some time. And so I wanted to give you a very simplified, as a product manager, a very simplified view of machine learning, a 101. And in this case, you could see that essentially deep learning uses these layers and tries to mimic how the brain functions, right? And it tries to activate different neurons based on the specific kind of input it's getting so that it can ultimately arrive at that answer of whether this is a dog or a cat or a hot dog or not. And in this case, as you could see on that image, the output of that particular outcome is dog. And what we had before these sorts of algorithms was rule-based engines, where you'd have to actually configure the rules that will, if this and this and this and this and this, that's a dog, which does not scale. So because of that, deep learning has allowed us to get into so many more use cases and solve so many more problems that we had than we could before purely with rules engines. So that's cool. In particular, over the past 7 years or so, our ability and the machine's ability to perceive the world around it has gotten incredibly good. So in this case, in 2011, we had about a 26% error rate in identifying that animal as a cheetah. On the right, and as of now, essentially, and the error rate is less than 3%, which is better than what a human can do. And that's pretty awesome. The fact that an algorithm and a machine can now perceive the world in that way opens up lots of new use cases. But of course, as a team, our mission is about bringing machine learning to mobile devices and mobile apps. So when we started researching this product, we went out there and talked to many developers, both internally at Google as well as externally, to try to understand what are you doing with machine learning on devices, and how does it work today? So I'm going to tell you a bit about that. The first team, one of the first we've talked about, is Google Translate. And of course, you hear a lot about Google Translate because it's such a delightful experience and incredibly useful. But what I like the most about Google Translate is the fact that it strings together multiple types of deep learning and machine learning models and technologies to deliver this experience. So it does the on-screen character recognition to extract the text that it's looking at. It then does the actual translation itself, and then ultimately it could do text-to-speech so it can speak the results back to the user. And we think that when you can string these things together, when you can use machine learning in multiple ways within a single experience, where relevant, obviously, really cool stuff happens. So that's one example. The other one is this app called Musician. Musician is a music learning app. It essentially allows you to play an instrument in an analog, like an actual analog instrument, and then the device listens as you play and tries to interpret how well you're doing. So it's listening to the specific notes you're playing, it's listening to how well you're playing them, it's time-stamping them, it's doing echo cancellation, and it's also doing noise cancellation. And finally, personalizing the learning experience. All of this is done with an on-device machine learning model. And in fact, when we talked with this team, they had built their own C++ runtime to actually do the inference on device as efficiently as possible. This predated TensorFlow Lite and other things that we do have now that could have helped with that particular process. The other folks we've talked about, amongst a few others, are Evernote. So Evernote launched a feature called Evernote Collect. And the insight behind Evernote Collect is the fact that we collect so much of our information now in a visual manner. We're taking screenshots of things that we care about. We're taking pictures of receipts. We're taking pictures of whiteboards after a meeting and asking someone to transcribe them. Well, Evernote tries to avoid that. It tries to extract the text and tag the image with that relevant text so you can search for it and find it and make it more useful. So that's super cool. And so the overall theme from what we heard through many conversations was that it's doable. On-device machine learning is doable, but it's really hard. And it's hard for 3 specific reasons. The first is acquiring sufficient data in both the quantity and the quality that you need. Think about it. So let's say you're training an OCR model. You can label the data for your own language, right? You could get an actual training set and say, I'm going to label what this data says myself because I understand that language. But in a global audience, when you have users all over the world, how do you create an OCR model that actually works for all those languages? That's really hard. Or even harder, if you're a music learning app, you need to hire world-class musicians to record the perfect note so you can then actually train against it. That's expensive. The other aspect is developing models that are optimized for mobile inference. And this has many dimensions. This could be in terms of battery life, in terms of compute, and in terms of size of the model. And what I've learned in machine learning is that these are always constant trade-offs. You can improve on one, but then decrease on the other one. And so it's a really hard challenge to solve. And finally, deploying and ongoing experimentation is essential to machine learning. You can't do one without the other. And so, but however, there aren't very many tools today to help you do that. So we set out MLKit to try to address all of these issues. Of course, it's the beginning of a long road and journey, but we think that we have some exciting stuff for you today. I want to first talk about our machine learning SDK, a machine learning stack. And in this case, the very bottom of it is the Android Neural Networks API on the Android side, and then on iOS is Metal. On the neural network side, we launched it with OMR1, and it's essentially a hardware acceleration interface. Since launch, we've been working with every one of our top SoC vendors to build drivers for the Neural Networks API. And I'm excited to show you some results. With Huawei's P20 series device, we're seeing a 10x improvement in latency on inference with Inception v3. And what's cool, if you don't know Inception v3, it's a really large model. It wasn't built for mobile devices at all. It was built for server-side inference. And the fact that we can run that kind of model at 10x the performance and actually run it quite efficiently on a mobile device that's not connected to a power plant is actually super exciting. This means that we have a lot more headroom to do more with machine learning on a device. Of course, there's another dimension of this where we build models that are inherently built for mobile, that are from the ground up, built to be highly efficient and all of that. And that work continues. So when you pair these two things up together, we think there's going to be a lot of cool stuff happening here. So we're continuing to invest on Android Neural Networks API, and of course relying on Metal on the iOS side. The next aspect here is TensorFlow Lite. TensorFlow Lite, which was announced last year at I/O and then shipped around November, is a lightweight machine learning and set of tools and library. It works on both mobile devices and embedded devices, and it was built from the ground up, as it says, to be lightweight. Now, I'm not going to steal any of the team's thunder. They have a session fully dedicated to TensorFlow Lite tomorrow, and so I highly recommend going to see it if you're at all interested in on-device machine learning, which I assume you would be if you're here. OK, then we get at the application layer. And this is where we looked around and we said, there isn't really an easy way to access machine learning technologies at that layer. You had to either go and interface directly with the runtime and build your own models, or you really had to build your own stack. And so that's where MLKit comes into the picture. MLKit is in beta as of yesterday, so you obviously all can go use it today. And it's essentially Google's machine learning SDK. Our aim is to bring Google's 15+ years in machine learning, all of the technology we've developed, bring it to mobile developers through this SDK. So let me tell you more about it. Well, first, let me show you the stack again with MLKit at the top. And in fact, this is our on-device machine learning stack. OK, now I hope I get to tell you about it. OK, so the first thing that's really important is that MLKit is both on iOS and Android. And this was really important to us, because when we talk to developers, we don't think about Android machine learning and iOS machine learning. We think about machine learning. We want to deploy similar models to users on both platforms. There's not a fork there. So it was important that we have a consistent SDK for both. And in fact, every one of our features is available on both Android and iOS. We offer two types of rough buckets of features. One is what we call base APIs. These are APIs that are backed by Google models. And so as far as you're concerned as a developer, there is no machine learning involved. The other is a set of features that help you use your own custom-trained models. I'll tell you a lot more about that in a bit. MLKit also offers both on-device and cloud-based APIs. Again, this was important, because on-device APIs give you the real-time and offline abilities, but they have limited accuracy in comparison to cloud. However, on-device APIs are free of charge. But we also wanted to give you a consistent interface for the cloud APIs, because in many cases, you do need that level of precision and that level of scope. And we'll talk about the distinctions between the two in a little bit. And finally, MLKit is deeply integrated into Firebase. And this was really another important point for us. We aim to make machine learning kind of non-exceptional. We don't want it to be special. We want it to just be yet another tool, just like you use analytics or Crashlytics or performance monitoring or cloud storage. Just like you use any of those parts of Firebase, we wanted machine learning to be right there and right then. And what this also does is it works well with other features on Firebase. Again, we'll tell you a little bit more detail about that in a few minutes. So that's the high level about MLKit. So what base APIs do we support today? First, text recognition. This is available both on cloud and on device. The second is image labeling. Next is barcode scanning, face detection, and landmark recognition. The 4 APIs on the left are all available on device, meaning you can use them for free and in real time and offline. We also have 2 super cool features coming up soon. One is a high-density face contour feature. This is over 100 points in real time. And the other is a Smart Reply API. And this is what we like to talk about, how at Google we work together really well. So as part of Android P, there is a feature where you can now insert response suggestions within the notification shade directly. So MLKit's Smart Reply API could be something that would be useful in populating those chips. This is the same API used in Wear OS, the same technology, not the same API, the same technology used in Wear OS, Android messages, etc. So that's really cool. But of course, sometimes you simply need to build a custom model. If you're trying to detect that particular type of flower, it's hard to build a generic model, or at least you could build one, but it would be super large to actually detect every flower, every dog, every species of everything. So you have to use base custom models sometimes. And we wanted to help with that as well. The first feature we have here is dynamic model downloads. What this means is you can upload your model to the Firebase console and have it be served to your users dynamically. You don't have to bundle the model into your APK. This has a bunch of benefits. First, it reduces your APK size. Because now you don't have to put that 5 or 10 megabyte model into your APK, meaning that you have to take the hit in the app stores when you're trying to, the user's trying to install your app. But the other really important insight for us was that we decouple the process, the ML release process, from the software kind of traditional app release processes. We've learned that these teams are typically slightly different teams. Your machine learning team is probably a different set of people than the ones that build in your core software experience. So this gives you that flexibility to deploy each at different times. Now, a really cool benefit of this also is you can now do A/B testing on different models with literally a single line of code using Firebase's remote config. This is the coolest part for me. Literally, if you were to do this today, as in maybe 2 days ago before MLKit launched, you'd have to bundle 2 models into your app. You're stuck with those 2 same models for the duration of the app's lifecycle, and you have to then upload all the metrics back and do all of that work. This makes it trivial. And given how important it is to experiment as part of machine learning, this is, we think, a real game changer for our ability to use machine learning models. And finally, we talked about that optimization challenge of building models that are made for mobile. We're excited that we'll have a feature that's coming soon that will allow you to convert and compress full TensorFlow models into lightweight TensorFlow Lite model. And Wei is going to get in stage here in a bit and tell you all about the magic, we call it also technology, behind that compression flow. So that's MLKit, Google's machine learning SDK, available on Android and iOS. I want to take a moment, as always, to thank our partners. We've worked with every one of these partners and many more to launch MLKit. They worked through so many bugs, so many challenges. They've given us so much feedback, and the product wouldn't be where it is today without their help. So I want to thank them. And in particular, I want to highlight a couple of things. So we worked with PixArt, and PixArt uses MLKit to deploy a custom model to use their magic effects experience. And what's cool about PixArt is they're using MLKit both on Android and iOS. We also worked with Intuit. And if you know US tax dates, tax day is around April. And so they were really pressed for time to get the feature out. And so we worked with them to integrate MLKit in record time. So that was super awesome as well. All right. So before I hand it over to Sachin to tell you more about MLKit, I wanted to make kind of a commitment to you. We're going to go out there, and we're going to knock on Google's research team's doors, every single one of them. And we're going to go out there, we're going to ask them to bring their technologies to you to be part of MLKit. We're going to focus on vision, speech, and text models. And we'll also continue to make use of custom models as easy as possible. So that's it. I'm going to invite Sachin to come on up here and tell you more about how MLKit works.
Thanks, Brahim. Hi, everyone. My name is Sachin Kotwani. I'm a product manager on Firebase. I was practicing my presentation at home with my 3-year-old, and every time I finished, she would say, again, again, again. And I'm not sure if she was trying to tell me that I needed to practice more or if she really enjoyed the content. Again, we'll find out. Okay. When we set out to build MLKit, we had 2 main objectives. The first one was to build something that's powerful and useful, and Brahim talked about that. The second one was also to make it fun and easy to use, and I'm going to tell you a little bit more about that. So if you've used Firebase before, you're probably already familiar with products like storage, real-time database, Firestore, remote config, Crashlytics, analytics, A/B testing, and more. And now, there's a new addition to the family. Starting this week with our launch, if you head to the Firebase console, you'll see MLKit on the left nav. Clicking on that will take you to the main screen with our Firebase APIs that Brahim just introduced you to. As you can see, they are mostly vision-focused for now, but we intend to add to it in the future. Let's look at one specific use case. Let's say that I'm building an app and it needs to determine what's the content of an image, what the theme is, what things are in it. I would use the image labeling API. As you can see, there are two icons here. This indicates that this API is available to run both on device and in the cloud. On device is free. It's low latency, no network required because everything runs on the phone. It supports roughly 400 plus labels. Now, if you need something more powerful, something that's going to give you more high accuracy results, you would use the cloud-based API. That is free for the first 1,000 API calls per month and paid after that, but it supports over 10,000 labels. Let's look at an example. If you were to feed this image to the on-device API, you'll get labels like fun, infrastructure, neon, person, sky. If you feed it to the cloud one, you'd get Ferris wheel, amusement park, night. You can see that's more accurate, right? Okay. So remember I also told you that it wasn't just fun, it's also easy to use. So you have to hold me to it. Let's say that I want to implement this API on iOS. I would just include these three libraries in my pod file. Similarly, if I'm doing Android, I would put these three libraries in my build.gradle file. Next, if I'm doing iOS on-device image labeling, I would instantiate the label detector, say label detector.detect, and then I get the results back, and I iterate and handle the extracted entities. On Android, the pattern is very similar. You instantiate the detector, detector.detect an image, on success, handle the extracted entities. Now, pay attention to the highlighted boxes in gray over there. This is on device. Now, if I want to do the same thing but call the cloud API instead, not much changes. It's just a few class names. The pattern is very similar. The detector, detector.detect an image, on success, handle extracted entities. It's pretty cool. All right, demo time. I was warned not to do a demo, but my wife says that I don't listen, so here's me not listening. And let's see if this works. Okay, so I'm going to show you the image labeling API. This is typically used for things like tagging photos, if you want to know what's in the content of a picture, still picture usually. But I thought it'd be pretty cool to show a live demo with a live stream. So I'm going to take a picture of this toy. It says toy, car, vehicle, tire, bumper. Wow, it's actually picking out all the pieces there. Okay, let me, oh, it says crowd too, event. I didn't get to test this because when I was practicing, there was no crowd. It was just empty chairs. Okay, so face detection. Switch to this. Okay, so there's a box around my face, as you can see. There's a left eye, right eye. The numbers next to the left and the right eye are how open they are. So you can tell that I'm awake. Happiness is a detector for the smile. So look at how that changes. And this works with multiple people, actually. So just, again, you shouldn't trust me. You should ask me to prove it to you. So I need a few volunteers here. Okay, see, multiple faces detected. Eyes for everyone, smiles for everyone. Huh? Pretty cool? All right. Okay, I have a couple more things. Lose It, as Brahim mentioned, is one of our partners. And they worked on this really cool feature. So I'm going to enter here. Let's say I am logging what I had for breakfast. And normally you could select foods that are already in the application, or you could enter it manually. But let's say that you want to enter a new food. Apparently this is not considered food, so I don't think it's in the application. But I'm going to try it. Okay, so like I said, you could enter it manually, but let's try what happens. Oh, it detected it faster than what I expected. Let me try that one more time. There you go, nutrition label found. And here's all the information, the calories, fats, saturated fats. All right. You want one more? Okay. This is stuff that's not available yet, but I think it's pretty cool. This is our face contours demo. It detects over 100 points, processes them in 60 frames per second, And you can see, my lips, my eyes, the entire face contour. So this will be coming pretty soon. There will be a sign-up link if you're interested. And, we look forward to having it in your hands so you can play with it. All right. Thank you. So that was pretty cool. And hopefully you find those base APIs useful. But there are obviously use cases that you might have that are very specific to your application. What if you want to detect different types of flowers? Or like musician, maybe you want to extract a musical note out of a sound stream. You would want to use your own custom model. And MLKit helps with that as well. So there are three benefits of bringing custom models to MLKit. The first one is that the MLKit SDK provides an API layer that interacts with your TensorFlow Lite model. So you can provide inputs, get outputs, just like you would do with the base APIs. Second, you can upload the TensorFlow Lite model to the Firebase console. And that provides two benefits. First, and Brahim alluded to this earlier, is that you can bundle your model with your application if you choose. But if it's big and you want to reduce the install size, you can actually just leave it in the cloud and download it dynamically. So the initial install size is smaller. And the third one, because it lives in the cloud, you can dynamically switch the model. You don't have to submit a new APK or bundle to the App Store or the Play Store. Here's a quick snippet on how you would load that model, how you would refer to it. So let's say I called my model V1. I would put this snippet, and it would retrieve it from the cloud. Now, let's take a step back. When I started, remember I mentioned that there are a lot of other Firebase products that are very useful. And one of my favorite ones, is Remote Config. And what it does is it allows you to dynamically switch values inside your app. It's typically used for things like, switching the color, the background. You can also use it to switch call to action strings. It's really useful for that sort of thing, but it turns out that it's also very useful for MLKit. So here's what I did. I went to the Firebase console, and I created a parameter called myModel. Then I created 3 different target populations. One for people who speak English, another one for people who speak Spanish, and then a default value. So what I'm trying to do here is I'm targeting a different model to those different populations. And once you do that, instead of hard-coding a model name, like is here, you just change that static string for a call to remote config, and then every device, depending on what population they belong to, they'll get their respective model. And this is just a very simple example. You can think of using A/B testing and analytics, so you can test out different models, and you can pick the one that performs best and choose that. So experimentation, as Brahim said earlier, is important in machine learning. All right. Before I wrap up and hand it over to Wei, I want to talk about this compression and conversion of TF models. So let's say you have a TensorFlow model, but what you need is a TensorFlow Lite model to run on device. We have a feature for that, and it's coming soon, as I said. You would upload your TensorFlow model along with training data, and once it's done processing, you'll get a bunch of TensorFlow Lite models to choose from. As you can see, these would be compressed, and they have trade-offs. So they have different accuracy, different inference latency, and different sizes. So depending on what you're most sensitive to, you can pick the one that suits your needs. This flow is currently only for image classification models, but we look forward to adding more in the future. OK, so you'd pick the model that works best for you, you publish it, and then it's just available like any other custom model that you would upload on your own. I know I made this seem super easy with like a beautiful UI and just 3 steps, but this is actually really hard to do. It's an active area of research. It's almost like magic. And to tell you more about that magic, I'd like to invite our resident wizard, Wei. Please come up on stage.
Thank you, Sachin. Hi, my name is Wei. My team, actually right here, my team has mixed machine learning experts and mobile developers. It's been a lot of fun to be part of it and build something that we all believe can be useful. For example, model compression. Now, I'd like to go deeper into the technology behind the magic. But first of all, let me explain why we wanted to support model compression. Running machine learning on the cloud versus on mobile. One big difference is that the mobile environment has very limited computational resource. This makes the model size and the inference speed extremely critical. For today's hardware limit, most mobile applications require very small models, ideally less than a couple megabytes. So on the other hand, if we look at the model architectures proposed by researchers for, say, image classification, to obtain higher accuracy, the machine learning models can go much deeper and larger, sometimes hundreds of megabytes for certain applications. After talking to a lot of mobile developers, we realized that how to make machine learning models small and efficient enough to fit on mobile phones is one of the big pain points. With MLKit, we'd like to address this issue by providing model compression, tooling, and support. So a model compression service or tool takes a large pre-trained model as input and automatically generate models that are smaller in size, more memory efficient, more power efficient, faster in inference speed, with minimal loss in accuracy. As Sachin just mentioned, this is still an active machine learning research area. And our compression service is based on Learn to Compress technology developed by Google Research. And it combines various state-of-the-art model compression techniques. For example, one method called pruning reduces the model size by removing the less contributing weights and operations in the model. We found that for certain on-device conversational models, pruning can further reduce the model size by up to 2x without too much drop in accuracy. So another method is trying to reduce number of bits used for model weights and activations by quantization. For example, using 8-bit fixed point for model weights and activations instead of floats can make the model inference run much faster, use lower power, and reduce the model size by 4x. Specifically, with TensorFlow Lite, switching from MobileNet to Contest MobileNet can speed up the inference by 2x or more on Pixel phones. So the third method trains a compact model called a student model with distilled knowledge from a large model, a teacher model. So the student does not only learn from the ground truth labels, but also the teacher. Typically, the student models are very small in size with much less weights in the model and use more efficient operations for the benefit of inference speed. For example, for image classification, the student models can be chosen from MobileNet, NASNet, SqueezeNet, or any other state-of-the-art model architectures compact enough for mobile applications. We can further extend this distillation idea to simultaneously train the teacher model and multiple student models with different sizes in a single shot. One thing to mention is that very often, for all these techniques, we need a fine-tuning step for the best accuracy. So in this case, we do not only need the original model for the compression process, but also your training data. So for MLKit, we'll provide a cloud service for model compression. For now, we only support image classification use cases, but we'll soon expand to more. So the reason that we support model compression as a cloud service, as I just mentioned, model compression is still an active research area with new techniques and new model architectures specifically for mobile applications invented very fast. For example, from MobileNet v1 to MobileNet v2, it took less than 1 year to invent. So our compression service will automatically incorporate the latest advances in technology for you. Another reason, the compression process typically takes quite some computational resource. It can run multiple hours on GPUs. So we will run our cloud service on Google Cloud to use the computation power there. So what we need from the developers include a pre-trained TensorFlow model in saved model or checkpoint format, and your training data in TensorFlow example format for the fine-tuning step I just mentioned. What we generate will be a set of models with different size and accuracy trade-offs for you to choose from. Since MLKit is running on top of TensorFlow Lite, all our generated models will already be in TensorFlow Lite format for you to download or serve through our model hosting service. So with MLKit model compression service, we're aiming to compress a model up to 100 times smaller depending on your use case and the original model. To give you a real developer use case as example, FishBrain is a local fishing app. They already have their model to identify fish species, and the model is currently running on the cloud. With our model compression service, the original model provided by the developer with 80 megabytes and 92% top 3 accuracy can be compressed to much smaller models with different size and accuracy shown here. As you can see, in this particular case, the accuracies of the generated models were even higher than the original model, which is not always the case, but it's possible, and it's great. To summarize, with MLKit, we'd like to make machine learning accessible to all mobile developers. To achieve that, we'd like to help with every single step in the machine learning workflow, not only how to use the model, but also how to build and optimize your model. Now, I'd like to conclude the talk with a summary of what we'll provide. We are launching in beta the base APIs for both iOS and Android, including text recognition, image labeling, barcode scanning, face detection, and landmark recognition. We are also supporting custom APIs with TensorFlow Lite model serving. Please check out these features at Firebase website. Meanwhile, we'll have a set of new features coming out soon, including high-density face contour API, smart reply API, and model compression and conversion service. We'll soon start to whitelist developers to try them out. If you are interested, please use this link here to sign up. We're super excited about MLKit and how it potentially can help developers build cool machine learning features. Look forward to your feedback, and we're committed to making it great. Thanks for coming, and if you have questions, we'll be available right after this talk at the Firebase Sandbox Q&A area. And we are also having some relevant sessions and talks for you to check out. Finally, please leave your feedback about this session for us to improve for the future. Thank you.
Hey there, IO Live. I am Todd Kerpelman, and I am here inside the very crowded and popular Flutter Firebase Dome, talking to Michael Thompson, product manager of Flutter. Hi, Michael.
Hi, how are you?
I'm doing well, thanks. So there's a lot going on here inside the dome, as well as some stuff going on outside. Tell me, what are we looking at here? What's going on behind us?
So this is our showcase wall that illustrates the wide selection of different types of apps you can build with Flutter. So Flutter, of course, is Google's multi-platform SDK for building mobile apps for both iOS and Android. So what we're seeing here are some apps that look very traditional iOS look and feel. We're seeing an app from Google over here from our Atlas team that has a much more traditional material look and feel. And we're seeing a number of apps that have a much more custom look and feel, where they've tried to create this more brand-specific extension, and where the layout of the app really is an extension of that brand.
And so what else can an attendee find if they're exploring the Flutter Dome?
Yeah, so what we're seeing here is the end result. And the thing that's really interesting is that's just one of our key components of our offering. The other thing is we have a great developer experience. So when you try and create UI, whether it's more traditional or more custom, we found that there's a lot of iteration going on. You may have one notion of what your screen should look like, but it's really helpful to take that and tweak it and step by step to build up your UI. So for that, we built something called Hot Reloads, which is the ability to update the current screen you're looking at, and in just a few hundred milliseconds, push a small change to that running application, preserving the whole state without having to re-navigate back in. And that's actually an example of all the great engineering we do in this project. So when you use Hot Reload, you're running against a virtual machine, which is how we can do those quick reloads. But when you're running these apps in production, very importantly, we compile these to native ARM machine code. So you get the combination of fast iteration speed at development time with fast execution speed in production builds.
The thing about Hot Reload that I think maybe not everyone gets at first is this is actually running on a real device. Like the game, you're editing real code.
Yeah, so this is, we do a lot of
We can push to overdrive. We can take this past the line. Think of all that we can do with just one of me and one of you. Hey! Doing what we want now. Hey! No one's ever gonna take us out.
Good afternoon, everyone. Welcome.
Hello.
Thank you. My name is Vinamrata Singhal. I'm a product manager on the Chrome Web Platform team. I work on Lighthouse, Speed Metrics, and a whole bunch of other performance tooling initiatives at Google.
And I'm Rick Viscomi. I'm a developer programs engineer on the content ecosystem team. And I work on web transparency tools like HTTP Archive and the Chrome User Experience Report.
And today, Rick and I are here to tell you a little bit about how you can use Lighthouse and the Chrome User Experience Report to guide the performance of your web application. But before we get started, I wanted to tell you a little bit about myself so you know who you're talking to. So fun fact fact about me, when I was growing up, I've actually grown up in 4 different countries: India, Saudi Arabia, New Zealand, and the United States. And what was interesting as I was growing up across these countries was having access to information was really challenging, either because it was restricted for me and my family, or because no one around us had that information. And that really changed when I started learning how to use the web, because it just made it so much easier to have access to that information. So that's why I really care about making sure the web is available for everyone and is a great experience for all. But even as I was learning how to use the web, there were definitely some pain points with that experience. So this is actually a picture of me as a kid in Saudi Arabia on DSL internet, if you remember those days, learning how to use the internet. And it was really, really, really slow. And what's interesting is that this slowness and this performance pain actually hasn't really gone away for a lot of users. And at Google, we've seen that it has real implications for businesses as well. So we actually have been collecting a whole bunch of data to show the impact that performance can have for businesses. You might have seen this study that we did with DoubleClick that shows that for sites that load in less than 5 seconds, they actually experience a bounce rate that is 53% lower compared to sites that load in more than 5 seconds. Additionally, we have data from Kissmetrics that suggests that shoppers who have trouble with site performance, 79% of them just don't come back. Additionally, for every second that there's a delay in page load time, there's a 7% drop in conversion rate. I just want to emphasize that again. For every extra second that your site is slower, you can lose 7% of your users. Now, this is all to say that if you're a business that's online, you should care about performance. And you might say to me, like, Vinamrata, I get it. Like, I should invest in performance, but what do I do about it? What is the guidance? What are the tools? What are the metrics? And to that I say, you've come to the right place. And we hope that to answer these questions and many more. So to give you a little bit of overview, what we'll be talking about today, we're going to start off by giving you a little bit of information into performance metrics, and then kind of walk you through the overall tooling and guidance landscape. Then Rick is going to take over and tell you a little bit about the Chrome User Experience Report, and then I'll wrap us up with Lighthouse. So let's get started with performance metrics. So when we talk about performance metrics, what we're really talking about is collecting data. And there's kind of 2 sources of data you want to collect. The first is lab data, which is also known as metrics from the lab. And when you're collecting lab data, it's essentially performance data that you're collecting in a controlled lab-like environment. And this can be really useful for getting very granular performance information of your site. The second type of data is what we call field data, or metrics from the wild, or you might have also seen this referenced as RUM measurement or real user metrics. And the idea is you're collecting data about how real users are experiencing the performance of your site. And this is really helpful in understanding the ground truth of the performance of your site. Now, you might look at this image and think that, oh, like, am I supposed to use one or the other? But in reality, we recommend that you use both of them together. So the first step is that you use field data to just like understand your users, understand the baseline performance of your site. Where are your users coming from? What devices are they on? What networks are they on? That really helps you understand how to calibrate your lab environments. Once you understand the baseline and whatever business or key performance indicators you're trying to optimize for, then you can set goals around the targets for whatever you want the performance to be. After you understand that, you want to start looking at the lab data, calibrated from what you saw in the field, to really drill down and understand what parts of the performance you need to improve, as well as implement the optimization to make the site faster. Once you've made improvements in the lab, you want to go back to the field to make sure that you're actually seeing the improvements in the lab, in the wild, and then also monitoring the performance of your site for regressions. So now that we've spent a whole bunch of time talking about where this performance data comes from, you might be asking, what data do I collect? And when we think about the performance of a site, what we're really trying to quantify is how does a real user experience the performance of your site? And there's kind of 2 buckets of those user experience. So the first bucket is what we call visual metrics. So this essentially measures how fast is stuff getting painted on the screen. And then there's the second bucket, which is interactivity metrics. And that's essentially measuring how quickly does your site become usable for your users. And under these buckets, we have specific metrics. In the visual metrics section, we have metrics like first contentful paint and speed index. And then in the interactivity metrics section, we have metrics like time to interactive. And to really understand what those metrics mean, I think it's helpful to visualize them on a timeline. And let's go back to the concept of, ultimately with performance, we're just trying to measure how real users experience this. So on the very far left, you have first contentful paint. So what this means is when the first piece of content starts appearing on your screen, could be text, image, or SVG. And this is a really pivotal moment in the user experience, because this is the point where users like, OK, the site is loading, it's like doing something. And then you have at the very end, you have time to interactive. And what time to interactive basically for a user means that everything is loaded, they can interact with any part of your page, and it just is responsive, it works. And then everywhere in the middle, you have what we call speed index, which essentially measures how quickly does the rest of your page load. And speed index tends to reward pages that load a lot of stuff earlier, because that to a user feels very, very fast. And we've actually seen a lot of developers have success with this toolkit of metrics. I want to share an anecdote of one of my favorites. So a lot of you might have heard of Pinterest. We actually spent a whole bunch of time with Pinterest helping them upgrade their mobile web experience to a progressive web app. And as a result of this, they also wanted to improve the overall interactivity of their experience. And they actually improved their time to interactive from 26 to 5.6 seconds. And as a result of this, they saw a whole set of improvements across their business metrics. So they saw an overall 40% increase in the number of users who spend more than 5 minutes on their site. They saw a 44% increase in the amount of user-generated ad revenue. They saw a 50% increase in the amount of ad click-through rate, as well as a 60% increase in core engagement. So all in all, this is really awesome work. But what's interesting is I think that we can still do a lot better to help developers understand the interactivity experience. And specifically, I think the place where we can make a lot of impact is right now time to interactive is only a lab metric. I think we can do a better job of helping developers understand interactivity in the wild. How are users first starting to actually understand the interactivity or experience, especially when they come to your app for the first time? I think in order to make this a little bit more concrete, I want to tell you a story. So imagine for a second that you're not a developer, you put your developer hat down and you're a user. So pretend that you just heard about this new site. Let's say it's like vinamrada's.coolstore.com, and you decide to go on it on your phone. And it's like loading, and so you decide to start interacting with it, and you click on a button, but nothing happens. So you keep clicking on this button, but nothing is happening. Raise your hand if you've ever had that happen to you. Yeah, it's like everyone. Keep your hands up. And keep your hands up if you were really frustrated by that experience, or you felt any frustration. OK. It's like everyone for those on the live stream. So again, it's a really frustrating experience. So putting our user hat down again, and then putting our developer hat back on, we can probably understand why something like this would happen. So one explanation for this is, the browser is done rendering all the HTML and CSS, but because you have so much JavaScript, the browser is taking all this time to compile, parse, and execute all the JavaScript. So when this new user input action comes through, the browser doesn't have time to respond to it because it's blocked by all the JavaScript that your website has. And this is exactly the type of user experience we want to minimize with a metric called first input delay, which we're introducing for the first time today. So first input delay is essentially measuring the latency of the user's first interaction with the page. And what this basically means is from the time that a user interacts with your page, the time that when that happens, to the time when the code that you wrote to respond to that interaction actually runs. And we think really focusing on the first user experience is really critical because as you saw a couple slides ago, a lot of users leave if the first experience is terrible. And if you want to optimize business metrics like bounce rate and conversion rate, then you need to make sure that your first experience is really, really solid. We're still working on the definition of this metric as well as our messaging. So we really encourage you to give us feedback. Here's a link to some docs and a JavaScript polyfill that you can start using to measure first input delay on your website. So check it out, and please give us feedback by filing an issue on the polyfill repo. So now that we've spent a whole bunch of time talking about metrics, let's transition to talking about the overall tooling and guidance. So this is kind of an overview of all the tools that we have published as Google about site performance. And one of the most common questions we get is, Google, you've put all these tools out, but how do I navigate this? How do I use this? What tool should I be using? Great question. And ironically, we built a tool to help you understand this. But not ironically, it's pretty awesome. So this is what we call the Speed Tools Overview. It's essentially an infographic that helps you understand for which use case, whether it could be, I just want to build a business case for performance so my company invests in it, to, I actually want to get really nitty-gritty into performance. And all the use cases in between helps you understand what tool you should be using. So I really encourage you to check it out and give us feedback about things that you think are missing. And we're really looking forward to hearing more from you. So now that we've covered a little bit about tooling and metrics, we thought it would be really helpful to deep dive into two tools in particular. So I'm going to hand it off to Rick now, who's going to tell you a little bit about the Chrome User Experience Report.
Thank you. So when we talk about metrics from the field, most people think of traditional real user measurement, or RUM, where you measure things like performance, page load, page views, and conversion. This is great for understanding the user experience on your own site, but how do we understand the user experience on the web as a whole? How do we know if the web is getting faster or more usable? How do we know if our site's performance is considered normal? For that, we need a different set of metrics from the field that represent the web at large. The Chrome UX report, also known as CRUX, helps us understand the state of the web. Specifically, it's a public collection of web performance data from real Chrome users. Let's see how it works. So when you have a data set that covers the web at large, it enables analyses that were never before possible. For example, you can compare real user performance across particular sites. And you could see how you stack up against competitors. In this example, we can see that competitor B is slightly faster than my website. This is a really good motivator for me to care about web performance. Because it's one thing to know how fast my site is, but it's another to see just how much faster or slower it is compared to the competition. Additionally, the Chrome UX report is updated monthly, so you can track your performance benchmarks over time. As I optimize the performance of my site, I can actually see those gains in each iteration of the report. Or alternatively, I could see that my competitor is investing in performance, and I really need to catch up. So what exactly does the Chrome UX report measure? It includes some of the visual metrics Vinamrata mentioned earlier, like first and first contentful paint. It also includes traditional page load metrics, like DOM content loaded and onload. When I'm exploring this data set, my go-to metric is always first contentful paint. Of the 4 metrics, it most closely reflects the real user experience of feeling like the page is loading. It also includes useful dimensions for slicing the data, like the form factor of the user's device, desktop, phone, tablet, and the effective connection type in mobile terms, 4G, 3G, 2G, and even offline. This reports the effective speed, not the advertised network. For example, a user on slow Wi-Fi would be considered 2G. Another dimension that early users requested was the ability to slice by country. With it, you can see how the user experience varies by geography. For example, it can help you understand how much slower the user experience is in places farther away from your web servers. There are 2 ways the data is aggregated, by URL and by origin. So how does an origin differ from a URL? It starts with the protocol. Either it's secure or not secure. The subdomain, for example, www, mail, or no subdomain at all. And of course, the domain, like google.com or example.com, which itself includes suffixes like .com, .co.uk, .edu. What an origin doesn't include is the path after the domain. Index.html, product/123. Performance from all of those paths are aggregated at the origin level. There are approximately 4 million of these origins in the dataset. This has grown 400x since it was first announced at the Chrome Dev Summit in October. And it's still growing each month. Now, it's worth mentioning that there are way more than 4 million origins on the web, so your website may or may not be included depending on its popularity. OK, you're probably wondering, how do you start using it? The raw data is available on Google BigQuery, which is a data warehouse with SQL-like syntax. You can write queries to get insights about specific origins or the web as a whole. In this query, we're calculating the monthly density or proportion of user experiences in which the first contentful paint is less than 1 second. It's broken down by 2 hypothetical competitors, developers and chrome.google.com. The raw results are definitely informative, but it's kind of hard to understand just by looking at it. What we're trying to understand is which origin is faster and how are they trending? To help answer that, let's visualize the data. We can integrate with 2 Google tools, Sheets and Data Studio. You'll notice on the BigQuery results page, there's a button to export to Sheets. That will automatically create a new sheet and populate it with a table of data. From there, it's easy to create a simple chart to visualize the performance data. It's clear from this chart that developers.google.com has a higher density of first contentful paint experiences less than 1 second. Also notice that the performance fluctuates month to month. Why would that be? It's not just that the sites themselves are getting faster or slower. It could be user population changes as well. For example, the population of users on faster or slower connections could be fluctuating. You can also integrate it with Google Data Studio. With it, you can build fully customizable and interactive dashboards and get live updates from the raw data on BigQuery. So for example, this dashboard is showing one way you could monitor the distribution of performance metrics over time. But what if you don't want to work to get this data and you just want high-level results now? There are a few Google tools built on the Chrome UX report to help you get insights quickly. The first is PageSpeed Insights, which was recently updated to include this real user performance data, alongside its popular performance optimization recommendations. PageSpeed Insights is built on the URL aggregated report data. This is more targeted performance data that you can get on BigQuery. And here we're looking at the home page for Google I/O. PageSpeed Insights also surfaces the median first contentful paint and DOM content loaded metrics, as well as an indicator to convey how fast or slow it is in relation to the rest of the web. And it turns out that the I/O web page is actually considered slow. PageSpeed Insights also shows the distribution, so you can get a sense for how skewed user experiences really are. In this case, we see that most first contentful paints are fast, but 82% of DOM content loaded experiences are considered slow. Another Google tool built on the Chrome UX report is the Speed Scorecard. This tool allows you to enter multiple websites and stack rank their performance. It also enables you to target specific geographic regions and connection speeds to see how performance varies. It also has something I really love, a way to correlate performance metrics with business metrics like revenue. It estimates how much more revenue could be earned if nothing else changed but site performance. You just use the slider to simulate performance improvements and its predicted effect on revenue. Again, this is another really great motivator to invest in performance, and not just for developers, but especially business leaders who think in dollars. Last, I wanted to share a case study of how the Chrome UX report is being used outside of Google. mPulse is a real user measurement product from Akamai, a leading CDN provider. Akamai is able to use the Chrome UX report to convince potential mPulse customers to care about real user measurement. For example, some companies don't have any RUM tools at all, and they may be relying on lab testing like web page test, which only gives them a narrow view of their performance. Akamai can show these companies their real user performance in the Chrome UX report, which may be vastly different from their performance in the lab. Just imagine the surprise to learn that users experience your site many times slower than your lab tests indicate. Akamai is also looking to integrate this data with their mPulse product. Recall that with metrics from the web as a whole, it's possible to see performance of competitors. In mPulse, for the first time, a customer could see competitors' real user performance data alongside their own. And by leveraging form factor, connection, and geography dimensions, site owners are now able to better understand how they stack up in specific markets. The charts shown here indicate how differently competing sites perform, especially on mobile. And this is exactly the kind of thing that makes the Chrome UX report so powerful, understanding how your site's performance fits into the larger picture of performance on the web as a whole. So this is just a small taste of the power of the Chrome UX report dataset, and it's only getting better over time. There are new datasets being released every month. In fact, we just had the April dataset released this week. We're also looking to add more user-centric performance metrics, like first input delay mentioned earlier. And we're working with other partners to get this data integrated into more third-party tools. So now I'm going to hand it back to Vinam Radha to tell you about Lighthouse.
Thank you, Rick. You guys can clap. Awesome. So more audience participation here. Can you all raise your hands if you've ever used Lighthouse before? Oh, awesome, yay. So for those of you who haven't, Lighthouse is a developer tool that you can run today on your website. And it basically gives you personalized advice about what you're doing well and what you can do better across 5 different categories: performance, progressive web app or PWAs, accessibility, best practices, and search engine optimization or SEO. Today, you can run Lighthouse through 4 different ways. You can run it as a standalone Lighthouse Chrome extension. You can run it on the audits panel in Chrome Developer Tools. You can run it as an NPM module, and this is the NPM command to install it if you choose to. And you can run it on web page test. Now, I want to take a step back and tell you a little bit about the journey that we've kind of taken on the product side to give you a little bit of context of where we're going. So this is a screenshot of Paul Irish, who's the tech lead on Lighthouse, announcing the project at Chrome Developer Summit. And our goal with Lighthouse was we understand that there's a lot of advice kind of thrown at developers like every day about like new things that you should be doing to create really good web experiences. And we really wanted it to be like the one-stop shop that you have to go to get all the advice in one place. And we've been hard at work at making this tool as comprehensive as possible. So we've actually launched over 100 audits into the report, including a whole new section focused on search engine optimization this year. And we've seen a lot of really great adoptions in the community. Specifically, in 2018 alone, we've seen over 500,000 users running over 2 million plus audits, which is great. And we hear stories from developers all the time about all the success they're having with Lighthouse. So I want to share with you one of my favorites. So this is Milan. Milan is a fashion e-commerce retailer based out of China. And they actually used Lighthouse when they were making performance improvements to their site as well as building a progressive web app. And they actually improved their Lighthouse PWA score by 57 points to 100. And they improved their Lighthouse performance score by 35 points to 75. And as a result of just making these 2 improvements, they were able to see a 10% increase in their mobile conversion rates, as well as a 65% decrease in their ad bounce rate. So pretty awesome stuff, but we also know that on the Lighthouse team, there's still a lot we can do to make the product even better for y'all to use. So let's just summarize this as like our top user requests. So the first user request we get, especially from people who are looking at the Lighthouse report for the first time, is, hey, like, can you make this report easier to understand? Because it's like kind of cluttered and kind of confusing. So that's one request we get. The other request we get is, I run Lighthouse, but the performance metrics and scores change from run to run, even if I'm running it the same way. Can you make Lighthouse more stable? And then the third is, I love Lighthouse, it's awesome, but I don't want to just run it on one site. I want to be able to run it on hundreds and thousands of sites. Can I conduct a bulk analysis using Lighthouse? And today, I'm going to walk you through how you can do all 3 of those things with new stuff that we've been working on. Let's get started with the first one, about how to make the report easier to understand. So we take this concern pretty seriously, and we actually did an entire usability study in the earlier part of this year. And taking results from that study, we actually came up with this whole new UI, which you can see today. You can also see this UI in the mobile web sandbox if you try using Lighthouse there. But my personal favorite new feature of this UI, which unfortunately you can't see from the screenshot, is when you hover over all the metrics, there's like a little tooltip that comes up, and it gives you more information about the metrics. So if you've never heard of like first CPU idle, you can kind of get a better understanding of what it is. And this new UI is actually launching with 3.0, which we're planning on releasing this week. You can get 3.0 today through NPM, doing Lighthouse at Next. It'll be the default way to run Lighthouse on the Chrome extension, which we'll be releasing later this week. And it will be coming to DevTools in Chrome 68. If you want more information about everything else that's coming in 3.0, you can check out that doc over there. I'll be walking through some more updates, but that doc has all the information. So let's move on to talking about the second concern that folks often have with Lighthouse, which is around the performance score. So these are actually scores that I got for a website that I will not name for their performance score of their site. And this was just consecutive runs one after the other. And again, this is a problem that we've actually known for a very long time. And we had a concerted effort since last year to work on it that we're calling Project Lantern. In my opinion, it has the best logo out of all the logos that we've ever created. So to understand what Lantern does that's different, I want to tell you a little bit about how Lighthouse computes performance metrics today. So when Lighthouse is computing the performance metrics of your site, what it's doing is it's actually throttling your page, trying to emulate it as if it was a user on a mobile device on a 3G network, and then computing the performance metrics accordingly. What Lantern does is basically completely rechanges the way we do this. Instead, it tries to estimate based on inputs you give it about what network and what device the user is on to compute the performance metrics itself. And using this approach, we've actually been able to see a 50% reduction in the amount of variability in the Lighthouse performance score while maintaining accuracy with what you get with traditional DevTools throttling. In addition, as a side bonus, you also reduce the amount of time it takes to run and warm up Lighthouse by 50%, which I know it can be annoying for a lot of people. So one question you might be asking is like, how does Lantern do this stuff? And I'm going to give you a very high, broad level walkthrough of how Lantern does what it does. So the first thing that Lantern does is it basically gets a static list of all the assets that are necessary in order to render your page. And in this extremely contrived example, in this case, it's like the index.html along with the blocking.css and JavaScript. And once it kind of knows, these are the assets, this is how much the assets weigh, then it takes into account the RTT, the time it would take to transport one packet, and in this case, it's 150 milliseconds. And this number is kind of estimated based on two variables on the right, in which case it's the network throughput as well as the CPU throttling. And then using the RTT as well as knowing the size of all the assets that are required to be transferred in order to render your site, Lantern can then predict all the different performance metrics. And on the bottom, you can see all the different things that need to occur in order to open the network connection are also taken into account. And that's kind of gives you a very high level of how Lantern works. So Lantern is going to be the default performance engine for Lighthouse, starting with 3.0. And so if you want to get started on understanding Lantern as well as using it, you can just get 3.0 the way that I showed you earlier. So now I want to move on to talking about scale, specifically scaling Lighthouse. And today, I'm happy to announce that we've been working on an API. This is the Lighthouse API. It's a RESTful API that allows you to get Lighthouse results for any URL. And I am really excited because I think it unlocks a couple of really important use cases that people have been talking to us about. The first is it allows you to build dashboards. You can track not just your home page or landing page, but you can track all of the different side pages that you might have. Second is, you can build tools on top of Lighthouse, as well as integrate Lighthouse into whatever continuous integration test suite that you might have. And then finally, you can conduct large-scale data analysis using Lighthouse itself. This is an overview of what the API currently looks like. And for those of you who use Lighthouse on the command line, you can see it's pretty similar to what the command line would give you, except we've made it a little bit more ergonomic for people to use. So the current status of the API is that it's in private beta. We've currently been working with a couple partners in order to iterate on the definition. If you're interested or intrigued by this API, I'll have more information later on in the talk about how you can get whitelisted for access. But we're planning on launching it as a free public Google service very, very soon. So I want to take a little bit of time to tell you why I'm personally really excited about the API. One of the things that I was mentioning earlier was, we have all these tools, and we're trying to align our tooling story together. But one of the problems that we've had in that is we don't really have a common infrastructure that all the tools can kind of rely upon in order to align the tools. And I really think that Lighthouse API gets us one step closer because it kind of creates a pipeline that a bunch of other tools can use in order to align all the tools together. And so I'm sure you'll be seeing a lot more tooling alignment initiatives in the future. So now you might be wondering, as an external developer, what can Lighthouse do for me? So I want to tell you a little bit about what two of our partners did with the Lighthouse API. So the first one is Mobify's logo you can see over there. Mobify is a platform for retailers to build customer-first shopping experiences through progressive web apps and accelerated mobile pages. Some of their customers include Lancome, Lilly Pulitzer, and Car Parts. And as part of this platform, they have this product called the Analytics Dashboard, which essentially makes it easier for business leaders at these retailers to monitor performance and customer engagement. So in order to make this process easier, monitoring performance and customer engagement, they actually integrated the API into their dashboard. And this is what it looks like. So this really helps business leaders kind of get a better understanding of how the performance metrics that Lighthouse is reporting can be correlated to business metrics they might care about. In this case, this is actually a live example of how one of Mobilify's clients, Debenhams, which is a leading British retailer, actually uses the data provided by the API to be able to correlate the scores with bounce rate, which is a metric that they care about. And I'm really excited for this use case because I think this really helps business leaders understand the return of investment that they're getting for putting work into performance and just makes it that much more obvious. So the second partner that I want to talk about is Duda, which is a website builder for web professionals and agencies. There are currently over 12 million sites that are built using Duda. And Duda really wants to make sure that whatever sites are being built, that they're fast, and especially as they add new functionality to the platform. And so they were actually using Lighthouse to add progressive web app functionality to the platform, but now with the API, this process becomes really easy because they're just able to integrate Lighthouse into their continuous integration pipeline. So Duda uses Jenkins, as you can see, to do their continuous integration tests. And as you can see over here, they've just added Lighthouse as one of the components. And they're able to set thresholds for their developers so that if it doesn't meet the threshold, they fail the build. In this case, the build has failed. And they're able to kind of dig into the report to understand what audits are passing, what audits are failing. And again, I think this unlocks a use case that we've heard from a lot of developers with Lighthouse, which is once you do all the work and the time investment to make your site fast, to make it a PWA, then how do you keep it that way? And I think the API makes it really easy because you can just integrate it into whatever continuous integration system you have. And Duda actually plans that once the API is publicly launched, to release this plugin to the entire Jenkins community so that if you use Jenkins, it's that much easier to get started with Lighthouse. I really want to thank both Duda and Mobilify for all the work they did in pulling these demos together. They're super awesome, and I'm even so much more excited to see what you do with this API. So if you were intrigued by any of the demos that we just shared, and you want to get early access to the API, you can sign up on this interest form over here, and a member of our team will be in touch with you very, very shortly. We'll wait until the phones go down. Oh, OK, still going. Awesome. OK, so I'm going to wrap up the talk. Rick and I talked about a lot of stuff, and I want to wrap it up with some key takeaways, of which there's only one. So the main takeaway that I hope that you get is that there's two kinds of performance data that we care about. There's lab data and field data. And lab data is essentially data that you collect in a controlled lab-like environment. Really helpful for drilling down into specific performance information and getting really granular and nitty-gritty. Field data is really useful if you want to understand the source of truth about the performance of your site, because it's essentially data you collect in order to understand how real users are experiencing the performance of your site. Lighthouse is a tool that can give you lab data, and the Chrome User Experience Report that Rick talked about is a tool that can give you field data. Now, a talk by a product manager wouldn't be complete without any action items for you all to take. So I'm going to list 4 of them out. So this is a really good time to take out your phones and take pictures, because I'm going to kind of go through this quickly. So the first action item we have is about first input delay, which is our main interactivity metric in the wild. So if you're interested or intrigued about improving how real users are dealing with the interactivity of your website, I encourage you to check first input delay. Here's a link to the docs. Here's a link to the polyfill. Please give us feedback. The second is around the Speed Tools overview. This is a tool that can really help you understand what tool you should be using when thinking about the performance of your site. Finally, we have the Chrome User Experience Report that Rick talked about. If you want to understand how to baseline your performance statistics, do competitor analysis, and all these other really cool use cases, check out Chrome User Experience Report. Really cool tool. Always making it better. And then finally, we have Lighthouse. Lighthouse you can run on your browser if you use Chrome. And you can also look into using the Lighthouse API if you're interested in using Lighthouse at scale. Here's the early interest form. And that's it. So thank you so much, everyone, for coming. I know it's like 5 p.m. on a Wednesday, so really appreciate all your time. So we are going to stick around for a little bit if you have additional questions, but you can also find us at Sandbox G, will be there for most of tomorrow, so come say hi. But I'm Vinam Radha, and have a great rest of your I.O. Thank you so much.
Thank you.
Doing what we want now. No one's ever gonna take us down. Feeling like we're supposed to. Now the sun's out, sun's out.
Hey there, IO Live. Todd Kerpelman here, and I'm here with Jen Tong, who is apparently using the power of the cloud to like find new planets. No big deal, you know.
Yeah, why not?
Sure. So Jen, what is going on here at this booth?
So behind us, we see Project Panoptes, which is an open source project that includes open source hardware that is composed entirely of commercial, off-the-shelf components. And it is intended to be low cost enough for educational institutions and hobby astronomers to build these robotic telescopes and contribute to the project.
And so what happens once they build these robotic telescopes? How are they discovering stars, or planets, I should say?
So the way they discover planets around other stars is by combining their efforts using the cloud. So what happens is each night the telescopes will all wake up and look at the sky, and they'll get a bunch of great images of the sky, and then when the day comes they'll go to sleep, but not really. They're going to start uploading all of their data to the cloud platform, and from there we can combine all the data together, aggregate it, and then from that we can infer the existence of planets around other stars.
And how do you infer the existence of planets?
So planets are very hard to see directly because their stars are very bright and there's lots of glare and they're very far away. In fact, a star only looks like 1 pixel on the camera. So we have to use some trickery to do that. So instead of looking for the planet directly, we look for a dimming of the star when the planet moves between us and the star, kind of like an eclipse, or we call it a transit in a more general case.
And so the general idea is you've got hundreds of telescopes all around the world taking pictures of the night sky. They combine all those images up to Google Cloud, which analyzes them all and looks for a star that dims on a regular enough basis that you think it must be because there's a planet passing in front of it.
That is exactly correct. So we were able to infer that just by having a whole bunch of samples from having a very large fleet of telescopes.
Wow, that's very interesting. Now, if I remember from being 3 years old, stars do twinkle. How can you tell that a star is dimming because of a planet passing in front of it versus like, you know, normal star twinkling, which is totally a technical term?
Totally technical. And that's a great question because that's part of the stuff that makes Panoptes special. Because we're using commercial off-the-shelf cameras instead of specialized astronomy sensors, we have to compensate for the fact that those cameras are designed to take color photos. Because when a camera takes color photos, it filters some of the light out using this thing called a Bayer filter. And when the star twinkles, it moves around that Bayer filter, and it makes it much harder to count the number of photons, because we don't know how much are getting filtered out by the Bayer filter. So the way we compensate for that is we look for another star in the same picture that has the exact same amount of twinkle. And from that, we can do a relative brightness measurement, because we know how bright those stars should be, because we can identify the star. And that's how we kind of cancel out the twinkle.
And I'm contractually obligated to ask, what awesome Google Cloud Platform features are you using to power Project Panoptes?
Yeah, Panoptes definitely kind of illustrates that boring uses of the cloud can enable really cool stuff. So we are using some simple stuff. We're using some of the simple security controls. We're putting a service account on each one of the devices so we can control access to a specific telescope, can access a specific part of our storage buckets. And then we're using Google Cloud Storage to store all of that data, and then we're aggregating it on Google Compute Engine.
And so the general idea is anybody can get involved, they can build their own telescope, and they can be part of this project, and then if they find a star, they can name it after themselves. Is that basically it?
Well, naming stars is a more complicated issue. And individual Panoptes telescopes don't actually discover a star themselves. It's kind of like a team that collaboratively accomplishes a goal. But yeah, anybody can get involved. We especially like to work with hobbyist astronomers and educational institutions because we want to kind of inspire a love of astronomy in the youth around the world.
That's good. And how would I get started if I wanted to?
So I encourage you to go check out projectpanoptes.org.
All right, so you heard it here. Go to projectpanoptes.org, and you too can name a star after you. Jen totally promised.
Hi, everyone. My name is Samir Kataria, and I'm an engineer on the Android team. I work on architecture components, and today I want to talk to you about a new library we have called Work Manager and background processing in general on Android. So let's talk about background processing in 2018. What are we trying to do these days? Just this morning, I was trying to send a picture of my lovely wife and my beautiful son to the rest of my family. So that's an example of background processing. We're also sending logs, syncing data, processing that data. All of this work is being done in the background. And on Android, there's a lot of different ways you can do this work. Here's a lot of them. You can do things on threads and executors using Job Scheduler, Alarm Manager, async tasks, etc. Which one should you use, and when should you use it? Meanwhile, Android also has a lot of battery optimizations that we've introduced over the last few years. For example, we introduced Doze Mode in Marshmallow. If you've been following Android P, we've had app standby buckets. In Oreo, we restricted background services. So all of these things have to be taken care of as a developer. And finally, we always have to worry about backwards compatibility. So if you want to reach 90% of Android devices, you want to at least have a Min SDK of KitKat. So given all of this, what tools do you use and when do you use them? And the trick behind this is that you have to look at the types of background work that you're doing. I like to split this up into two axes. The vertical axis here is the timing of the work. Does the work need to be done right when it's specified, or can it wait for a little bit so that if your device enters Doze mode, you can still do it after that? Also, on the horizontal axis here, how important is the work? Does the work only need to be done while your app's in the foreground, or does it absolutely need to be done at some point? So for example, if you're taking a bitmap and you decide that you want to extract a color from it and update your UI with it, that's an example of foreground-only work. You don't care about it once the user hits home or back. That work is irrelevant. Meanwhile, if you're sending logs, you always want that to happen. That's an example of guaranteed execution. So for things that are best effort, you really want to use things like thread pools, RxJava, or coroutines. For things that require exact timing and guaranteed execution, you want to use a foreground service. So an example of this would be that the user hits a button and you want to process a transaction and update the UI and the state of the app based on that. That really needs a foreground service. That needs to happen right then. Your app cannot be killed by the system while that's happening. This fourth category is very interesting. So you want guaranteed execution, but you're OK if it happens later. Doze mode can kick in. And there's a variety of ways to solve it. On your APIs, you'll use Job Scheduler. If you want to go a little further back, you can use Firebase Job Dispatcher to do that. And if you don't have Google Play services, you'll probably end up using Alarm Manager and broadcast receivers. And if you want to target all of those things, well, you'll use some mix of these four things. And that's a lot of APIs, a lot of work to be done. Work Manager falls here. It's guaranteed execution that's deferrable. So Work Manager, let's talk a little bit about its features. I just mentioned guaranteed execution is also constraint aware. So if I want to upload that photo that I talked about, I only want to do it when I have a network. That's the constraint. It's also respectful of the system background restrictions. So if your app is in Doze mode, it won't execute. It won't wake up your phone just to do this work. It's backwards compatible with or without Google Play services. The API is queryable, so if you have enqueued some work, you can actually check what is its state. Is it running right now? Has it succeeded or failed? These are things that you can find out with Work Manager. It's also chainable, so you can create graphs of work. So you can have work A depending on work B and C, which in turn depends on work D. Also, Work Manager is opportunistic. So this means that we will try to execute that work in your process as soon as the constraints are met, without actually needing Job Scheduler to intervene or call you out and wake you up. It doesn't wait for Job Scheduler to batch your work if your process is up and running already. So let's talk about a little bit of the basics and talk through the code. So I just described the example. I want to upload that photo. So how would I do that using Work Manager? Let's talk about the core classes. There's the worker class. This is the class that does the work. This is where you will write most of your business logic. And there's the work request class, which comes in two flavors: one-time work request for things that just need to be done once, and periodic work request for recurring work. And these will both take a worker. I'll show you just now. So here's my upload photo worker. It extends the worker class, and it overrides the do work method. This is the method that will run in the background. We'll take care of that on the background thread. You don't need to put it in the background thread. So you simply do your work. So in this case, we upload the photo synchronously, and we return a result. So in this case, let's say we succeeded. And the worker result enum here has three values: success and failure, which are fairly obvious, and retry, which says, I encountered a transient error. Let's say that the device lost network connection in the middle. So retry me after a little bit with some backoff. So now that I have this, I can create a one-time work request using the upload photo worker, and then I can enqueue it using workmanager.getInstance enqueue. So soon after this is enqueued, it'll start running. You'll upload your photo. But I just talked about this. What if you lose connectivity in the middle of this? Or even before this, what if you never had connectivity? You actually want to use constraints in this case. So an example of the constraint here you want to use is you make a constraints builder, and you say, set required network type to be connected. So you need a connected network connection. You build it, and you also set the constraints on the request that you just built. So by simply doing this and then enqueuing it, you make sure that this work only runs when your network is connected. So let's say we want to observe this work now that we've done it. So I want to show a spinner while this work is executing, and then I want to hide the spinner when it's done. How would I do that? So as I said, I'll enqueue this request. And then I can say get status by ID on Work Manager using the request ID. So each request has an ID. And this returns a live data of the work status. If you guys remember architecture components, live data is a lifecycle-aware observable. So now you can just hook into that observable, and you can say, when that work is finished, hide that progress bar. So what is this work status object that you were looking at the live data? It has an ID. This is the same ID as a request. And it has a state. The state is the current state of execution. There's 6 values here: enqueued, running, succeeded or failed, blocked, and canceled. And we'll talk about the last 2 later. So let's move a step up in concepts here. Let's talk about chaining work. So I promised that you can actually make directed acyclic graphs of work. How would you do that? Let's say this is my problem now. I'm uploading a video. It's a huge video. I want to compress it first, then upload it. So these are both eligible for background work because they're time-intensive things. So let's say I have 2 workers, compress photo worker and upload photo worker. They're both defined to do the things that I just said. So you can make work requests from them, and you can say, Work Manager, begin with compress work, then upload work, and enqueue it. So this ensures that compress work executes first, and once it's successful, then upload work goes. And if you were to write this out, because that was a very fluent way of writing it, what happens behind the scenes here is that begin with returns a work continuation. And a work continuation has a method called then that also returns a work continuation, a different one. So you're using that to create that fluent API. So you can actually use these work continuations and pass them around if you want, et cetera. So let's say that I'm uploading multiple photos. I take lots of photos. No one takes only just one photo of their child. So how would I upload all of these in parallel? Well, so let's say I've got a work request for all of them. I can literally just say .enqueue and put all of them there. It's a var args, so you can pass more than one thing there. And these are all eligible for running in parallel. They may not actually run in parallel depending on your device and the executor being used and all of that, but they could be. So let's choose an even more complex example. Now you want to filter your photos, so you want to apply some kind of, I don't know, grayscale filter or sepia filter to them. Then you want to compress them. Then you want to upload them. How would you do this? Work Manager makes it very simple. So first you say, begin with, you do all the filter works in parallel. After those have all completed successfully, then you do your compression work. And after those have completed, that is completed successfully, then you do your upload work. And don't forget to enqueue at the end. So we've talked about all of that, but there's a key concept that I want to cover that's very much related to chaining. This is inputs and outputs. So let's talk about this problem that I have here. It's a MapReduce, and it's really a good way of explaining a MapReduce is to give an example. I love reading. I've loved reading Sherlock Holmes novels since I was a kid. And the other day I was thinking, well, Arthur Conan Doyle has a very specific way of writing. What are the top 10 words he uses in his books? Well, how would I figure that out? I would go through each book, and I would count the occurrence of each word, and then I would combine all of that data and sort it so that I would find the top 10 of those. This is a distributed problem that we could call a MapReduce. And for inputs and outputs, the common unit of operation here is a data. The data is a simple class that's a key value map under the hood. The keys are strings, the values are primitives and strings, and the array versions of each. So this is kind of like a bundle or a parcelable, but it's its own thing. It's serializable by Work Manager, and we limit it to 10 kilobytes in size, and I'll go more into that part later. So how do we create a data? So in Kotlin, you can make a map very easily. So in this case, we're mapping the key file name to the value a steady in scarlet.txt. That's the novel that I'm going to look at. And I'll convert it to a work data. So this is a data object. And once I create my work request builder, I can set the input data on it. So this is the input data of that map. And I pass it along. So inside my worker, I can actually retrieve this input data by just calling the getInputData method. And from that, I can get the string for the file name. So now I have the file name. And I can say, count all the word occurrences in this file name. That's some method that I've written somewhere else. And I can return my success. But you don't want to do just that. You actually want to also have outputs, right? Now you've done all this work. It should do something. There should be an output for it. So let's say that method that we have returns a map of words to their occurrences. We can convert that map to a work data. And we can call a method called setOutputData that sets this data. So getInputData, setOutputData. So the key observation that you need to know here is that the worker's outputs become the inputs for its children. So what happens is the find top 10 words worker, which goes next, its input data is coming from the previous worker. So in this case, you can pass the data all the way through, find the top 10 words, and return out. So the data flow for one book becomes like this. I'll count all the word occurrences in that book. I'll pass it to the find top 10 words worker. Its input data will be whatever I pass through, and it'll do the sorting or whatever it needs to do. But here's a really tricky thing. What happens when you have multiple books? What's the input for the find top 10 words worker? You're passing multiple pieces of data, but I've only been able to get one input data. What happens to the rest of them, or how do they combine? For this, you want to look at input mergers. So input merger is a class that combines data from multiple sources into one data object. And we provide two implementations out of the box: overriding input merger, which is the default, and array creating input merger. You can also create your own. But let's talk about these two. First, overriding input mergers. So we have two data objects here, each with their own keys and values. What does overriding input merger do? It first takes the first piece of data, and it just puts everything in a new data object. So it's an exact copy of this. Then it takes a second piece of data, and it copies it over. So overwriting anything that's the same key. So in this case, the name Alice becomes Bob, and the age of 30 becomes 3 days. Note that it changed type, so a number became a string here. The scores key was new, so it just got added. Note that if we did this in reverse, instead of Bob, you would have Alice as the final output. So this is something a little tricky. You want to make sure that overriding input merger is the right tool for the job, but it is very simple. What about array creating input merger? This is the one that actually takes care of those collision case. So in this case, let's go just key by key. The name becomes an array of Alice and Bob. Color becomes a singleton array of blue because it's only defined in one of them. Scores, notice that there's one integer and one array of integers. These combine and they just concatenate together. Order is not specified, but all the values come through. What happens for age? So there's an integer and there's a string. This is an exception. We do expect it to be the same basic value type. So let's go back to that example I was telling you about Sherlock Holmes. Implicitly, there's an input merger before the stage. So we combine all of that data. And which input merger do we want to use? So we don't want to throw away any of this calculation that we've done. So we actually want to use an array creating input merger, which preserves all of the data and gets it through. So how do we do that? Well, we just say set input merger on the request builder of the find top 10 words. So it merges data using an array creating input merger. So you say begin with the count words workers, then do the find top 10 words worker, and then in queue. So for example, if the first book had 10 instances of the word Sherlock, 5 of Watson and 30 of elementary, and the second one had 12, 15, and 5, you would get arrays like this. Sherlock would be 10, 12, Watson would be 5, 15, elementary would be 35. So in your find top 10 words worker, you would sum all of that up, sort them, find the top 10, and that's your output. And I just said that's your output, right? So you can actually observe the output in your work status using that live data. So you can actually get that output data. So that's super useful because you can display it in your UI. How do you cancel work? So I just decided to send up a picture, but I'm like, wait a sec, this is not the picture I meant to send up. How do you cancel that upload? Very simple, you just say cancel work by ID. But do note that cancellation is best effort. So the work may have already finished. These are all asynchronous things. They may be happening in the background before you've had a chance to do that cancel work. It may already be running or finished. So it's best effort. OK, so let's talk a little bit more about tags. And tags are solving this problem. IDs that I just told you about are auto-generated. They're not human-readable. So they're actually UUIDs under the hood. And you can't really understand them. They're not useful for debugging. If you log them, they're not going to make sense. What kind of work was running? I don't know. It's just some big number. I don't know what that is. Tags solve this issue. Tags are a readable way to identify your work. So tags are developer-specified strings by you, and each work request can have 0 or more tags. You can query and cancel work by tag. Let's look at an example. So I used to work on the G+ team here, and the G+ app supports multi-login. So you can have multiple users logged in at the same time. And each of those users could be doing several kinds of background work. You could be getting favorites. You could be getting preferences. So if you have 3 users logged in on your phone, and they're doing 2 kinds of work, you have 6 things happening. How do you identify what you're looking at any given time? Well, you can use tags. So for example, in this work request builder, you can add tags to say, this is user 1, and this is the get favorites operation. So now you can actually identify that work. And if you wanted to look at the statuses, you could say, give me all of the work for user 1. And this will return a list of work statuses as a live data. Because each tag can correspond to more than 1 work request. So this is a list of work statuses. Similarly, you can also cancel all work by tag. Cancellation is best effort again. But you can cancel all of one particular kind of work in this case. Tags are also useful for a couple of other reasons. Tags namespace your type of work, as I just told you. Like, you can have tags for the kinds of operations you're doing, get favorites, get preferences, etc. But they also namespace libraries and modules. So if you're a library owner or a module owner, you should always tag your work so you can get it later. Let's say that you have a library and you move to a new version of that library in your app. Maybe you want to cancel all the work you had. You can cancel all work by your tag. So always use tags when you are using a library. And work status also has tags available in it. So if you're ever looking at a work status, you can get the tags for that work and see what you yourself called it in the past when you enqueued it. One more thing I wanted to talk about is unique work. So unique work solves a few different problems. But one of the common ones that almost every app has is syncing. You want to sync when you first launch the app. You want to sync maybe every 12 to 24 hours to get the freshest data. And you may also want to sync when your language changes. Maybe you have a version of your data in a different language. So you want to sync at that point, too. So you're doing all this syncing, but you really only want one sync active at a time. You don't want 4 sync operations running. Which one's the right one? Which one wins? You don't know. You just want one. Unique work can solve this. So it is a chain of work can be given a unique name. You can enqueue, query, and cancel using that name, and there can only be one chain of work with that name. Let's take a look at that sync example. So if I say begin unique work with my name, let's say sync in this case, and that next argument is what I call the existing work policy. So if there is work with this name, sync, what should I do with it? In this case, I say keep it. I want to keep the existing work, ignore what I'm doing right now. The next argument is actually your work request, in this case a sync request, and you enqueue it. So if there's work with the name sync already in flight, it will keep that. If there isn't, it will enqueue this and execute it. So this is how you dedupe your syncs. So here at Google, we love chat apps, and maybe you're updating your chat status. So you want to say, I'm bored, and then 10 seconds later, I'm watching TV. Then I'm bored again. OK, I'm going to sleep. And you're in a bad network connection state. You have bad Wi-Fi, and maybe the first thing hasn't gone through when you type your second chat status update. And really, the second one should win, and the third one should win over that. So you want to make sure that the last one wins. How would you solve this? Here's a simple function. You don't even need to read the rest of it. It's the last line that I want you to care about, which is begin unique work. Your name is update status, and you choose the replace option. Replace cancels and deletes any existing in-flight operations of that name. So the last one always does win. In this case, if you have 2 update chat status calls, the last one will win. And finally, I love music. I love the Foo Fighters. I was building a playlist the other day with all their songs. There's a lot of songs. There's like 150 or 200 songs. And I was doing all of this. I was adding a song. I was shuffling 2 songs around. I was moving something to the bottom of the list. I was deleting a song because I had it already somewhere else. These are all things that I want to do using Work Manager, but how would I do that? These things all have to execute in order. And so since the order is important, we provide the ability to use the append existing work policy that says, do this work at the end of the list of update playlist operations. So just append this to the end of this thing. So everything else must successfully execute before this executes. So you can add operations to the end. So existing work policy, as a summary, there's 3 types: keep, replace, and append. A few notes about periodic work. It works very similarly to everything you've seen so far. Just a couple notes on it. So the minimum period length is the same as Job Scheduler. It is 15 minutes. It is still subject to DOS mode and OS background restrictions, just like any of the other work we've talked about. It can't be chained, and it can't have initial delays. And we think that that just sort of makes good API sense. It's much more reasonable to think of it in those terms. All right, so we've talked a lot about code. Let's talk about how it all works under the hood. So you've got a work. You enqueue it. We store it in our database. What happens after that? Well, if the work is eligible for execution, we just send it to the executor right away. By the way, this executor, you can actually specify it, but we do provide one that's default. But let's say that your process gets killed. Well, what happens then? How does it get woken up, and how does this work run again? So if you're on API 23+, we send it to Job Scheduler as well. And Job Scheduler invokes an IPC, wakes up your process. It goes to the same executor, and that's where it runs. If it's an older device, and you use Firebase Job Dispatcher and use our optional dependency, we can send it to Firebase Job Dispatcher. Same thing, invokes an IPC, runs it on that executor. What if you don't have that, or you're not using a Google Play Services device, so you're using something else? We have a custom alarm manager and broadcast receiver implementation. And the same thing, uses an IPC, wakes up your app when the time is right, and runs the job. A couple implementation details. So Job Scheduler and Firebase Job Dispatcher through Google Play Services, they provide central load balancing mechanism for execution. So if every app on your device is trying to run jobs, they'll load balance them. They'll make sure that you're not running too much work on your device and burning up your battery. The Alarm Manager implementation that we have, unfortunately, can't do that because it's only aware of your own app. Of course, newer concepts like content URI triggers, idle, doze mode, et cetera, are only available at the API levels that they were introduced at. So those methods will be marked with requires API with the appropriate API level. We take care of obtaining wake locks when necessary. So especially this is true for the Alarm Manager implementation. Don't take wake locks in your workers. You don't need to do that. We take care of it for you. Finally, let's talk a little bit about testing. You want to test this app. We provide a testing library. It has a synchronous executor. Use Work Manager as normal to enqueue your requests. And we provide a class called Test Driver, which executes enqueued work that has constraints. So we can just pretend that the constraint's been met. Periodic and initial delay triggers are coming soon. We don't have them yet. So if you wanted to look at the code for it, you can initialize the Test Work Manager. You can get the test driver, create and enqueue your work as you normally would with a constraint in this case, and we can tell the test driver, hey, all constraints are met for this work. Your work executes at that point synchronously, and you can verify the state of your app and make sure that everything's right. I also want to talk a little bit about best practices before I end here. It's very important to know when to use Work Manager. Work Manager is for tasks that can survive process death. It can even wake up your app and your app's process to do the work. So for example, it's OK when you want to use it to upload media to a server. It's also OK when you want to parse data and store it in your database. It's not OK for that example I gave earlier. You're extracting the palette color from an image and updating an image view with it, because that's foreground-only work. It's also not OK when you're parsing data and just updating the contents of a view, because you could switch screens, you could go in the background. It's not work that needs to use Work Manager. It doesn't need to survive process death. Also, it's not OK to process payment transactions in it if they care about timing right then. So if you click Buy and you want to update the state of the app, that really needs something else. So that last one needs a foreground service. The other two may just use thread pools or RX. Also, Work Manager is not your data store. Instances of data are limited to 10 kilobytes each when serialized. So data is really meant for light intermediate transportation of information. You can put file URIs or keys to other databases in there if you want. You can put simple information to update your UI. If you want to use a full data store, I would recommend using Room. Yeet would be very happy that I'm saying this. It's an awesome database. Finally, be opportunistic with your work. So here's a filter compress upload example again. The reason that these are not just one big job is because they all have different constraints. So they can execute at different times. Let's say I'm getting on an airplane and I'm uploading a bunch of images and running this chain of work. Well, I go into airplane mode. Maybe I don't have network for the next 12 hours because I'm flying across the world. Well, the other work can still execute, and it should. So if you architect like this, you can do that. This also, by the way, makes your code a little bit more testable, because you can write a test for filtering that isn't conflated with compression and upload. All right, and I want to talk about a few next steps for you. If you need to reach us and talk to us about Work Manager, we are in the Android sandbox, just behind us, I think, over here. d.android.com/arch/work. That's more information on the official developer website about Work Manager. These are all the Gradle dependencies. The first one's a required one. The second one is if you use Firebase Job Dispatcher, also include that. There's a testing library, and of course, we have Kotlin extensions as well. Work Manager is part of the architecture components in Android Jetpack. And we have a bunch of talks here. Tomorrow, Navigation Controller, 8:30 a.m. Hope you guys make it there. And thanks for being part of this talk. We look forward to hearing back from you soon. Thank you.
Accomplished it. Welcome, Sarah. Thanks for joining me.
Thanks for having me. Super excited to be on AI Adventures.
So you wrote a sensational Medium article that I've got open here about your Swift detector, which kind of showcases end-to-end machine learning, from gathering and pre-processing the data to training and serving from Cloud Machine Learning Engine. And there's even Firebase and an iPhone app in the mix.
Lots of different tools.
Yeah, definitely. It's super amazing. What inspired this project?
So I had seen a couple of other blog posts on the TensorFlow Object Detection API, and I've been wanting to try it out. These blog posts did things like detecting pets, whether there was a cat or a dog in an image. I saw another one about detecting raccoons.
Oh, wow.
So then I thought I wanted to try it on my own with some training data that I found. And the easiest thing I thought of was to just look at my Google Photos and find all the pictures of myself.
Right.
To train a model to recognize me. Had lots of selfies, so I had enough training data.
Yeah, and that search function on Google Photos, super helpful.
It's pretty great.
Yeah.
So I trained that model locally. It works pretty well. But I wanted to build an end-to-end demo. And I know a little bit of Swift, so I thought it'd be cool if I built an iOS client to make a prediction request against my model, which made me think, why don't I build a model to detect Taylor Swift? Because why not?
Swift with Swift. Perfect. So it looks like here you're using the TensorFlow Object Detection API to find Taylor Swift in these pictures. Can you talk a little bit about what that is and how you use it? What was it like to use it?
Yeah, sure. So the Object Detection API is some utilities that make it easier to recognize objects in an image. So rather than just classifying an image as this image has a cat in it, it'll return bounding boxes of where that object is in the image. And to do that, it's using a technique called transfer learning, which utilizes a model that's already been trained on a similar classification task using millions and millions of images.
Right.
And then what I do as a developer using the Object Detection API is I take the checkpoints of the second to last layer of that model that's been trained on millions of images, and then I update it with my own data so that I don't need to start from scratch. So I didn't have time to label millions of images of Taylor Swift.
Though I'm sure you wouldn't have minded, right?
I wouldn't have minded.
Going through all those pictures, yeah.
So I just needed to use a smaller set of training data to update the final layer of that model.
It's fantastic that you can kind of stand on the shoulder of giants, all the work and all the training that's already been done on these models.
That's one of the great things about transfer learning.
Yeah. So was the training kind of quicker as a result because you didn't have to go through as many images?
Much faster. So instead of taking maybe days, it took just a couple hours.
Fantastic. Awesome. And then so actually doing the work then, right? I guess you would have had to somehow get the images and do any pre-processing required to have the TensorFlow Object Detection API kind of consume those images, whatever formatting you needed to do, and then actually run the training.
So the Object Detection API requires your images be in what's called a TF record format.
TF record, okay.
And to get them in that format, I converted my images to what's called the Pascal VOC format, which is just one format you can choose from. It stands for Visual Object Classification.
Okay.
And what that is that's an XML file. So I take all my images and I generate this XML file, which gives me details on the bounding box of where the object is.
So that's what's in the XML file. It's just kind of coordinates here of the boxes themselves.
So it has the XY coordinates of where my object is in the image, and then it just has the label associated with that bounding box. In this case, I just have one label, Taylor Swift.
Only need one.
Only need one.
Awesome. So then, let's see, we have our data, it's labeled, and I guess now there's only one thing to do, hit the training.
Yeah, so training is next.
So with all these kind of steps, can you just outline kind of how they all connect together?
Mm-hmm. So I drew the bounding boxes around my images, got them into the Pascal format.
Right.
And then once they're in that format, I wrote a script to convert them to a TF record, which I can then use to feed into my model.
Gotcha. Okay, so all of these kind of steps, now they're all connected.
Mm-hmm.
We've gone from the raw image to a, well, not just a label image, but specifically TF records, so it's even formatted correctly. So now we're ready for our training, I guess, right? And so in this case, we're going to do our training on ML Engine, it looks like, based on your blog post here.
Mm-hmm. Yep.
How was that process, and kind of what did you have to do to make that work?
So it was similar to the process I used for running the training locally.
Mm-hmm.
The main difference being I needed to put all of my data in Google Cloud Storage and tell ML Engine where to find it. So the first thing I needed to get in Google Cloud Storage was the model checkpoints from the pre-trained model I was using. I used a model called MobileNets, which is optimized for mobile, obviously. So I put those checkpoints in my cloud storage bucket. I also needed my training and test TF record files, which I talked about before, how I generated those. And then I have a config file, which tells the object detection API where my training and test data is located. And it supports ML Engine and Google Cloud Storage.
Great. And so that whole thing kind of comes together and I guess just takes care of all the training for you then? Awesome. And how long did that training kind of take? Everyone wants to know, if the training takes a long time or a little time, and how long you had to wait for that.
I think it took about 30 minutes.
30 minutes. Okay, that's
not too
bad.
long.
Yeah. Given what you're getting out of it,
exactly.
That's quite nice. So once training's done, what do you have kind of as your result? What do you have in your hands?
So you have a model checkpoint, which is just a binary file, similar to the pre-trained model checkpoint that I used to start training. This is now going to be the final model checkpoint, which has been updated with all of my training data.
Gotcha. Okay. So that's very nice. And then you, I guess, would now kind of flip it over the wall to the serving side.
So to serve it, I can use a gcloud command with ML Engine to deploy my model. I just need to point it at where those checkpoint files are of my final trained model.
Okay.
And then in just a couple of minutes, I have my model available for serving, and I can use that to generate predictions against the model.
Fantastic. And so I guess this kind of brings us to the next phase of this project. We've gone from our data, we've pre-processed it, we've done the training, and we have this kind of API that can serve up predictions at scale.
Exactly.
So now we're ready to call that endpoint. And what did you end up kind of architecting here? It looks like you have a couple of pieces.
It's using a couple of different Firebase SDKs. So the client is a Swift app. It's an iOS app that's written in Swift, and it's a pretty thin client. So all the client is doing is it's uploading an image to Firebase storage.
Oh, okay. So that's what that arrow is for.
Gotcha. Exactly. And then we're using the Firebase SDK for Cloud Functions. So a function is triggered whenever an image is uploaded to a specific storage bucket.
Ah, very handy.
So the function is written in Node.js, and that function does a bunch of different things. It downloads the image, and then it resizes it. It base64 encodes it, which will prepare it for the ML Engine online prediction request.
Okay.
So I make that prediction request. If the confidence that I get back is greater than 70%, that's just a threshold that I've chosen, I'm going to draw a box around that image.
Okay, so and the box drawing it looks like it's happening here in your Node code.
Yeah, I'm doing that using ImageMagick, which is available in Google Cloud Functions.
Oh, perfect. Yeah, very convenient. And so then once the box is drawn, how do you get that information back to your client then?
So once the box is drawn, I write the image to Firebase storage, and then I also write some metadata on the image to Cloud Firestore, which is a database. So I'm writing the confidence of the detection along with the path of the image in Firebase storage.
Gotcha. So that's why you kind of have these two write operations coming from your Cloud Function.
Exactly. And the reason I'm using Firestore is in my client, I can create a listener on the ID of that image path. And so then I get updates whenever new data has been added to that collection in Firestore.
Oh, perfect.
So I don't have to keep pulling that to see if the detection is finished. So right when it's finished, my client will get an update, and then I can then download the new image with the box around it, along with the confidence detection score.
So that's really neat that you've managed to use the kind of architecture to signal in both directions, right? You upload to cloud storage, and that triggers the Cloud Function. So on upload, something happens and it happens right away. And then coming back, once the response from ML Engine is received, you're using Firestore to basically give that real-time update to hit your phone right away as well. So you kind of keep that loop tight, even though you've managed to do this while all the while maintaining this kind of thin client. That's really nice, that the way you've kind of leveraged the existing technology. You didn't have to write anything to make sure everything happened nice and quick, but async.
Yeah, one thing that's great about Firebase is I get those real-time updates whenever new data comes in with that path.
Fantastic. So I guess zooming out a little bit, you've built the mobile app that builds a custom machine learning model. You collected your data, you annotated it, you're training, and you're serving at scale to your mobile client. What did you find to be kind of the most interesting part of all of this?
I would say definitely learning to tie together all these different tools. So there's a lot of different things I use to build the app from end to end, from TensorFlow object detection to Cloud Machine Learning Engine, which had a couple of different components. It had training, serving, and online prediction. And then the client piece using some Swift SDKs and the Firebase SDK for cloud functions.
Yeah, I mean, just along the way, you're hitting Python, Node, Swift, JavaScript. Oh, JavaScript is there.
Even a little bit of Bash with the G-Cloud commands.
Right. That's right. Outstanding. And so, on the whole, what did you find to be most challenging kind of out of all of this?
The most challenging part was getting all of the data into Google Cloud Storage, because there's a lot of different pieces that needed to be there, from the pre-trained model checkpoints, the TF records, and then that config file, which tells object detection where to find these different pieces.
Right. And these are all coming kind of from different places, and just getting it all arranged. Yeah, I could see how that could be challenging. And I guess, was there some fun parts as well, hopefully, along the way?
It was pretty fun to build. One thing that was kind of funny was, as I labeled all the images myself. So there was a day
Hard
where
work.
I know it was a tough job. So there was a day where I had pictures of Taylor Swift on my computer. People walked by, were probably wondering what I was doing.
Yeah, just perusing photos all day. Right?
Exactly, generating those bounding boxes. And the most fun thing was definitely the final result of seeing on the iOS app the prediction with the bounding box come back in real time.
Definitely, yeah, that's a long journey.
It was.
Awesome. And as I understand, you've actually open sourced your code on GitHub.
Yeah, it's all available on my personal GitHub repo, and there's instructions in the README if you want to build the same model yourself.
Awesome. So that's so great that our audience can go out and build their own model. And I want to thank you so much. Really appreciate you coming in today and chatting in the studio.
Thanks for having me. Great to be here.
Yeah, it's been great. Thanks for watching this episode of Cloud AI Adventures. Today, we saw how to go from raw data to training to a mobile client. You can use Sarah's GitHub repo to not only recreate this, but extend it with your own data, a different model, or a different client app. For more details, we've included links to all the resources we discussed in the description, so check it out. And if you've enjoyed this episode, please like it and subscribe to get more episodes right when they come out.
Let's build a house. We'll have a backyard. Something beautiful, something with a view. Let's build a house just for me and you. I'm coming home. Heating up, yeah, we're burning up. Popping bottle tops, sitting out on the rocks. Watch the water roll, easy breezy go. Till the tide gets too high. Want the sun, want the
Hello, good afternoon. My name is Xavier Ducroy.
And my name is Jérôme Daucher.
So today we're going to talk about what's new in the Android build system since last year. We're going to start with variant-aware dependency management. So it shipped last year in 3.0 in the fall, and the whole concept is that all the variants of a module can depend on matching variants in another module. So debug depends on debug in a library, and release depends on release. And it works well as long as you have matching variants on both sides. But when it doesn't happen, even though we have a DSL to help you fix the problem, but we've seen a lot of developers over the last 6-9 months who just see an error message, like this, and just don't know what to do with it. So we wanted to take a few minutes to explain exactly what's going on and help you solve such a problem. So the first thing to look at is there's this line that says could not resolve project library. So that's the project that publishes artifact that you're trying to consume. And the project that's consuming it is the one that says required by project app. And in the top right section, you can see it says, the name of the configuration that we're trying to resolve, which is staging runtime ClassPass. And it's always the name of the variant, followed by compiler runtime, followed by ClassPass. So here it's the runtime ClassPass. And the error is, unable to find a matching configuration. And so the way it's working really is that the library project is publishing a whole bunch of artifacts for different variants in different configuration, and each of those configurations has attributes associated with it so that Gradle can match it. On the app side, the request has similar attributes, and it's trying to do a mapping, and it needs to find one exact match. And here, it can't find any match. So if we go through those 4 configurations, you can look at all the attributes and basically, by process of elimination, find out what the problem is. So here, the first thing that we see is 2 of them have an API. The API used by compile ClassPass, and the other 2 are runtime. And you can see that the attribute named usage, we request Java runtime, and some of them are using Java API, so they're not compatible, so we can just ignore them. Then we have a few more attributes. There's one here, Android type attribute, that is compatible, so on both sides, so we can just ignore it. It's something that we use internally to match different type of plugin application versus library versus features, so you can just ignore it. The other one, variant attribute, is not required. It's actually never required, and you can just ignore it always. We use that only when we build the model, when we do a studio sync, so you can always ignore it. And then we find the final attribute, which is always incompatible. We ask for staging, and it's finding 2 other values. And the name or type of the attribute here, which is package name.buildType attribute, is the key part. It's basically, hopefully self-explanatory. This is the build type attribute, and we're requesting staging, and it's not finding it. So basically, it means your library does not have the staging build type, and that's why it's failing. So you can create it there, or you can just use the DSL that allows you to create a fallback. So in that case here, in the app, you're saying if staging is not found, just use debug. You have the same exact principle if you have a missing flavor dimension value. Here, the error message is a little bit different because there's multiple flavors potentially, so they're named, tier being the name of the flavor dimension. But that's the same problem, right? It's not finding trial when you're searching for it. And so the fix is basically exactly the same one. You're just assigning matching fallback on the trial one. And you do that on the consuming side, right? On the app side, not the library. Or if it's a library that depends on a library, you put it always on the consuming side. You can have another type of problem. Here, it's saying cannot choose between the following configuration, right? So instead of finding 0 matches, it finds 2 compatible matches. And so it's only going to show the 2 configurations that are matching. It's going to hide all the other ones, so that's a little bit easier. And if you look at it, there's going to be a lot of attributes that are compatible, so you can just ignore them. And then you're down to those 2 here, and it says it found an attribute on the producing side, on the library, but it was not required by the consumer. And so here, basically what's happening is that your library has defined a flavor dimension that is not used or not defined in the app or the consuming module, and therefore it doesn't know how to choose this one. So you can, again, create the flavor dimension in your app or in the consuming module, or you can just go and say, missing dimension strategy, name of the flavor dimension, name of the value, and all it's doing really is just adding that attribute directly to the request so that it's able to match the other one. And you can add this either to the default config, which applies to all your variants. You can apply it to a specific flavor, which will apply only to that flavor, or you can add it to a particular variant.
Thank you. All right, so let's talk about some of the notable changes that we've introduced in the compilation pipeline. The first thing that we have changed lately is AAPT2. And this is a new incremental resource compiler. And compared to AAPT1, AAPT2 is really dividing its work into 2 phases. There is an incremental capable compilation phase where it's changing your resources into a binary format. And then there is a final linking phase where it's going to generate the resource table and the final IDs. Now, if you want to use the latest platform features, you need to use AAPT2. And in theory, AAPT2 is entirely compatible with AAPT1. However, it's a lot stricter. So you might run into issues when you change from AAPT1 to AAPT2. So we have given you a flag so that you can disable if you have issues, but you should be aware that those issues may not be in AAPT2 itself. It may be in your project. So you should file bugs if you find issues with AAPT2, but you should do your homework first. You should look into, well, maybe the problem is in my project. So let's look, maybe you have invalid resources, unreferenced stuff. AAPT2 will catch those. So we're going to phase out AAPT1 pretty soon, so it's really important that you switch and that you file bugs if you still find some. Next thing is dsugar. So this is a tool which is used to remove all the syntactic sugar that was added by Java 8, like lambdas and stuff like that. We've delivered, again, into 2 different versions. So the first version, which shipped with 3.0, was an external process. It used a lot of resource, was pretty slow. Now, with the D8, the new Dexter, we've introduced a newer version where it's integrated inside its pipeline. So it's better, it's faster. Again, we're going to phase out the old version. In theory, you should all be switching to the integrated version. You shouldn't be seeing any difference. If you do, please file a bug. It's most likely our fault this time. It's probably not your fault. But file a bug, because we're going to phase out the old external process version very soon. Talking about Dexter, you should all be using the new D8 compiler right now. It was introduced in 3.0. It's now default in 3.1. If you use DX, if you still use DX because you have errors, translation errors, or runtime errors, you should definitely file bugs. They are extremely responsive at fixing those issues. And again, we're going to be phasing out DX, the old DX, very soon. And we would like you to be still capable of building your applications, so please file bugs. Now, we've just introduced R8, which is a new shrinker obfuscator. But it's a slightly different thing than what it used to be with ProGuard. So ProGuard used to operate on class files. It was transforming class files and making them minified to be ready to be dexed. R8 takes over the entire pipeline from class files to dex files. So that means it's doing dsugar, it's doing minification and dexing, all in one operation, and it can reuse a lot of the data, so it's faster. So when we introduced it, you should try it, and you should see if it works well. Again, please file bugs, because at some point, we will stop supporting the old shrinkers. Maybe not soon, but very midterm, I would say. Now, these are the flags you can use to enable or disable R8 and D8. So please use this if you run into trouble, but please also find bugs, okay? Now let's talk a little bit about performance. We know very well that it is a subject that you are extremely interested in, and so are we. One of the problems we have is that we have a lot of trouble reproducing issues that may happen in the wild. We don't have that many implications internally that we can use. So, however, here is an example using the Nest mobile app. And you can see that a Nest full build has improved about 13% from 3.0 to 3.1 and about 18%, obviously this is not final, with 3.2 versus the 3.01. That's if you keep the same set of features in your application. Obviously, you're not changing the application, just changing the plugin. If you start adding features like Java 8 or Kotlin, things may vary, obviously. Now, if you look a little deeper at performance, things is a little bit more complicated. So in particular, when you look at incremental builds, you can see that Java-C for the full build was about 10 to 15% of the overall build. But when you're an incremental build, it jumps to a really bad 38% of the overall build time. So really, we can see that in incremental scenarios, Java-C compilation is the dominating factor. Why is that? It's because it's not incremental. Why is it not incremental? It's because people are using annotation processors. And so far, they are not incremental capable. So we started a joint effort with Gradle to have incremental annotation processors. It's called InCap. So it's ready. It's been shipped in 4.7. And now we are in the process of trying to move all of Google's annotation processors to be incremental capable. There is an action required from you if you have in-house annotation processors, then you should move them to be in-cap capable to use this library. It's not very complicated. For the simple annotation processors where there's just like one source file and it generates something from one source, doesn't need to see the entire world, it's just adding a few manifest entries, so it's very simple. And that will eventually, if all of your annotation processors are in-cap capable, we'll be able to switch the compilation to be incremental, and that will have a huge impact on the performance of your incremental builds. Thank you. Let's talk a little bit about Jetpack. You've heard about it a lot, so how does it work? Let's just take the first example where we have a pure, you want to move to a pure Android X project. So here you've got your old project, it's using the old COM Android support. What you should do is to use the refactoring tool in Studio to actually move your project to use the new stuff. One of the issues is that we add some dependencies to your project automatically. Say you use legacy multidex, say you use data binding, we're going to add automatically the multidex support library. Now, if you move to a new pure Android X world, where you now suddenly have the Android X constraint layout instead of the old com.support, we need to know that we must use the Android X multidex runtime library so that the two worlds do not collide, right? So we need to have an indication of which one we want to inject. And you need to tell the plugin, this is, through this flag, which of the two versions you want us to use. Okay, so if you want to move to an Android X world, please use this flag. If you are in a hybrid world, which is most likely what's going to happen to most people, so yes, you've moved your application, you moved all your projects to use the new Android X stuff, but you use some external library that you have no control over that still uses the old com.support libraries, you have no choice, you have no control over the sources, so what can you do? So we're going to provide a build-time translation facility that will just basically change automatically the dependency from the old com.Android support to the new one, and will change the library itself by changing all the import statements to the new ones. So this is done locally. It's not like we're going to republish this library, but locally you will be able to have an illusion of a pure world where everybody is depending on the new Android X library. Again, there is a flag, enable Jetifier.
Okay, so let's talk about the app bundle. I'm sure you've heard about the app bundle a lot over the last 2 days. So we're going to tell you a few Gradle specific things. So the first thing is that on the application plugin, not on the library or the feature plugin, but on the application plugin, on top of all the assembled tasks that you see here, we have bundle tasks. And so you'll be able to very quickly, without any change, just go and build a bundle, right? And remember that the bundle is a way to upload that to the Play Store and get out of the box much smaller APKs targeting ABI, density, and languages, for a specific device. So you'll get much smaller install. Locally, you can also build an APK exactly the same way the Play Store does it when it creates those APK. So if you want to verify something, saying, I have a device, I don't want to build an APK directly, I want to build an APK the way the Play Store would create an APK from the bundle, you can do that. So the step is definitely a little bit more involved than directly building the APK, right? We first build a bundle, then we use a tool called Bundle Tool, which is also available as a command line tool to create a zip of all the possible APKs. And then based on a device configuration, we can go and create those APKs. In general, we don't really necessarily want you to create that manually using a Gradle task. However, a lot of Studio and Gradle itself can use that flow when you need it. So for example, the install task, if you have just a basic Android application with no dynamic features, is going to directly build an APK. As soon as you create dynamic features, which we'll talk about in a little bit, then the install task will go through the bundle in order to ensure that we can install that on any device. Because remember, if you have a dynamic feature and you try to install on a pre-L device, so API less than 21, we need to fuse that those APKs together in order to install it. And we don't want to do it a way that's different from the Play Store. We want to do it exactly the same way the Play Store does it. If you try to run tests from the command line calling connected check, it's always going to go directly to the APKs. We're going to work later on adding support to run tests via the bundle in order to simulate better exactly the type of APKs that are created by the Play Store. Deploying from Studio, you have a choice, right? You can either directly deploy APKs, or you can deploy APKs built via the bundle. And here, the run configuration inside Studio has a checkbox that you can check. We recommend to not check it when you do your regular development. As we saw earlier, building a APK from the bundle is much more complicated than building it directly. And on top of that, when you deploy from Studio, we actually look at the device you want to target, and then we inject that information into Gradle, and then Gradle takes some shortcuts. So for example, if you require legacy multidex, which takes a while to build, but you deploy to a device that's 21 or above, we're actually going to use native multidex, which is much faster. We can take that kind of shortcut when we build a bundle. So we recommend to have two different types of run configuration. Just create two of them, one with and one without the option. And then use the APK as often as you can. And only use the other one when you really have to, when you want to try exactly the APK that would be delivered by the Play Store. If you push to a device, again, that's pre-21, then we're going to use that option anyway. And we're always going to go through the bundle as soon as you have dynamic features. So you may already be doing manual multi-APK using that DSL, and also there's a variant API that allows you to compute version code dynamically for all the different APKs that get generated. If you're doing that right now and you want to switch to the bundle, you can just erase all of that DSL. It's completely unnecessary, right? There's nothing to do. All you have to do, you call the bundle task, get your bundle, you're done. And on the server side, we will do all the split by density, ABI, language by default. We do have a DSL to allow you to maybe disable it if you're running into a problem. We expect that there will be very, very few cases where you actually need to do that. But you have the ability if you really have to. If you have that, also file a bug and talk to the Play Store team and see if you can actually solve the problem with them. So I mentioned dynamic feature earlier. So what are dynamic features, right? They're small APKs that are downloaded on demand side by side with your main APK. So if you have a feature that only 10% of our users need, no need to install it for all the other 90%, just have it downloaded on demand. So the way you're going to organize your code is it's a separate sub-project in Gradle. You have a different plugin, a new plugin called Dynamic Feature. And the layout is a little bit different compared to, let's say, a library, right? Normally in a library, your application depends on your library and can refer the code of the library. Here, the features are actually sitting on top and depend on the base. So we can see here the two base feature, the two dynamic feature in blue, apply the plugin dynamic feature, have a dependency on the project app, which is your base one. Now, the base one also have to refer to those dynamic features. It needs to list them because the way we build the, I'll show you later. It's a little bit complicated. It's unusual. But you need to list those dynamic features. And it's just a list of strings, which are the Gradle path of all of your dynamic features. If you used Instant App since last year, it probably looks somewhat similar. You know, Instant App, you have the feature plugin, which is used both for your features and for your base feature, except you have a small flag using base feature equal true. But the base feature also have to refer to all of those features using a slightly different DSL, which is not great and will probably migrate to the dynamic feature version soon. But right now, you do it using the feature configuration. And you know, you probably heard about, you know, that in the future, you'll be able to instant enable your app bundle in order to deliver dynamic apps using the app bundle. And this is why it's going to be possible, because the feature plugin and the dynamic feature plugin are very, very similar. In fact, the application, dynamic feature, and feature plugin share probably over 95% of their code. They are extremely similar. And so if you're already architecturing your app for Instant App, switching to the app bundle would be exactly the same architecture with slightly different plugins. And if you're doing dynamic feature right now, then also enabling that to be done Instant App will be very similar in the future. OK, so you know, I mentioned that bidirectional dependency, where the app bundle needs to know about the base app needs to know about the feature. So if you have those two modules that I had before, if you're building the APK, it just look normal, right? You know, there's a bunch of intermediates in each module, and each output an APK. What happens is that the bundle task belongs to the app bundle, to the app module. And so when you actually build the bundle, we have to publish things from the feature back into the base module, and that's why we need to have all of those dependencies be available on the base module. If you don't add a dynamic feature to your base module, it's just not going to happen. It's not going to show up in your bundle at all.
So when developing dynamic features, it's important to understand there are some differences with traditional Android application building. So in particular, there's some attributes of your application which are invariant, which won't change between the base module and the features. Application ID, version name, version code, all of those should be set in the base module, and we will then publish them back to the features so that they can be used in the task when, for instance, generating the manifest or whatever. So it's important to understand that you set them in the base, you do not repeat them in the features, we will automatically transfer them, okay? Let's talk a little bit about multi-dex. So let's say you're in a multi-dex situation and you're not using any features, but you're still doing the bundle thing. In this case, there's really not much difference. It's the same behavior. The only difference is that instead of shipping stuff into an APK, we are now shipping into a bundle, which eventually gets uploaded. The dynamic delivery will not do much. They will just take these DEX files and store them on the device before execution. So same behavior. If you have feature, still not a lot of difference. Basically, each feature can develop and grow, can become itself a multiple DEX files. Everything gets merged onto the base module, and then you get all packaged inside the bundle again. And you know, same thing as without feature, it gets delivered on the phone, not a big difference. By default, we enable the native multi-dexing. Now, things get a little bit more complicated if your main SDK is below 21. So if it's below 21, we need to have flexibility to still deliver the application in native multi-dex if you are suddenly deploying on a device which is 25. But if you're deploying on 15, now we need to do something specific for that. And what will happen is that the dynamic delivery will fuse all of your DEX files into a single one that will be delivered. So this is important to realize that even if none of your modules, including the base module or your feature modules, if none of them use multi-dexing itself, because we combine those into a single one, this may actually go over the DEX limit, and this may require multi-dexing, okay? So you need to manually enable multi-dex in the base application. And what that will do is basically create the MEMS DEX list that it will ship along with all the DEX files into the bundle. So now the dynamic delivery will take that bundle, and it will be capable that if suddenly you're trying to deploy this bundle on a 15 device, it will use the Mendex list to do the fusing, create the correct Mendex, and then create the extended DEX correctly. All right? Shrinking and obfuscation. So it's the same as before. You set it on the base module, just like the application ID. So you say Minify enabled. This is not a lot of changes. But how we actually implement it is really, really different. So let's go through the motion here. First of all, this is only supported with R8, which is our new shrinker I talked about earlier. So what we do is that we take all the rules that were been defined close to the classes they apply to, so all the rules in the features, we will merge all the rules into a single one. Then we'll take all the class files, we feed this into R8. R8 will create a combined DEX, big DEX files with everything. And then we're going to feed that DEX file into a DEX splitter, which will resplit this DEX for all of the features plus for the base. Right? So it's a very different mechanism as before. Now we have, again, this DEX has been shrinked, it's been obfuscated. Now there's two scenarios possible. Either you're using the bundle or you're using the APKs. If you're using the bundle, it's pretty simple. These DEX files are automatically transferred into the bundle like we saw earlier. If you're using feature, it's slightly different. The DEX files need to be republished back to each of the feature, and then they will be packaged into the APKs. All right, so it's a slightly different mechanism as we must have seen in the past. There's a lot of going back and forth, and that's why we need to have these dependencies between features and app.
Okay, so we wanted to talk a little bit about a few things that are actually not shipping in 3.2. We're working on it. We've been working on it for a while. We expect they will ship soon in a 3.3 Canary, and they have a lot of changes, and so we wanted to kind of like give you a heads up, and also we want feedback as soon as it's available. So I want to talk about the way we process resources right now in the build. So if you have a first library called library 2, in the current flow, what happens is that we're going to process those resources, and we're just going to generate an R.java and nothing else. So when this gets consumed not by another library, library 1, this one may be referencing resources from library 2. And so in order to really validate all those resource references, and also these with some overlay mechanism, we're going to merge those two resource folders into a single resource folder and process it, and then generate another R class. We actually generate two R classes, right? One is for the library itself, which library 1, which contains all the resources from library 1 and library 2. And then we have another one, which is just a new version of the R class generated by library 2 that is used in case you want to run tests and things like that. You need the final ID version of it. So then if that gets consumed by an application, we kind of have to do the same thing again. So we're going to remerge the app and library 1 and library 2 and process all of that. And then we generate the final resource binary format, as well as all the final R classes that are needed by the code from the app, library 1 and library 2. So as you can see, this is not exactly efficient, right? You know, this is probably one of the last things that is very inefficient in the way we build things. The resources from library 2 is basically merged and processed 3 times. We generate a lot of our classes. In fact, we're seeing some project with a few hundred modules generating several thousand R classes, which is too many. And so we really need to solve this. So as I said, we've been working on a new flow, and this is what the new flow looks like. So first, when we compile the library 2, we're going to generate a binary version of resources. And this is because APT2 has that feature. We can't make that work with APT, so that's why Jerome was saying APT2 is going away. AP2 is really the future. We also create the R class, and this time we just generate the R class directly rather than the source code so that we don't have to compile it. That's more efficient. When we depend on it and consume it in library 1, what we're going to do is that we're only going to process the resources of that module. And then we'll use the output of the previous module the same way basically you use a jar during Java-C, right? It's just a compiled class path. It's mostly there to validate, again, resource references, and we generate a new resource package that only contains those resources, not the merge version. There's no merge anymore. And the R class only of that library. Now, that library R class only contains the resources of that library. It does not contain the resource IDs of the previous library and this one. We don't merge those IDs anymore. When an app depends on library 1 and library 2, same exact principle. At the end, we have an additional step because we need to take all those binary and those binary format of the resources and merge it into the final one and create the final R class. So as you can see, we're generating a lot less classes, and also it's a lot more efficient. For example, if I change a resource in library 2 by just editing, let's say, a string, there's no reason that I need to compile library 1 again, right? It's just the list of IDs that I need to check against for reference is exactly the same one. There's been no changes. So we can use the same thing like compilation avoidance that we use for Java-C. And then we don't need to recompile library 1. We don't need to recompile the app as well. All we have to do is do the final link, and that's it. And we can do that also because the R class for the app does not use final IDs anymore. So let's look at some of the impact of that change. So first I said that the R class of each module only contains the resources of that module. It doesn't contain all of them. That means that if you're inside a module, you want to reference another resource from another module, you have to use the R class from that module instead of the R class of your app. That means you're likely to have to import more than one R class, which Kotlin solved easily with type alias. We are looking at ways to also make that work in Java easily because technically there's no reason for the R class to be called R. It could be called whatever else. So each library could define its own name to reduce the amount of conflicts. And again, as I said, the R class IDs are not final anymore, even in the app, similar to inside libraries, which means that you can't use Java switch cases anymore. I mentioned we are not doing resource merger anymore. So if you have a module that redefined a resource already present in a library, that's not going to work anymore. And there's some good reason for that. We definitely want to hear from you if you're using that in a strange way. If what you're doing is, well, in debug in my app, I want to override an icon that's coming from one of my library, you can just use variant-aware dependency management, right? In that library, have a debug version of that icon, and then the app will consume the debug version anyway, which was not the case before 3.0. So that solves that problem. If you have another use case, definitely talk to us because we want to hear about it. So I mentioned namespace, right? I haven't talked about any namespace so far. But when you think about it, I just said we don't have any resource merger or resource overlay. So what happens is your application depends on a third-party library here, or a third-party library here, and both of them declare exactly the same resource with the same name, but with a different value. A string maybe, or layout, or an icon, or something like that. In the past, the resource merger would just pick one of them, basically. The first one that you define in your dependency would have a higher priority, and it would just merge on top of the other one, and it would just replace the other one, which is probably not what you want. And so here, what's happening now is that what we really want to do is we want to package both of them. So both of them are going to be compiled in their own namespace, and then we're going to package that. Internally, the R classes from those two libraries will have the same, r.string.foo, but with different values. And internally in the resource table, they will really point to two different resources, which is much better. So now when you reference to a library, to a resource from a library, you have to use the namespace of that library. And using the R class of that library is already a way to access it via its namespace, right? It's like you don't have a single R class with all the IDs. So when you do that from the manifest, it's a little bit different. You have to use the manifest, when you use that from XML, you have to use the namespace directly in the resources. So @com.library1:string/text, which is very similar to when you access an Android namespace resource, right? @Android:something. If you do have custom attributes, you have to do the same thing. So you're probably using res auto everywhere now, not really bothering what your namespace is. Now you actually have to care. You can say, hey, this is constraint layout. This XML prefix constraint is that namespace of that library, and then I can use those attributes. So we're hoping to bring that in 3.3 Canary. It's going to be opt-in, obviously, some breaking changes. We're going to enable that with a flag. We're going to include refactoring support in Studio so that all those references will be changed for you. And we're going to want a lot of feedback, right? It's not going to be turned on in 3.3 final by default either. There's going to be several revisions where there will be changes and improvement. but we'll want a lot of feedback.
Thank you. OK, last thing we want to talk about today is our public API. We are painfully aware that the public API that we provide is not very good. It has very poor documentation. The plugin DSL is pretty bad. It's not specific to the module type. So there's plenty of things you cannot set in different modules, yet the DSL is still there. There's no mechanism to access the intermediate files. So some people would like to have access to the merge manifest, class files, dex files, you name it. You can't really do it in a nice way. The variant model doesn't give access to a lot of information coming from the variant properties, so you only have access to part of the truth. And then there's just too many things that require internal APIs, hacking tasks, the separation between public and internal APIs is not well defined, so you don't know when you're switching from one to the other. So it's a mess. And to give you an example, this is how the configuration works today, right? So we have the DSL parsing first, and then we create the variant, right? So that bunch of variants are created. Then we create all the tasks for all of these variants. And eventually, we call the variant API. So that's where a lot of the scripts, customization scripts are running. But you can see here, the problem is right there, is right in front of you, that it's happening after the tasks have been created. So there's no way you can change anything that will influence tasks creation. Say you want to switch from legacy multidex to native multidex, but you can't do that anymore because we've already created the tasks for legacy multidex. Say you want to change some of the information in the DSL programmatically instead of putting it in the DSL. Well, you can't really do that either because we already created the tasks, and chances are that the input have already been finalized. So it's happening too late, and then eventually the after evaluate scripts, the custom ones, run even later. So there's really no way you can do a lot of things here. And so what people do is that they access the tasks, and then they try to figure out where the files are generated, and it's a mess. So what we would like to do is to have a simple Gradle API interfaces that would be the only module that you should depend on. And if you start depending on some of our other modules like Gradle Core, you should talk to us and you should tell us what are your needs, why are you doing this? Don't think that we are not listening. We are interested in figuring out why you need to customize things, and we are interested in providing you a good solution. So one of the things we are looking for instance, is to give you access to all of the intermediate files. So each intermediate file really is associated with a type, right? You've got classes, you've got merge manifest, you've got dex files, you've got resources. All of those should be able to be accessed and should be safely capable of being replaced. So you should be able to say, give me the merge manifest, change it a little bit, and I'm giving you back this new version. And that's the one you should use to continue the build process. So it should be replaceable, it should be appendable, maybe you want to add class files directly, and eventually all of this should be done through very well-defined extension points. So we started working on it, and we would like to have feedbacks on this. So the proposed phases would be slightly different. Now you've got the DSL parsing. We would then start invoking your custom code right there. So you would have the ability to start changing DSL objects programmatically, even before we start creating variants. Then we would lock them up. That means you can't change them anymore. Once that code has run, it's locked up. We would then create the variants from this information. From the variant, we can then call directly the variant API. So that's the ability for you to change variant-related information. Now, be aware that this is happening now before the task's creation, right? There's no task created yet. So this is really the ability to say, it was using multidex, now I want it to use legacy multidex. Once these variant API scripts have run, we will lock up the variant object. So again, if you use scripts later on, like in after evaluate, that starts to change the DSL parsing or the variant, it's too late. We will not allow it. We will throw an exception. Then eventually we create the tasks, and we will lock them up immediately. We will not allow you to modify the tasks anymore. The way to modify things will be to go through the buildable artifact, to inject, to replace, to append, but not mocking with the tasks, because we replace them all the time. We merge them, we delete them, we split them, whatever we need to do to support new features or make things more efficient. And then eventually the after evaluate will run. So the compatibility will be a painful subject. We will try to make, obviously, the DSL mostly unchanged. We're going to try to make an effort to also becoming more Kotlin friendly. And unfortunately, we think that the variant API will change heavily. But since we already realized that it was not so great, hopefully you'll be sympathetic to the idea that you will have to change the script using the variant API. So we want to hear from you. It's very important that we get feedback from the community for us. And I want to thank you for coming tonight. I know it's a late session. It was very nice to see so many people here tonight. Thank you.
Thank you.
Heating up, yeah, we're burning up. Popping bottle tops, sitting out on the rocks. Watch the water roll.
It was another great day at Google I/O 2018, and it isn't over yet. Come back at 8:30 p.m. Pacific Time for our live concert with Justice. They'll be debuting their new song, Stop. Tomorrow, we'll be back here at 8:30 a.m. with more sessions, sandbox demos, and special guest interviews. See you back here in 1.5 hours. We'll leave now with Justice's new music video, Stop.